taking you to the COVID unit.
He converted the 10-bedded acute care unit into a state of
Acho que era falar ou não? Ok. Estamos prontos? É em português ou em inglês? Em português, ok. Muito bem. Muito bom dia. Um prazer estar aqui neste segundo dia do Encontro Ciência. Algo que começa a ser uma tradição aqui em Portugal. E hoje temos aqui esta sessão plenária número 4, que é a Ciência em Portugal para uma Europa mais global. E temos a honra de ter a presença de alguns ilustres convidados, o Sr. Ministro de Estado da Economia e da Transição Digital, Dr. Pedro Cisa Vieira. Temos algumas intervenções convidadas, Alexandra Cunha, Joint Nature Conservation Committee, UK. Temos o Miguel Belhão, que é o CEO do Air Center, o Tiago Rebelo, que está via Zoom. Temos o reitor da Universidade de Aga Khan, o Firoz Rasul, o encerramento desta sessão será pelo Sr. Ministro dos Negócios Estrangeiros, por vídeo, o Dr. Augusto Santos Silva. Antes de passar ao Sr. Ministro da Economia, gostaria de dizer que hoje nós vivemos um momento em que a ciência representa uma esperança para o momento que nós todos vivemos, um momento, digamos, de aflição social, e com expectativas todos olham para a ciência para conseguir respostas. E o facto é que, no conforto, quando nós estivemos confinados, desde março, nestes 4, 5, 6 meses, no conforto dos nossos lares, nós vimos substituídos aqueles ícones da televisão mais populares pelos novos atores, que são os nossos cientistas. E projetamos neles a esperança da solução, de arranjarmos uma solução, conseguirmos uma solução para este problema que vivemos e projetarmos, de alguma forma, um futuro em que a ciência hoje tem um papel fundamental na construção do país. Vimos isto e continuamos a ver como os comitês científicos a assessorar os governos, algo inédito. Vemos, como referi, os novos atores nos mídia em que dão confiança às tomadas de decisão política, mas vemos essencialmente isto e a resposta da ciência na expectativa de construirmos uma agenda absolutamente transformadora a nível social para o nosso país e no contexto europeu. E é preciso algumas visões estratégicas para o país e, em particular, para algumas áreas que relacionam a nossa interação como seres humanos com o planeta. Se, de alguma forma, um vírus nos uniu todos em torno da procura de uma solução, é um facto que temos outras soluções para procurar nesta relação instável entre a interação que nós fazemos com o planeta, explorando recursos limitados e que colocamos em causa a nossa sustentabilidade. Eu, como representante e como responsável da Agência Espacial Portuguesa, tenho a dizer que também, no espaço, a essa esperança e a esta solução, e a esta resposta. Diria que a construção, iniciada em 2018, com a Estratégia Nacional para o Espaço, e pragmatizada com a concretização de um projeto já antigo, que é a Agência Espacial Portuguesa, leva-nos a crer que temos as condições numa época e numa era de convergência tecnológica e, se calhar, também de necessidade de procura de novas soluções, novas respostas, construir uma agenda em que o espaço é, com certeza, um dos fatores de resposta que nós precisamos. E olhamos para este setor com alguma perspectiva, alguma esperança de que, aproveitando exatamente este contexto e esta convergência tecnológica, consigamos construir uma agenda industrial, uma agenda de inovação também para o espaço. É importante referir que, no contexto da nossa localização, com este imenso oceano que representa um enorme potencial bloqueado ainda, Portugal deve ter uma resposta concertada a nível internacional e uma resposta em que o espaço e as ferramentas que dele resultam possam constituir também uma perspectiva para o nosso país, colocar-se como uma nação espacial e dar uma resposta também neste setor, combatendo e percebendo eventualmente melhor a interação e a sustentabilidade dos nossos ecossistemas e construindo modelos de previsão. Gostava-vos de deixar esta palavra sobre o espaço, porque representa, entre outros, um dos pilares também da recuperação económica que o nosso país está comprometido. Gostava agora de passar aqui a palavra ao Sr. Ministro de Estado, Dr. César Vieira, para nos dar um pouco, para partilhar os seus pensamentos sobre aquilo que pensa ser a resposta da ciência para estes problemas que nós vivemos atualmente e também, obviamente, num contexto muito mais alargado, o contexto europeu, e ligado, obviamente, ao Plano de Recuperação Económica. Sr. Ministro.
Bom dia. Cumpridas as boas práticas da higienização, eu queria cumprimentar os poucos presentes neste enorme auditório e aqueles outros bastante mais abundantes, creio, que nos acompanham em casa ou à distância. Falar de ciência em Portugal para uma Europa mais global implica colocar essa questão em contexto. Uma Europa global é um conceito absolutamente autoevidente. Eu diria mesmo que a Europa inventou a globalização. E a Europa inventou a globalização quando começou a assentar a sua atividade económica nos ganhos conquistados pela ciência e pela tecnologia. Foi a capacidade de mobilizar conhecimento e de o transportar para atividades económicas e outras que levou a Europa, nos últimos 5 séculos, a conquistar um lugar central e a construir um planeta verdadeiramente globalizado. A partir da idade dos descobrimentos, assentando na ciência do conhecimento dos oceanos, da navegação, do conhecimento e da observação do espaço, da aquisição de conhecimentos cada vez maiores do ponto de vista químico, físico e na sua transposição para a atividade produtiva, a Europa conheceu a capacidade de integrar um planeta que até aí vivia relativamente isolado e de criar um sistema económico verdadeiramente global. A liderança económica global da Europa nunca terá estado tão evidente como no final do século XIX, no início do século XX, quando fomos capazes de, a partir do conhecimento e da ciência que se foi desenvolvendo, transpor isso para tecnologias que transformaram o modo de produzir, que aumentaram brutalmente a capacidade de ter bens físicos à disposição das populações e, nesse aspecto, criar uma era de grande prosperidade, de criação de excedentes que foram reinvestidos na melhoria da vida dos cidadãos. O século XX foi seguramente muito difícil, mas chegámos ao seu final numa situação em que a Europa vivia num contexto praticamente ideal. A liderança tecnológica que tinha atingido permitia-lhe gerar excedentes suficientes para garantir à população europeia níveis de bem-estar que provavelmente nunca foram atingidos na história da humanidade. Qualidade e segurança alimentar e segurança de abastecimento alimentar que ultrapassou as necessidades históricas de alimentar a população, segurança do meio ambiente com qualidade do ar, da água que bebemos e daquela que rejeitamos para o meio ambiente, capacidade de assegurar saúde e educação a toda a população. Todo este nível de bem-estar assentou na liderança tecnológica que a Europa adquiriu ao longo dos séculos. E neste momento, a verdade é que sentimos todos, e isso tem consequências económicas, tem consequências sociais e tem consequências políticas, que a liderança nas novas tecnologias começa a escapar à Europa. Do ponto de vista das novas tecnologias digitais, aqueles que dominam a atividade económica estão do outro lado do Oceano Atlântico e cada vez mais na Ásia. E, nesse sentido, importa à Europa recolocar a questão do seu posicionamento neste sistema económico global. Se não conseguir assegurar a capacidade de produzir bens, conhecimento, bens tangíveis e intangíveis que possam assegurar estes níveis de bem-estar, é toda a concepção da forma como vivemos em sociedade que fica posta em causa. E uma vez mais, só o conhecimento e a ciência podem assegurar à Europa um nível de prosperidade compatível com as aspirações dos seus cidadãos. E, nesse sentido, importa refletir bem de que forma conseguimos traduzir o conhecimento científico que vai continuando a ser produzido na Europa em bens e serviços que possam encontrar uma colocação no mercado e que possam assegurar este nível de bem-estar económico que se traduz depois em bem-estar social, ambiental e mesmo político. E, nesse sentido, é muito importante que, no contexto das circunstâncias em que vivemos, a Europa, para responder a uma crise económica que decorre da pandemia da Covid-19, tenha feito 2 passos absolutamente essenciais. O primeiro passo é perceber que a dimensão desta crise económica exige uma resposta económica que não está ao alcance de qualquer Estado europeu isoladamente considerado. E por isso a decisão mais importante dos últimos tempos é mesmo esta ideia de mobilizar a própria credibilidade, a própria solidez da União Europeia para levantar fundos no mercado que possam sustentar um programa de recuperação económica para todo o continente de uma escala inédita na história da União Europeia. Esse é o primeiro grande passo. Mas o segundo grande passo, praticamente tão crítico como o primeiro, é a ideia de dedicar o investimento que, tornado possível por estes recursos assim mobilizados, para vencer alguns desafios cruciais para a nossa prosperidade futura. Em lugar de pura e simplesmente fazer um programa de estímulo económico que seja orientado para dinamizar a atividade económica, se quiserem, aquela velha receita que o Keynes ilustrava com a ideia de abrir buracos para depois tapar, cria emprego e atividade económica e, por si só, ajuda a sair da crise. A Europa não se limitou a isso. Depois de ter mobilizado os recursos, disse que estes recursos vão ser aplicados em algo que vai ter um estímulo económico imediato, porque dinamiza a atividade económica, mas que vai ser focado na construção da nossa prosperidade futura, investindo em fatores críticos para o nosso bem-estar e a nossa competitividade a prazo. Por um lado, para conseguir compatibilizar esta ideia de crescimento económico com a necessidade de proteger o nosso planeta, a diversidade da vida do nosso planeta e a capacidade de sustentar o nível de recursos que dele extraímos. A transição climática, que há de consagrar 37%, que há de estar consagrado 37% dos recursos do Plano de Recuperação Europeu, visam precisamente assegurar que a forma como vivemos, como consumimos, como produzimos, é compatível com os desafios da neutralidade carbónica em meados deste século. O investimento na transição digital corresponde à compreensão de que, para podermos ser mais eficientes, não apenas na forma como utilizamos os nossos recursos e os reutilizamos, mas também na forma como produzimos para o mercado, exige um investimento muito grande nas tecnologias digitais. Não apenas na adaptação dos nossos sistemas, das nossas empresas, das nossas organizações às tecnologias digitais produzidas por outros, mas na capacidade de desenvolvermos autonomamente na Europa uma nova geração de tecnologias digitais, sobretudo orientadas para a digitalização da indústria. E a terceira nota, também muito significativa, é a de perceber que é à volta da cooperação europeia e na mobilização comum dos recursos humanos, científicos e financeiros que a Europa tem, que haveremos de conseguir dar este passo. Temos, portanto, os recursos. Temos o objetivo, que é de assegurar esta construção da prosperidade futura. E temos a consciência de que o caminho que queremos produzir vai exigir uma imensa captação de conhecimento e a capacidade de, a partir dele, transformar os nossos sistemas económicos. Pensem nisto. Tornar a Europa um continente neutro em emissões de gases com efeitos de estufa em 2050 pode-se fazer de duas maneiras. Ou regressando ao confinamento imediato e à cessação de toda a atividade económica, ou adaptando a forma como produzimos e consumimos os recursos. E este é o caminho que a Europa escolheu traçar. E para esse é necessário conceber, industrializar e distribuir em grande quantidade produtos, tecnologias cuja forma de produção nos permite alcançar este objetivo. E essa mobilização é absolutamente crucial. E aqui voltamos ao papel de Portugal neste contexto. Na nossa economia, no nosso país, a capacidade de colocar o conhecimento ao serviço da economia é mais crítica do que nunca. Trata-se não apenas de participar neste processo europeu de que falava, mas de, ao fazê-lo, darmos um salto significativo na forma como o nosso país se apresenta ao mundo na sua produção. Se quiserem, trata-se da aceleração de um processo que está em curso. Desde há 2 décadas, o país investiu significativamente na modernização e na criação de um sistema científico e tecnológico verdadeiramente moderno, competitivo, aberto ao mundo e cada vez mais capaz de ser avaliado e de concorrer na produção de conhecimento com outros números. Isso também só é possível porque, desde a implantação da democracia, resolvemos investir significativamente na qualificação dos nossos recursos humanos. E tendo ainda um atraso relativamente aos nossos congêneres europeus, podemos dizer com confiança que fomos provavelmente o país que mais progressos fez nestes últimos anos. E a conjugação destes efeitos, investimento na qualificação, investimento no sistema científico e tecnológico, já trouxe resultados tangíveis para a nossa vida económica. Na última década, Portugal cresceu muito significativamente o valor das suas exportações, cresceu sobretudo diversificando os produtos e bens e serviços que exporta, cresceu porque os produtos que exporta são cada vez mais tecnologicamente complexos e, por isso, geram mais valor para os seus produtores, e esse percurso é aquele que devemos de prosseguir. E o desafio que eu lanço num encontro com a ciência e a tecnologia em Portugal, como Ministro da Economia, é que sejamos capazes agora de dar o próximo e decisivo passo. É conseguir aquilo que, na verdade, mais crítico é nesta altura. É a capacidade de traduzir este conhecimento em processos e produtos que transformem a forma como Portugal se especializa economicamente. É estar verdadeiramente próximo das nossas empresas. É articular e investir naquelas instituições que fazem o interface entre a produção de conhecimento e a produção de bens e serviços para o mercado. As nossas empresas são francamente inovadoras. Aliás, se Portugal se qualifica tão bem no Innovation Scoreboard da União Europeia, como país fortemente inovador, pela primeira vez o ano passado, tal se deve, sobretudo, à percentagem de pequenas e médias empresas inovadoras. Elas estão disponíveis para mudar processos, para desenvolver produto. Mas precisamos mesmo que todo o nosso sistema científico e tecnológico se prepare para duas coisas. Uma é falar mais de perto com o nosso tecido empresarial. Resolver problemas concretos em termos de produto, em termos de processo e colocar a capacidade e as competências desenvolvidas ao serviço de respostas concretas para chegar ao mercado. Transformar aquilo que se percebe em produto. Ou então ajudar as empresas a resolver problemas com que se confrontam. E esta proximidade é crítica. A segunda nota, obviamente, é também fazê-lo num contexto cada vez de maior abertura e cooperação internacional. Sabemos que a capacidade de cooperarmos com outras instituições é a forma de progredir na inovação hoje em dia. E, por isso, seriam esses os dois desafios que eu lançava à comunidade científica e tecnológica. Nós estamos num continente, numa união política que corresponde ao maior mercado do mundo, que corresponde também aos países onde os níveis de produtividade mais elevados são. Queremos preservar os níveis de bem-estar que a Europa tem proporcionado aos seus concidadãos. Temos os recursos necessários para alinhar agora esses objetivos de longo prazo com as competências e capacidades que temos. Em Portugal podemos ser protagonistas. Esse protagonismo agora depende cada vez mais de falar de perto e de responder às necessidades do mercado. E como Ministro da Economia, estarei sempre a interpelar a comunidade científica e tecnológica no nosso país para que se coloquem verdadeiramente ao serviço do nosso tecido empresarial. É nas respostas concretas que forem capazes de dar aos problemas que as empresas se colocam, é na capacidade que tiverem de ter a curiosidade para os problemas que no dia-a-dia elas identificam, que seremos capazes de dar mais um salto neste processo. Muito obrigado a todos e muito bom trabalho. Bom dia.
Muito obrigado, Sr. Ministro. Dar simplesmente aqui, eventualmente, uma nota. Portanto, Portugal inovador, traduzir este conhecimento em capacidade tecnológica e colocá-lo ao serviço da economia. I think now we should switch to English, because we have now some interventions from our panelists. I will ask for Alexandra Cunha. I think she will join us by Zoom, right? Alexandra Cunha belongs to the Joint Nature Conservation Committee in UK. So I think, Alexandra, I know you are there. Okay. Hello, Alexandra. Floor is yours.
Thank you. Good morning, dear colleagues and participants. I can't see how many participants are in this plenary session, but I hope everyone is in good spirits and with a hot tea or coffee in hand. I would like to start by acknowledging the Science 2020 Organizing Committee for inviting me to participate in the conference and send my apologies for not being able to be there in person. As you can imagine, I would have loved to be in Lisbon at the conference center and meeting everyone in person. I also would like to say that the views expressed here today are my own and not my employer, JNCC. After I realized the topic of my plenary session was science in Portugal for a more global Europe, I panicked. My science expertise is very specific and is all about seagrass ecology, nature conservation, and marine protected areas. So how could I possibly contribute with any ideas to such a tremendous task? So I decided to ask some colleagues for help. After our mean brainstorming session, the word came out. Whatever you want to speak about, Alexandra, do it with passion. Well, my passion are seagrasses, and nobody here wants to hear me speaking about seagrasses today. So I thought I would reflect on my own experience and the process of becoming a scientist in Portugal and in Europe. What worked well and what could have worked better. And what I want to do today is to share with you some ideas that I think could help promote the Portuguese scientists in Europe. Some of these ideas are not new, and I recognize that a tremendous effort has already been made in Portugal, with many research centers hosting and networking with the best research centers in Europe. At present, scientists in Europe and all over the world face a tremendous challenge. Our word has been mistrusted and often twisted. An example of these has been the global disbelief about the human impact on climate change, and now we are experiencing it again with COVID-19 and the pandemic. We have seen scientific advice being ignored over and over by decision makers, science being politicized and not reaching the public the way it should. We have seen scientists struggling to put together enough good evidence and communicate it properly. We need to make people trust in the science community, and we scientists need to be more confident in our role in benefiting society. So, what can we do in Portugal to get into a better position? I think we need to improve the way we train scientists in Portugal. I know that with the implementation of the Bologna program, the way scientists are trained in Portugal is changing, but we need to do better. I thought about my own experience growing as a scientist. I'm very grateful for having had the most inspiring teachers at school and professors at uni. I was delivered the most comprehensive and the best quality information about the mysteries of biology while studying at Portuguese universities. And that was the kind of education that allowed me to shine while doing my PhD in an American university. Yet, I was not prepared to start working and enter the labor market, including academia. Nobody taught me how to use science to get an impact in society and ultimately change the world for better. I think a key point to promote science in Portugal into going more global is to accelerate a change in teaching paradigm at universities. We need to give scientists more tools to get them ready to start working when they finish uni. We need to teach maybe less content and deliver more behavior, competency-based learning. We need to empower students and they need to finish their training more confident they can do a job. For example, we need more training at project and people management while at school. Most of us scientists had to manage projects, European projects and FCT projects included, without any previous formal project management training. And it was not easy, to say the least. Young scientists need to have proper access to personal development, career strategy, and coaching programs. Having studied and worked abroad, I found a staggering difference between my colleagues at work in England and when I had to recruit for projects while in Portugal. I'm always in awe when I see my young colleagues just recently coming out of English universities and so ready to dive into large pieces of work with all confidence. Portugal needs to provide proper training in science communication and influencing if we want to make an impact and to be heard. Science funders in Portugal need to support more citizen science programs. There are good examples of citizen science projects in Portugal, which shows that the Portuguese society is hungry for information and collaboration opportunities. But abroad, I see another level of society engagement, and the numbers of people participating in citizen science projects is enormous. A lot of the projects I've seen have thousands of people gathering the most diverse information and data to feed databases and form the basis of solid evidence. And this takes me to the next topic. Portugal could invest more in data gathering, organizing and managing data to support decisions and solid expertise judgment. The use of strong evidence is paramount to the way scientific advice is delivered and perceived. We need clear and transparent information to engage with decision makers and have their support and trust. In Europe, there's a growing hunger for scientific evidence and well-managed data hubs, and Portugal could develop that area of expertise. Funders, research foundations, and governments need to invest more in evidence gathering, data management and quality assessment, and staff training. Evidence databases are fundamental, and yet is a large shortage for funding for it in Portugal. Not only funding the creation of databases, training scientists and paying people to manage those databases. And speaking about money, it is important that scientists have access to proper careers. If science is to go more European, Portugal needs to look deeper at the scientific human fabric and support scientist workers. Scientists need to have access to a career, to personal development opportunities, to a healthy family work balance, and to a fair and behavior competency-based performance assessment. In previous sessions this week, I heard that not all PhD holders will find jobs in academia, and I certainly agree, we are not all fit for academia. We need more business hiring scientists, but also government bodies. But we need to train scientists better for that kind of jobs, and also show business owners and government bodies how scientists can help them do a better job. I also heard Portugal is good at doing omelets without eggs. I say we could do much better omelets if we actually had the eggs, as all scientists working abroad can attest. In summary, my 2 pence for a road book on how to make science in Portugal more ready to go global are change aspects of scientific training, making scientists more ready for the labor market by focusing on a wider set of behavior competencies, not only the content, supporting more and better training in science communication, promote large and sustainable in time citizen science projects, fund evidence gathering and the creation of databases so scientists can use it to provide advice and solid evidence. And finally, Portugal needs to nurture their scientists and boost their morale if a greater impact in Europe's science is the aim. Thank you so much for your attention and have a lovely day.
Thank you, Alexandra. So I will just make some notes about Alexandra's presentations. And I took my notes here. Tremendous efforts has been done in science in Portugal. Also, the ignorance of the decision makers for the evidences presented by the scientific community. Key point to promote science in BT is the training in science communication. And one note that I took that will bridge the intervention from Miguel Bellot, investing in data gathering and training, a scientific database. So Miguel, this is your turn now. Miguel Bellot is the Air Center CEO. And I start to tease you, Miguel, about this remark that Alexandra did about to have more data, to have more knowledge. So how the Air Center we will contribute for that.
Thank you, Ricardo. Well, thank you very much. Thank you for this kind invitation. Good morning, everybody. I got a presentation. I will deal about this topic, but in my presentation, I will discuss some key enablers to make more global Portuguese science, how Portugal can help to make a more global Europe. We identified different topics like address global issues, multidisciplinary approach, international collaboration was also stressed by the Minister of Economy, artificial intelligence and data science. But I want to be practical, not be theoretical. Then I want to present 3 particular cases of global problems where Portugal is already, Portuguese science and technology is already playing an important role trying to solve this problem. In the short term, on the COVID, in a mid-term, climate change, and in a long-term, asteroid impact. I want to go to see how Portugal is contributing to those 3 problems, and then I would like to end with some conclusions. Well, the question we have today in this panel is how science in Portugal may contribute towards a more global Europe. And we can turn this question, as Professor Elena Cañao did, is that how we can make the Portuguese science more global. And for that, as I said before, first, we should tackle global issues. We should tackle global problems. There are global issues. There is more and more interconnected activities. Those global problems cannot be addressed with a single discipline. We need a multidisciplinary approach. For instance, for climate change, we have to combine atmospheric science with geophysics, with space, with oceanography. The same way that a single discipline cannot solve this problem, a single country cannot do it. We need international collaboration, was stressed by the Minister of Economy. And international collaboration is one of the key aspects of the Air Center. I'm the CEO of the Air Center, and we are joining 15 countries along the Atlantic to deal with all this problem. And this international collaboration is a key issue to make the Portuguese science more global. And then artificial intelligence and data sciences. We are collecting a lot of data. We have to collect more data. And the combination of this data with artificial intelligence is a key enabler to generate new products and services. Was also mentioned by the Minister of Economy. He put 2 challenges to the Portuguese science and technology: to be able to generate new products and services and to be in international collaboration. Both things can be dealt with those combination of Earth observation data with artificial intelligence. But let's go to the 3 examples. I want to go to those 3 examples to see how Portugal is already, in many aspects, global in science and technology. let's go to the short term. In the very short term, we only have one challenge, is the COVID. This is the short-term challenge, and Portugal already have good answers to this. We have to stress, for instance, the project of the respirator did by SEIA at University of Minho. This is a unique case where in 45 days, new product was generated, and this product was made global, because this product was sold to Brazil, Angola, Mozambique, and other countries. I mean, Portugal is already global on that, and we have to put this emphasis. Also, at the Air Center, we generate a new project called COVID Observatory, and by using data from the Sentinels, we did a daily update of the water quality, the air quality during the pandemic. I mean, there are already some important global contribution to Portuguese industry and, science and technology to this problem. Let's go to the second, to the midterm. In the midterm, the main problem we face is climate change. COVID is an eclipse. It's eclipsing the problem we were dealing, which is climate change and all the related effects. We have extreme weather events, we have sea level rise, we have a loss of biodiversity, we have ocean acidification. All those are real problems that we have to face in the midterm. And also Portugal is very active in that. Portugal is very active because what we need is to check and to have a complete observation of the Earth. The European Union launched the Green Deal to tackle this problem. And within the Green Deal, there is a project by European Union and European Space Agency, which is called Digital Twin Earth. Digital Twin Earth is to get a model in virtual of the behavior of the Earth, a complete model. We better call it Digital Twin Ocean, because the biggest part of the planet is ocean. This Digital Twin Earth is going to be a tool. It's going to be a tool for policymakers to take decisions, but it's also a tool to generate new products and services, as the minister said this morning. And Portugal is already very active there. It's already very active in different lines. I mean, the Portuguese Space Agency, led by Ricardo, they have one of the 4 main priorities is the digital planet, to promote the use of Earth observation for day-to-day application. This is very close to the citizen. This is the way to improve the life of the citizen with this Digital Planet project. In addition, in collaboration with the Portugal Space Agency, the Air Center, we are promoting a constellation of satellites called the Atlantic Constellation. This is a constellation of satellites to monitor with an unprecedented frequency the health of our oceans. This will help for the Digital Twin Earth, and that will help to collect all these data that we need, which deal later on with artificial intelligence can give solutions for fisheries, for coastal erosion, for aquaculture. And this is done. Those global views, it's very much pushed forward by Portugal, which we are in a unique situation because, you know, Portugal is now co-president of the European Space Agency. Portugal will lead the European Union with the president next year, and Portugal will be also president of Eureka, the largest innovation network with nearly 50 countries. And those global challenges will be priority and will put Portugal in a leading role in this global issue, will helping Europe and Portugal to be more global. And we also look to long term to talk to a new topic. In the long term, what challenges we're facing? There is a challenge which is there, and which is a possible asteroid impact with the Earth. This is a long-term issue which may happen, but is this a real problem, or this is just an excuse for Hollywood movies? And well, in fact, it's a real problem. If you look to I don't know if the laser works, but I'm colorblind like Ricardo. I think I'm very bad to do. But you look to the graph on the top on the right. How many asteroids could collide with the Earth? Of the order of 10 kilometers, a dozen. Those is the one who killed dinosaurs. It was about 16 kilometers size. It's about a dozen. But if you go to 1 kilometer, it's already 1,000. If you go to a few hundred meters, we have 100,000 asteroids of about 300 meters. We call it city killers. Why city killers? Because the effect of this impact is 1,000 megatons. Will destroy a city like New York and will create casualties of the order of a few million. And this is the problem because the big one, we know them, but those one, only 5% are known. 95% is unknown. And a smaller one of the order of 15 meters, there are millions. How frequent they impact the Earth? Those smaller ones, every day. Every day, small asteroids fall down on the Earth. There are a few meters. Those are, in summer, these meteors. We have shower of meteors. this is not a real problem. There is only an indirect risk. In the Cold War between the USSR and the United States, there were spy satellites detecting nuclear missile launches. And those meteors could be confused with a missile launch. And in fact, we were twice about to start a nuclear war because of those meteors. But in fact, per se, this is not a problem for us. The problem is when we go to higher sizes. In fact, this is the effect. If we go to 50 to 300 meters, it is something will happen 250 years. And it's an event like Tunguska. Tunguska is the last big one which fell down in 1908, about 100 years ago. Tunguska is in Siberia. Fortunately, it was a not populated area. Only 2 people died because it was completely isolated area. If that would be in a big city, we'll be talking about different figures. But this is today the most worrying one. But if you go to higher sizes, for instance, for more than 10 kilometers, 6 billion casualties because whole life on Earth could be lost. Fortunately, that happens only once every 100 million. This is not very frequent. There are some proof of that. This is the Barrington crater in Arizona. Those are craters in Canada. 100 of asteroids impact the Earth. This is the list of the well-known. There is one in China in 1490 with about 10,000 people killed. And 65 million years ago was the dinosaur one. Then the question is not if an asteroid will impact the Earth. The question is, when is the next one and how big it is? This is the main question. Well, in our files, the most dangerous we envisage is called Apophis. Apophis is the god of the chaos, and Apophis was discovered recently. When it was discovered, there was a probability to kick the Earth in 2029. It's a 300-meter size, 20 million tons. It would impact a 50,000 kilometers per hour, generating a power of 1,000 megatons. New observations demonstrate that it will not impact the Earth in 2029. It will pass at a distance of 20,000 kilometers. 20,000 kilometers is very small. It's half the distance of the geostationary satellites. And there is an ellipse of error. This ellipse of error, it is depicted there, is very elongated. There are some places in this ellipse that we call keyhole. If the asteroid passes by this keyhole, because it will get in resonance, will come back every 7 years close to the Earth. If passed by this keyhole, will impact the Earth in 2036. The probability is 1 in 50,000. It's very low. It's not going to happen. But there are lotteries. The Christmas lottery, the probability to win is 1 in 100,000. If people play the lottery, I mean, we should avoid to play this lottery. This is the negative lottery we don't want to play. That means we need solution. We need science and technological solution for this problem. And Portugal is active in this. A Portuguese team, together with Swiss, France, Italy, and Spain, proposed a project to mitigate this. But let's have a look to what are the science solutions for that. There are different solutions. There is an instantaneous solution, there are long-term solutions, and other funny solutions. Instantaneous, the US preferred, the America preferred is an explosion. It's a nuclear bomb, a nuclear weapon. The European solution proposed by Portugal is a kinetic impact. Is to impact with a probe, with a spacecraft of about 100 kilos to move it. Why we don't like the explosions? First of all, launchers are very reliable, but still 3% of the launcher fail. If you put in Cape Canaveral, close to Miami, a nuclear bomb, and there's a 3% of probability to fail, to solve a problem of 1 in 50,000, the statistic doesn't work. Second, if you destroy the asteroid, you may create many small impacts. You may create grenade, kind of a bigger problem than the one you want to solve. That's why Europe and Portugal prefer the second solution, a kinetic impact, to impact and then move the trajectory, to deflect the asteroid. There are other solutions. There are put an electric engine on that with low thrust, put a solar sail, deploy a solar sail, and the solar wind will move it. There is another one, which is an ion beam laser system. The funniest one is the one proposed by Russia. The Russian professor Ivaskin is a well-known asteroid expert, proposed to paint the asteroid. If you paint the asteroid totally black or totally white, the effect of the sun photons move the trajectory with the Jarkovsky effect. That means just by painting, you can avoid that. Which is the problem of this long term? Is that you need 20 years to deflect. While the instantaneous, you may detect the asteroid too late, and you have no time to go to this one. Then kinetic impact is the most important one. Europe made a competition some years ago for ideas, how to deflect an asteroid. This competition was won by a team, as I said, where Portugal has a role together with Spain, Italy, Swiss, and France, and was a project called Don Quixote. The idea is to learn to deflect asteroids. You have to learn. The question is, the first time you have to deflect is not the first time you do it. You need to make exercises. And the exercise was two probes. There are two probes launched together from the Earth, go back to the Earth 6 months later. One is called Sancho, the other one is called Hidalgo. Then the first one make a flyby of the Earth and go directly to the asteroids. Orbit the asteroids and characterize it, gravity field, nutation, rotation, compact. And the second one is sent to Venus. Venus, with a flyby of Venus, you get high velocity and you impact the asteroids at a very high velocity. And then the other one get back and measures the deflection. Our calculation, the one done by the scientists, is that with a 500 kilograms spacecraft, you can deflect 50 micron per second a big asteroid. This is all you need. Only 50 micron per second you have to deflect to have it done. This is how the orbit around asteroid looks like. This is Tutatis. This is a real asteroid. And there is, the scientists, when you impact the asteroid, there is a big crater, and a big mass will be ejected. This multiplies the effect of the impact kinetic change. If asteroid would be a billiard ball, there is an easy way to calculate. It's a physics problem of high school, but this mass ejected multiplies by factor beta. Scientists think that this beta factor can be 10, but this factor is a key calculation that we need to do in this type of projects. Okay, I would like to finish with a vignette I found in the press. This is a Congress of dinosaurs. It is, the speaker says, the frequency of a dinosaur killer impact is about 1 every 100 million years. And then in the audience, one said to the other, so why should we worry? Well, as conclusion, we firmly believe that to make Portugal more global and Europe more global, we need to deal with those global challenges in an international collaboration, in a multidisciplinary approach. And I just said, the role of Earth observation data combined with artificial intelligence and data science is going to be crucial for what I said before, to create products and services and to try to deal with these global challenges. Portugal is already global. I mean, it's already playing a critical role in global problems like COVID, like climate change, or like asteroid impact. I mean, we are already there, but we have to continue this line to take the challenges put by the Minister of Economy this morning, to make products and services and to be international. I would like to finish with an optimistic message. It's nothing more optimistic than Stephen Hawking. He said, we are just an advanced breed of monkeys on a minor planet of a very average star, but we can understand the universe, and that makes us very special. Thank you.
Thank you, Miguel. There are other dimensions, and this also the space debris. This is one of the topics that we, Portugal, we are also involved with, and of course with the knowledge and some programs together with the European Space Agency. So I wrote also here some notes, some remarks, some conclusions, Miguel. Space has the solutions to know more about our planet, our oceans, and interactions with our planets. Also the answers of space to planetary defense and the importance of the data science to improve our knowledge. Now, I think we have Tiago Rebelo. Tiago is a director of a department of CEIA, research center in Matosinhos, north. So I think Tiago will join us by Zoom, right? Mm-hmm. Okay, welcome, Tiago.
Hello,
so you have the floor, please.
Okay, thank you very much, Ricardo. Thank you for the kind introduction. First of all, good morning to everyone, which is there in the auditorium, but also to everyone which is listening at home. Welcome remark to my dear colleagues for this panel, and my apologies for not being able to join you there in Lisbon. Well, it's the times that we are living, and we need to accommodate it. And it's a good example how technology is disrupting and is making us all global, and diminishing the gap between ourselves. So first of all, I should start by saying that I'm absolutely astonished by the previous presentations. Miguel is absolutely right. We are already contributing to a global Europe from Portugal, and I'll try to address that in my presentation as well. But Alexandra previously has also mentioned something which I loved, which is we need to take care of our resources, and our resources, the best we have is our people. And I think for that, we need to generate the conditions. And the conditions, I'm not talking about salaries only, I'm talking about challenges. And for challenges, we need to work all together to face those challenges, which can be societal, which can be coming from outer places like the asteroid impact that Miguel was mentioning. So I've divided my brief presentation, and I'll try to stick with the 15 minutes in three main topics. One, what is SAIA and what's our role? And our role here, and the role of institutions like SAIA in bridging the gap between science, knowledge, and industry and economic value. And afterwards, I'll try to give a few examples on how I believe we are already, and by we, I mean our country, is already contributing in quite some areas to making Europe more global, and to really develop products and services which have a knowledge base, but really have an economic impact down the road. And third, and at last, I think we don't need recipes on how to deal with a post-pandemic world, but everyone has its views, and we have our views on how shall we face the opportunities that lie ahead of us, because there are opportunities. And the Minister of Economy this morning just mentioned the great initiative from Europe, which we as a country will have to take the challenge, we'll have to take the endeavor, and we'll have to organize ourselves, and we'll have to face the fact that we'll need to work like we never did before. We'll need to work together like we never did before. So I'll try to address these three topics: SAIA, a few examples, and then a few keywords on how to deal with a post-pandemic world. So, but very briefly, SAIA is an innovation center, is an engineering center. We have more than 20 years of existence. We are one of the highest investors in the country in research and development. We have projects deployed across 10 countries. We have around 300 engineers, and we are up today the biggest employer of aerospace engineers here in the country. We have our headquarters in Porto, but we also have offices in Évora near the aeronautical cluster, and also in Brazil and in other parts of Europe. We work mainly in five different areas. We try to face, let's say, social, technology, and economic challenges from the perspective of these five different markets: the automotive, the mobility, the aeronautics, the ocean, and space. But there is one key word that lies in between all of this, which is sustainability. And sustainability is a word that perhaps is becoming too popular in the sense that everyone is using it. But when I talk about sustainability, I'm not only talking about the environment, I'm not only talking about our oceans, I'm not only talking about our planet, but I'm also talking about social sustainability and economic sustainability. So when we look at these five different areas, obviously we need to go carbon neutral, obviously we need to make our industries more competitive, but there is a trade-off. We cannot do one without the other, and certainly we cannot have both tomorrow, but we need to work towards it. So sustainability is what's common to all these five different areas. Then our role, even though quite simple to explain, is very difficult to actually do it. And our role is to bridge the gap between academia, between research centers, between science and knowledge with industry. And it's not the journey is not only from science and knowledge to industry. It's also a journey that starts with challenges from industry. So it's not only science that needs to get close to industry, like we normally say, it's also industry that needs to get close to science. It's the industry that needs to understand as well that science is only a benefit. Knowledge is only something that can make our products and services better, and it's only something that can make our economy a more knowledge-based one with much more added value. So very simply, what we try to do is to lay in between research. We try to perform development and technology integration. We do a lot of engineering and product development, and then we partner with spin-off. We have startups for the industrialization of the commercialization. But the gap is really not only left to right, it's also right to left. It's also industry to science and science to industry. So I'll give you three examples on how scientific challenges and partnerships with universities and R&D centers generated products, which are now on the market and are now being deployed, but also 3 examples on how industry has challenged us and the academia and the science to make their products better and to help or develop their products. And then I'll have one last example, which is, and Miguel already mentioned, which is an example on how we have all together replied to a national emergency, to a global emergency, which was the COVID-19 pandemic, and how we developed this respirator, this ventilator in 45 days. So, first example, we were challenged a few years back by University of Azores and by a few marine biologists that wanted to monitor big marine animals. And they wanted to do it like no one has ever done it before. They wanted to do it in a non-invasive way, so they didn't want to hurt the animals. They wanted to do it without interfering with that behavior. And they wanted not only to monitor the animals, but also to monitor the ecosystem. And to monitor the ecosystem means to monitor the ocean, its acidification, its O2 presence, salinity, etc., etc. So more than just retrieving knowledge from the animals, we are actually using the animals as data mules. We are using the animals to collect data for us. And what we did is we developed this reusable marine tags, which is basically the red thing that you are seeing in the middle of the screen, which can go up to 2 kilometers depth, and which basically do their mission in a full passive way. They are attached to the animal in a non-invasive way. For the animal, it's like a fly on a horse. It doesn't feel it, doesn't know it's there. There is no alteration to its behavior. And when its mission ends, it comes to the surface, it communicates with the satellite, and it's retrieved. And as of today, I can say that most of the scientific documentaries that we are seeing in our televisions, from BBC, from National Geographic, is being recorded with these tags, is being recorded with 4K cameras, which are included on these small devices, and that we are selling for the niche market, not only for scientists and for the sake of knowledge, but also for ocean literacy. And we are getting images and information that we could never have retrieved all the way. And this was a scientific challenge. It came from a scientist, and the engineers and the people that worked the technology made it so that it could work. And this is already a contribute towards, I would say, a more global Europe in a very niche market, but one that is very interesting because, to be fair, we know more about the moon than we know about the bottom of our oceans. And this is something that we need to change. And Miguel also mentioned the digital Twin Earth project. I believe it's really about knowing more about our ocean, as most of our land, of our Earth is ocean. The second example, it's about autonomous vehicles. And autonomous vehicles, I could have mentioned drones and their role in monitoring the territory, or making agriculture smarter, or monitoring our oceans and dealing with piracy, etc., etc. But I've decided not to talk about drones, but to talk about autonomous surface vehicles, because there are multiple means on how to monitor the ocean, and definitely one can be satellites and Earth observation, and I'll mention that down the road. The other is in situ observation, and in situ observation also means on the water. It means on the water. If today we are already flying drones for most of our missions and monitoring the Earth and monitoring the different applications from the air, we need to start doing the same with vehicles in the ocean, with vehicles in the water. And this is one example of an autonomous surface vehicle that it's really dealing with bathymetry collection and data collection at the ocean bottom. And it's a fully electric vehicle, fully autonomous vehicle. And again, it came out of a challenge, which is at the intersection between science and industrial needs. Now, the third one, and the minister mentioned the fact that Europe needs to become carbon neutral, and Portugal is ahead of that challenge, I should say, because we were one of the first countries in the world to have a charging electric grid, which started a few years back with the MOBI-E project, which then evolved, and multiple companies, including FASEP, built a huge repository of products coming from that opportunity. But I believe that we need now to change from mobility management to sustainability management. So mobility is what we do when we need to get from place A to place B. But we are only going to go more green and to really change behaviors if we incentivize behavior changing. So what are we doing these days is we are basically putting a value on carbon, and if you are emitting too much carbon, you need to pay for it. Well, our concept is slightly different. If you are saving carbon, if you are sparing CO2 by making a green choice, if I'm walking, if I'm taking an electric car, if I'm taking an electric bike, if I take a bus instead of driving my diesel car, then I should be reimbursed. I should have a value on that. So we developed the AIR. The AIR is a sustainability platform which is already in place, for example, in the city of Cascais, where we are giving prizes to citizens which have sustainable behaviors. And with that, we not only control the entire mobility grid, but we also incentivize decarbonization. We also incentivize green movements. And finally, 3 examples on industry challenging science. 1, a pilot offshore underwater aquaculture for growing salmon in the middle of the Atlantic. This is a challenge that came from industry, from a big retail group here in Portugal, which basically understood that it would be perhaps possible to grow salmon not only in the fjords in Norway, but in the middle of the Atlantic. And there were technological and scientific challenges that need to be addressed, because in the middle of the Atlantic means 10 miles from the shore, 40 meters depth. So the systems needed to be fully autonomous. This was a pilot that was in place last year. The results were quite successful. And I believe this is a huge opportunity, again, for merging the gap between science and industry with economic value, because Portugal is already one of the biggest consumers of salmon in the world, but this market is a very interesting one, and competing with Norway in this case would be certainly a differentiator in the high value markets. Then another challenge in this case from Embraer with the development of the KC-390 aircraft, which is, again, it's not an European program, it's a global program in which Portugal had an amazing role. It was the first time that we actually developed about 2/3 of the structure of this aircraft. It was the first time that Portugal had a meaningful, important role in an aeronautical program worldwide. And for that, it was not only the engineering, it was also the science, it was also the involvement of institutions like PIEP, like the University of Minho, but also institutions like OGMA, for example, which manufactured the parts, and SEA, which developed themselves. So this is an example of a program which had multiple partners, a lot of challenges, and certainly made us enrich our knowledge, enrich our capabilities here in Portugal. And I believe that we should now take the next step and not only working for the big manufacturers, but have our own strategy on what we could do with the competencies, with the capabilities that we learned and that we acquired over the last few years in developing the KC-390 transport aircraft. Another challenge about micro launchers in this case, with the development of the kick stage and the payload fairings, which are very lightweight structures, composite structures, and which is an example of how we can mix the fact that we have a territory and an opportunity of launching satellites from middle of the Atlantic, with also having a technology endeavor and also having our industries and our companies working towards this challenge of building a lightweight composite structure to launch small satellites into space. And finally, and Miguel already mentioned, an example on how, if we want, and Portugal is really, I'm using the correct words, if we want, because sometimes we don't, we can work together. And by working together is not only putting engineers to work together, is by putting engineers to work with medical staff, to work with health professionals, to work with universities, to work with researchers, to work with foundations, innovators, etc., etc. And in how in 45 days we developed this medical invasive ventilator, the Athena, which we have up to date manufactured 400 units, and which we are now preparing to go towards the 900 units, and which we are now finishing a partnership with American company for them to take the exclusive fabrication and the exclusive retail of this product, which again, it was built for a challenge that we were facing here at the country, but it can target and it is competitive as well in the global markets. And finally, I do not like recipes, and I only have 3 more slides, so I'll be very fast. How to bridge the gap between science and industry, and by industry, I mean economy in a post-pandemic world. And I have, well, to make a cake, you have multiple ingredients. I have 3 which I consider can be core ingredients of this strategy. And I'll give concrete examples because I also don't like to be a tourist. One is we need to keep on reindustrializing our country. We have the workforce, we have the people, we have the capabilities. We need to keep on improving towards high value chains. We need to keep on improving towards highly competitive products. And a good example would be to take the knowledge that we built with the KC-390, to take the capabilities that we have on the aeronautical cluster, and to target a new complex aeronautical problem, but one that we can go end to end, one that we, as a small country with the capabilities that we have, can really achieve completely. And obviously that is not a big aircraft, it's what we call a short distances aircraft. It's a multifunctional lightweight aircraft that we call the ATL, and that we believe that together in the country, we can really develop this aircraft and we can really target it towards developing countries and countries that are now growing and have a need for these vehicles like Africa or like Brazil and South America, for example. So we need to work not only this platform from an economic perspective and technology perspective, but also make it so that in the future it can be carbon neutral. So we need to think about how to make it green, and that means not only conventional propulsion, but also electric propulsion and so on. Then the second one, and this is addressing already what the minister mentioned this morning, we need to become more sustainable. We need to build a sustainable future. Okay, we need to care about the economy, we need to care about ourselves and our day-to-day, but we need to leave something for our children of tomorrow, and that's a sustainable future. And if we don't make this, well, then there is no tomorrow. And for that, I suggest that we start with targeting zero carbon mobility ecosystems. And target zero carbon mobility ecosystems means twofold. In one hand, it means having vehicles, platforms, bicycles, cars, trucks, logistics, which are greener, which are zero carbon emission, which are fully electric or which can be hydrogen based, but we need to change. We need to diminish the number of vehicles in our cities, and we need to diminish their impact on carbon. And the second one is really to have the platforms and the means to quantify what we are avoiding, to quantify how much carbon we are sparing, to quantify and to provide information to our citizens on the data of their sole contribute and of the contribute of a city, of a region, of a country as a whole, because we'll need to have indicators on our evolution, and these platforms will be a key factor for citizens, for countries, and for regions to contribute. And finally, the third one, and Miguel and Ricardo already mentioned, I think we need to strengthen our Atlantic position. Our Atlantic position and our Atlantic Ocean, the Portuguese Atlantic, is something that is of unique value. And I'm saying here that to strengthen our Atlantic position, we need to value our ocean of data, because it's really what's out there. It's an ocean of data. It's an ocean of information. And those data and those information will, in a first hand, they will help building our future, because they will give us knowledge that will help us understand climate changes, that will help us understand the ecosystems, monitor the ecosystems, have sovereignty over these areas. But on the other hand, there is a huge opportunity on how to take sustainable value out of the ocean. And that means industry, that means offshore renewables, that means aquaculture, that means mineration, that means many, many things that we cannot exploit before we know, before we understand. So one cannot come without the other. And for that, obviously, I do agree that having an Atlantic satellite constellation is one of the root bases for us to really grow this, and we can only complement this constellation with the other in situ observation platforms. But Portugal would definitely grow if it could organize ourselves, if it could follow the lead of the Air Center and build this constellation so that we can strengthen our position. And the constellation is not something that can only be born with the country, so that would have to make us collaborate with European partners, but also global partners across the ocean. And finally, my last slide, I really strongly believe that we learned a huge lesson from the COVID-19 pandemic. And by we, I mean not only the citizens, the regulators, the scientists, the companies, the industries. We learned that together, and if we learn to collaborate, which is something very difficult, we can really have an impact using science, technology, and innovation at the basis. So I think there are three things that we need to start doing for this to be sustainable and for us to recover from this pandemic with science, technology, and innovation. One is we need to build policies to innovate which are stable in the long term. Innovation takes time, takes persistence, takes effort, and this effort and this persistence and our goals and our priorities cannot change with our governments. They need to be kept in the long term. So this is clear, this is something that we need. Then we need to recognize that to strengthen Europe's global position, we shall first find our role. We shall first find what can we do. We shall first find our core areas, and we cannot do everything. We need to focus. And that's something that normally we tend to disperse funding so that everyone is happy, but that in the end, we only have so-so, and we end up on not doing or not reaching the full potential of what we could do. So for that, I believe we should start by establishing our strengths. We should start by identifying our priorities, and we should keep on joining our efforts. And for that, I think the COVID-19 really gave us a lesson, but now we have to keep on doing that, and we need to keep on further developing what we did with science, technology, and innovation towards a more global Europe, but above all towards a more sustainable country, because without a sustainable country, we will never be able to contribute to a more global Europe. Thank you very much.
Thank you, Tiago. Very nice presentation. You cover so many aspects. So I retained some ideas. Say wants to fill the gap between academia and the industry. The answer from SEIA to the pandemic crisis with the ventilators, it was really amazing how in almost 2 months they got these ventilators. Also, the SEIA contribution to comprehensive oceans, gathering more data, produce information, running services, and of course, the long-term policies for innovation, because innovation takes time. Now I will pass the floor to Dr. Firoz Rasool. Dr. Firoz Rasool is the President of Chief Executive Officer of Aga Khan University. Please.
Thank you very much for the invitation and the fascinating presentations that preceded. I'm going to speak about something a little bit different. I'm going to speak about the response to COVID. This was a suggestion from Minister Manuel Heitor and my trustee, Professor Antonio Rendas, who suggested that to give a perspective from outside Portugal, particularly from parts of Africa and Asia, on how a private institutional network dealt with COVID and what are the things that we had to deal with. Many of you are aware of the Aga Khan Development Network because of its presence in Portugal, and the Aga Khan University that I represent is part of that network. And so today I'm grateful for the invitation to speak about the experience that we have had. So let me give you a little bit of a context. I hope you can see these graphs. They basically show the countries that we are in Kenya, Pakistan, Afghanistan, and Uganda. So you can see the cumulative cases since February to October 27th, which is when this particular chart was presented. Now, these cases are per million people. So that just gives you an idea, and I will give you some comparison in a second. And this is the number of deaths. So if you take Pakistan, the number of deaths is 30 per million. Kenya is 20 per million, just to give you an idea. Now, I accept that in parts of the developing world, collecting data sometimes can be more difficult. But this is data that has been collected from an international source and validated by them. So then as we continue, I've compared here UK and Portugal because we have a presence in both UK and Portugal here. And it gives you an idea. So the number of cases we're looking at is 10,000 per million people. As you can see the graph on the right, it gives you a sense of where we are. And then if you look at UK and Portugal, in terms of deaths per million people, remember I said Pakistan was 30 and Kenya was 20. UK is over 700 per million, and Portugal is something like 250. So it gives you a sense, and we need to understand what exactly is going on. So here are some other epidemiological data. You can see total cases in Pakistan, 300,000 and over, and deaths about 6,700 total. Population 220 million, just to give you an idea. Kenya's population is about 50 million, about 50,000 cases and 950 deaths. And here's the data for Portugal that you're familiar with, about 150,000 cases, of which about 2,600 deaths. So just to give you a sense of scale, and of course the population of Portugal is much, much smaller than some of the countries that we are talking about. And this is the UK. About 1 million cases and 46,000 deaths so far. So this is what COVID did. It, as everybody knows, something unprecedented. It came and hit. This is another country we're in, Afghanistan, and you can see the number of deaths is about 1,600. Now, you could argue that it's not enough testing and so on, but we can tell by deaths in the hospital. You don't have to worry about testing, and the reporting of data is, while not perfectly equal to the West, it's pretty good. So how did we deal with this at the Aga Khan University? So this just gives you an idea about some of the tests we had to set up and perform. These are some of the patients that were admitted to our hospitals, and you can see the peak was in July, and now we are beginning to see a second peak coming up. But the impact for us, as in many hospitals, I visited the hospital Curi Cabral yesterday and met with the people there. The first was that the other patients disappeared. They didn't want to be in the same hospital as the COVID patients because they didn't know what this COVID was. Do you catch it by walking in a hallway? If you're in the same room, what happens? So people didn't want to come. And that affected for us as a private, not-for-profit hospital system, our revenues in a big, big way. Also, we had some employees who were infected, but we found out they were more infected in where they lived in the community than in the hospital. That reduced our capacity. People were tired, they were fearful, they were anxious. We had to transition to online learning, as many universities did. And the question was, what was the role of our medical and nursing students in the pandemic? Do we bring them to the hospital? Do we ask them to stay home? Do we get them involved? Are we putting them in danger? I mean, all of these questions were ones that existed. Here's for those of you who visited our campus, this is our waiting area during COVID. And this is our waiting area before COVID. So just shows you how the patients all disappeared. So what was our response? So we're just going to play I should play a video here. Okay, it's coming up.
After the hospital received its first COVID patient in late February, our whole world changed. We had to work around the clock to rapidly create the facilities for handling a high number of infected patients.
So now we are taking you to the COVID unit.
We converted the 10-bedded acute care unit into a state-of-the-art negative pressure facility. We've converted our emergency department spaces to ensure that we are able to handle all patients, including COVID patients, safely. We've also converted the old private wing into a COVID diagnostic and treatment zone. This involves numerous modifications, including creation of doffing areas, airlock systems at the entrances to ensure that the corridors and the spaces outside of this are safe and secure. A state-of-the-art testing and screening site is now up and about. This testing facility is the first of its kind in Pakistan. The last 2 months for us has been a learning experience, a journey which has been long, difficult, but yet full of hope.
So you just saw that we had to set up very quickly testing facilities that were separated from the rest of the hospitals. And this was a booth that we built. We protected the person taking the test from the patient or person coming for tests. This gives you an idea. It had to be done all outdoors because that was the advice at the time. Keep people outside in fresh air that's moving all the time. We had to build field hospitals. So these were temporary isolation facilities. This was built in a sports pavilion in Nairobi. This is also in Nairobi. This is the current version of an American military field hospital. And the American government donated this hospital to us. It takes care of 40 patients with full ICU facilities, operating theaters, and everything else. This is the inside of this field hospital, just to give you an idea. This is the field hospital in Karachi, in Pakistan, in an expo center, not unlike this one, which was converted into a field hospital. And we had to reassign staff to critical areas to make sure we had the people, not just the spaces. Of course, training and guidelines for personal protective equipment was extremely important. And these are all the things that many people had to go through. But for us in the developing world, to be able to have to deal with this was a big challenge. So what did we learn? We obviously had to go to online and distance learning for our classes with our students. We are now bringing students back gradually, particularly the medical students and the nursing students in their 4th and 5th year for their clinical training. So that has just begun. Of course, we have gone to blended learning, a mix of online and in-person learning, so that our students don't fall behind in their education. We also had to protect employees through providing proper spaces. We had to modify the spaces. Here's the areas how we created physical distancing in classes, in waiting areas, outside. Many of our people are working from home. For us, this is a pretty challenging situation. Why is it challenging? In countries where we work, the internet is very unreliable and power is not available all the time. So how do you teach a student or ask a teacher to deliver a course when the internet is down most of the day, and if the internet is up, then the power is down? And so those are some of the challenges that we've had to deal with. We also created a lot of apps. So this is an app we created that every student and every employee has to do a self-screening before they come to the campus. And it's very simple. It's like a traffic light. If you put the symptoms in, how you feel and so on, if it's red, you don't come in. If it's yellow, you go for a test. And if it's green, you come in. And so that's how we are still managing the process of bringing people back to campus. And you can see some of the safety measures. Of course, training of the staff, extremely important. For us, it's not just training the staff, but it's also retaining the staff. I'll give you an idea. With the UK now leaving the EU through Brexit, is losing a lot of European healthcare workers. So guess what? They're recruiting nurses in Kenya. So all these nurses that we have trained in ICU practices and so on, we are losing them now. They're paying 4 times the amount of money, and this is now a massive brain drain in the middle of a crisis that's begun. We also had to get involved in innovating, and we saw some examples of this. So here's an example of a UV light that we created to disinfect PPEs, masks in particular, for our doctors, so they can be reused. And we've got a patent for it that we have just applied for this UV disinfection machine. Here's the app I was telling you about that every employee and every student has that we had to develop. And we also developed an app, we call this the Corona Check, for 6 countries, for the population. So they can look at their health conditions. So it was for Kenya, Uganda, Tanzania, Tajikistan, Afghanistan, and Pakistan. And so they use this app in different languages. It gives you an idea about the type of things. Also for us to buy product was very difficult. So this is a simple nasal swab that is critical for the testing of COVID. We couldn't buy it. You can't access it, not in the developing world, because I don't know if you're aware, 92 of the 95 countries that produce medical supplies have a no export rule. So Portugal can't export unless they get approval from the government. And particularly when you have these types of devices so we created our own. These are 3D printed right in our lab now, because we had to develop our own production facility. You heard about ventilators. We use this, we shared ventilators between 2 patients, and we had to modify the manifolds and so on. We had to produce in-house sanitizer, because you couldn't import any. You couldn't buy any. We had to develop our own. So this just gives you an idea. And to give you a broader idea in terms of the research, We have now undertaken almost 150 studies under different disciplines. They go obviously from epidemiology and clinical, but also to healthcare related, health worker related, and mental health related, because mental health is a big challenge in this particular crisis that doesn't come through. We're doing a study of the genomic diversity of the virus in Pakistan and looking at through next generation sequencing. We're doing this with the NIH in the US. We're also looking at the markers of disease severity through gene expression in asymptomatic patients to be able to get some idea. And this is funded by the Pakistan Higher Education. Here's a partnership with Portugal, with University of Lisbon and with Nova University, and looking at immunity through immunological assays that we've begun. And this is a joint project with Portugal. We're also looking at surveillance of patients to look for the spread of infection in the province where we are. And we've also been developing drugs to treat patients in this particular area, particularly to do with pregnant women and young children that have just been given given birth. The mothers have given birth, and the mother might have COVID, and what about the child? And this was a very interesting analysis, that the second, which is looking at the burden and the epidemiology and mitigation strategies in majority Muslim countries. Many of the Muslim countries don't have their own national public health agencies, and they are not able to respond, some of the poorer ones particularly. So we did a comparative study of what is available across the world and what the result has been. A couple of areas that I think you might be interested. We're also testing 2 COVID-19 vaccines. One is a Chinese vaccine made by a company called CanSino, which is now in clinical trials right now in Karachi. And we also did the Empecta study with Roche in the US, and a clinical trial on this drug, tocilizumab, which is made by Roche Genentech for African patients, because they have been testing these drugs in other parts of the world, but when they came to Africa, they needed an FDA-approved clinical trial center, which is what we have. We are the only FDA-approved clinical trial center in sub-Saharan Africa. And so this is where we are testing these drugs with Genentech. Convalescent plasma, of course, every country is testing this, and we are as well. And we are also starting in Nairobi, in Kenya, this clinical trial on the vaccine from Sanofi to look at whether these vaccines are going to work in different populations. So it is an international trial that we are part of, and we are doing the Africa or the Asia section of this particular one. And of course, the constant surveillance trials that we need to do in looking at the infection. Finally, I just wanted to add by saying that in many of these countries, the governments don't have the capacity, and we had to advise them on management of care, best practice, even supplies. We talked about nasal swabs that we had to create. This is a very interesting project. I'll just take a minute to explain. There is a massive shortage of ICU capacity in the countries where we work. So in Pakistan, there are very few ICU facilities, but even fewer ICU doctors and nurses and technicians. So what we did is, working with the Gates Foundation, who funded this, and then a local foundation who came forward with this, is we set up a national tele-ICU project. So we connected all the ICUs to Aga Khan University, so we can support a doctor in 2,000 kilometers away with a patient who is now going down fast. How do you treat them? And not only that, we connected our alumni, all of our graduates who are in the US. So we had 1,000 doctors and nurses all connected by telehealth 24 hours a day to help any hospital in any village or small town, and a doctor who needed help with ICU support for the patients. In Kenya, we helped the Ministry of Health, and we also provided technical support and, of course, clinical data that they need for their studies. So what happens next? This is the next question. The virus hasn't gone away. It's still here. We are seeing a second wave, a third wave. So what happens next? And this is the question we have started to look at. Of course, telehealth is one that is already begun, where people who don't want to come to the hospital, we are now beginning to treat them through using telemedicine. Home health has become a very important area. So pharmacies, medicines to be delivered, we are now delivering them to people's homes, so they don't have to leave their homes. We're also doing home health services, physiotherapy, blood collection, and whatever portable ultrasound machines we have. We are also using that so people who either choose not to or are unable to leave home, that can be treated at home. So what are the lessons we learned and what are the questions? The first one is, what are the factors that underlie this anomaly in Pakistan? Why is it Pakistan, with 220 million people, has only 30 deaths per million? And Portugal has 250, and the UK has 750. Why? Is it genetic? We don't know. We don't think so, because some of the doctors in the UK, most of the doctors in the UK who are dying are South Asian. So how does that explain? It's a big quiz. We don't understand that. The other question is, with infection and mortality, what are the differences between India and Pakistan? They're genetically the same. And yet, two countries side by side, big differences. We don't understand what that is. As you can see, I said also, why are the death rates of South Asians much higher in the West than in the East? Not understood. What are the reasons underlying the ethnic differences in infections locally and globally? This is an area for new research. The other one is, what is the immune response to the virus? Why is it so different across the world? So it means vaccines are going to be more efficacious in some countries than others? We don't know. What are the factors that cause the diversity in phenotypical expression of disease? Short-term versus long. Is it age-related, environmental related, demography related? Don't know the answer to some of these questions. And what is the probability and mechanism for reinfection? When will the antibodies die down? When the patient becomes exposed? If this is flu-like, then does that mean we need a vaccination or a vaccine inoculation every year? Again, lots of questions unanswered. So I'm going to leave you with those unanswered questions and to say there are areas of collaboration and participation with our partners, including in Portugal, for some of these questions, and we hope to work together to understand the underlying area. One thing is clear, that has become clear in my visit to Lisbon this week, is that this new disease has leveled the playing field between the developing world and the developed world. Institutions in the developing world have an equal chance of creating new knowledge and a new understanding about a pathogen that is completely devastating the world as the countries in the developed world, in Europe, in the US, and in China and elsewhere. So we are excited. Of course, we are terrified of also what the unknown looks like, but we're excited with what we think we might be able to contribute. So thank you very much.
Thank you, Dr. Razul. I will finish now this session, but before I want just to retain some ideas about the session. So I just want to start with summarizing what the Minister of Economy just said. We need to put the science and knowledge into the economy. Then myself, I mentioned also the credibility of the political decisions based on the science and the advisors of the science. Alexandra pointed to have more data, more science databases, and easy access to those databases. Miguel stated the importance to have more data by satellites. There needs to have models like the digital twin Earths, digital planets, and also to tackle the problems of our sustainability focus on the Atlantic. And Tiago from CEIA mentioned wants to fill the gap between academia and the industry, get more data, produce information, analytics, and also running services. And he points out also the long-term policies for innovations, and innovation takes time. And finally, Dr. Razul present us the response and their experience the response for the COVID, an overview of the pandemic profile, and also their learning experience and new methods, and of course new self-manufactures internally to respond to their needs. So I think now we have to conclude this section, the intervention by video of the Minister of Foreign Affairs, Augusto Santos Silva. I think this is the moment to pass the video, right? Okay.
Bom dia a todos. Bom dia a todos. Em primeiro lugar, por agradecer o convite para participar mais uma vez no Encontro de Ciência, neste caso o Encontro de Ciência 2020. Sabem todos o gosto com que o faço. Peço desculpa de não poder estar presencialmente, mas é por razões relativas à minha própria agenda que me impedem de estar em Portugal e em Lisboa nesta ocasião. E queria apresentar a minha comunicação estruturando-a em 4 pontos fundamentais. No primeiro ponto, procurarei explicar a importância que a internacionalização da ciência e da tecnologia tem para a política europeia e externa do nosso país. Em segundo lugar, queria entrar no ponto fundamental desta sessão, que é a importância da ciência para a Europa global e, portanto, queria enquadrar o que nós fazemos no domínio da ciência e tecnologia nas nossas responsabilidades como Estado-membro da União Europeia e, em particular, como a próxima presidência do Conselho da União Europeia. Em terceiro lugar, queria mostrar quão importante a dimensão científica é na relação bilateral e na cooperação bilateral de Portugal com outros países. E, finalmente, queria argumentar que a ciência, a investigação, o ensino superior, portanto, em geral, o mundo académico, representa um dos planos mais importantes da cooperação, da política de cooperação para o desenvolvimento desenvolvida por Portugal. Comecemos, portanto, pelo primeiro ponto, mais genérico, apenas para recordar que tenho defendido que a internacionalização deve ser entendida como um dos objetivos estratégicos da política europeia e externa de Portugal. Juntamente com a nossa participação na construção europeia, a nossa ligação atlântica, com a nossa ligação particular com os países de língua portuguesa, com a nossa ligação ainda mais particular com as comunidades portuguesas espalhadas pelo mundo e com a nossa vinculação básica, fundamental ao multilateralismo, juntamente, portanto, com todas estas orientações estratégicas, a internacionalização deve ser tomada também como uma linha de força fundamental da nossa política. E quando digo internacionalização, não falo apenas da internacionalização da economia, não falo apenas da internacionalização da língua e da cultura, falo também da internacionalização da ciência e da tecnologia, desde logo do nosso Sistema Nacional de Ciência e Tecnologia. É muito importante nós compreendermos que é internacional o quadro de referência do nosso próprio Sistema de Ciência e Tecnologia, como é muito importante também termos bem consciência da capacidade do recurso estratégico para o país que é o seu Sistema de Ciência e Tecnologia, como é igualmente importante percebermos o papel que a diplomacia científica tem na política europeia e externa. E é, portanto, desta perspectiva geral que valoriza a internacionalização da ciência e da tecnologia portuguesa que eu gostaria de abordar agora os 3 pontos específicos que, como já disse, escolhi para falar hoje: as nossas responsabilidades europeias, o papel da ciência nas nossas relações bilaterais e o papel da ciência na nossa política de cooperação. Comecemos, portanto, pela Europa. A ciência terá um papel essencial na recuperação da economia europeia, na economia pós-Covid, porque tanto ansiamos. e com a consciência que todos temos, ou devemos ter, de que a recuperação da economia portuguesa, da economia europeia, será ao mesmo tempo um processo de transformação da economia europeia, para torná-la mais resiliente e para torná-la mais adaptada aos desafios do tempo de hoje, em particular ao desafio do que nós chamamos a dupla transição, a transição digital de um lado e a transição verde do outro. E, evidentemente, que essa transição verde e digital nós só podemos vencê-la se mobilizarmos os recursos científicos e tecnológicos de que dispomos. E, portanto, o meu primeiro argumento, a minha primeira hipótese de trabalho é esta, de pensarmos que o processo de recuperação e transformação da economia europeia em que estamos agora envolvidos e para o qual vamos mobilizar recursos financeiros como nunca antes tínhamos feito, esse processo exige uma maior incorporação tecnológica dos nossos produtos e processos e exige uma maior base científica, uma mais larga base científica para esses processos e produtos. E isto materializa-se em certas iniciativas e certas responsabilidades que marcarão de uma forma muito clara a presidência portuguesa do Conselho da União Europeia no próximo semestre, entre janeiro e junho de 2021. Desde logo, por causa do lançamento dos novos programas no quadro do novo quadro financeiro plurianual, que são programas que têm diretamente a ver com esta área. O novo programa Erasmus, de mobilidade académica, o novo programa Horizonte Europa, que terá maior dimensão e maior fôlego, e o programa europeu para o espaço. É a primeira vez que ele vai ser lançado e vai ser lançado na nossa presidência pela primeira vez a partir de 2021. Haverá um programa europeu para o espaço. Também queria chamar a atenção, se me permitem, para os avanços muito substanciais que vão ocorrer no próximo ano no que diz respeito à Europa digital. Em 2021 iniciar-se-á a década digital europeia, 2021-2030, e isso não se trata apenas de uma agenda de promessas ou de compromissos. Trata-se de uma agenda de iniciativas e de realizações. Está hoje adquirido que será no primeiro semestre do próximo ano que se lançará, que se concluirá, que se efetivará, melhor dizendo, o novo cabo submarino que ligará a Europa e a América Latina e que na Europa será amarrado em Sines, e é muito possível que o primeiro supercomputador europeu verde seja lançado também durante a nossa presidência. E, portanto, o sistema europeu de processamento de dados, o papel da Europa na chamada ciência dos dados será mais claro, mais intenso, mais forte no próximo ano e, evidentemente, que isso coloca novas responsabilidades à presidência portuguesa do Conselho da União Europeia, mas também à comunidade científica e tecnológica portuguesa no seu conjunto. E depois não esqueçamos as responsabilidades que já são hoje as nossas em várias agências científicas internacionais muito importantes. Começando pela Europa, foi com todo o gosto que nós vimos o nosso compatriota engenheiro Rodrigo da Costa ser escolhido, depois de um processo muito competitivo e exigente, ser escolhido para diretor executivo da Agência Europeia do Sistema Global de Navegação por Satélite. E esse nosso compatriota terá uma responsabilidade na transformação qualitativa dessa agência que se perfilará no próximo futuro. Depois, Portugal ocupa neste momento, juntamente com a França, a presidência do Conselho da Agência Europeia do Espaço. Depois, Portugal criou o Air Center, uma iniciativa intergovernamental com sede no arquipélago dos Açores, na região autónoma dos Açores, na Ilha Terceira, que junta esforços de 14 países europeus, africanos, latino-americanos e de várias organizações científicas e universitárias. E, portanto, as nossas responsabilidades europeias e internacionais no domínio científico são evidentes, já são hoje grandes e serão maiores no próximo futuro. E, evidentemente, este é um contributo nosso para uma Europa mais global e, com ela, um sistema científico e tecnológico português mais internacionalizado. Mas eu queria aproveitar os minutos que me restam para me referir ainda a outros 2 pontos que reputo igualmente importantes. O primeiro é o papel da ciência no relacionamento bilateral. Vamos fazer um pequeno exercício exemplificativo. Olhemos para as relações bilaterais com os nossos vizinhos. Nós temos 2 vizinhos. Temos um vizinho que nos liga a contiguidade territorial por terra, a Espanha, e, neste momento, o grande projeto comum, conjunto luso-espanhol, que existe, está consolidado e se desenvolve cada ano que passa, é um projeto na área da ciência e da tecnologia. Estou-me a referir ao Instituto de Nanotecnologia, sediado em Braga. A cooperação bilateral Portugal e Espanha não seria hoje a mesma se não houvesse o Instituto de Nanotecnologia, e esse instituto foi o primeiro grande projeto conjunto que os 2 países se abalançaram a fazer, e não foi por acaso que esse primeiro grande projeto conjunto se fez na área da ciência mais avançada e da tecnologia de ponta. E agora olhemos para o outro vizinho do outro lado, um vizinho que é nosso vizinho do outro lado do Atlântico, os Estados Unidos. O programa científico, em muito boa hora lançado pelo saudoso José Mariano Gago, revolucionou, eu acho que o verbo é mesmo esse, revolucionou o quadro de relacionamento bilateral entre Portugal e os Estados Unidos. Estou-me a referir aos programas de intercâmbio e de cooperação universitária e científica de universidades portuguesas e instituições americanas que são líderes ao nível mundial, como a Harvard Medical School, o Massachusetts Institute of Technology, o famosíssimo MIT, o MIT, a Carnegie Mellon ou a Universidade de Texas em Houston. O programa consistente, lógico, coerente de trabalho entre universidades e instituições de investigação portuguesas e universidades e instituições de investigação americanas mudou e mudou qualitativamente a substância e também, digamos, o nível, a escala do relacionamento bilateral entre Portugal e os Estados Unidos. São apenas 2 exemplos, outros poderia dar, sobre a importância da ciência na nossa relação bilateral com a Alemanha, por exemplo, e muitos outros países, mas estes exemplos bastam, na minha opinião, para percebermos bem a importância que a ciência tem na política externa portuguesa. E, finalmente, o papel da ciência em sentido lato, portanto, formação avançada, investigação científica, inovação, aplicação tecnológica, o papel que a ciência em sentido lato tem na nossa política de cooperação. A nossa política de cooperação tem naturalmente parceiros privilegiados, os países africanos de língua portuguesa e Timor-Leste, e nesse quadro a dimensão da formação avançada e da investigação é crucial. E é cada vez mais crucial. Dou apenas alguns exemplos. Em primeiro lugar, a importância que detém no conjunto dos programas de cooperação a dimensão da formação avançada. Nós temos um programa de bolsas através do nosso Instituto Camões diretamente e através também de outras instituições, desde logo as ligadas às Forças Armadas e às Forças e Serviços de Segurança. Nós temos um programa de bolsas, dizia, que tem uma componente interna e uma componente externa. A componente interna quer dizer bolsas para a realização de estudos nos respectivos países financiadas pela cooperação portuguesa, e a externa quer dizer bolsas para que estudantes de ensino superior dos países africanos de língua portuguesa ou de Timor-Leste disponham para estudarem e se formarem em Portugal. Essas bolsas apoiam a realização de estudos de graduação, de licenciatura ou de pós-graduação ao nível de mestrado ou doutoramento. E são uma componente muito importante, por razões que me dispenso de explicitar, da nossa cooperação. Mas não são a única componente. É também muito importante o trabalho que nós temos feito através do Ministério da Ciência, Tecnologia e Ensino Superior, e que é um trabalho de cooperação nossa com redes internacionais de apoio ao desenvolvimento para favorecer, para capacitar mais a nossa cooperação na área da ciência e do ensino superior com países africanos de língua portuguesa. Um exemplo muito interessante é o exemplo da cooperação entre o Ministério da Ciência, Tecnologia e Ensino Superior português e a rede HK para o desenvolvimento, de que têm beneficiado justamente países africanos que são nossos parceiros na cooperação. E, finalmente, queria referir-me aos projetos de cooperação que são inteiramente científicos, são projetos de natureza científica. Talvez o mais consolidado até ao momento, mas um muito conhecido, é o Centro de Investigação em Saúde em Angola, o CISA, que tem sido ao longo dos anos um dos projetos bandeira da cooperação portuguesa e que é, como o nome indica, um projeto de capacitação de Angola em recursos científicos e de investigação na área da biologia e das ciências biomédicas. Outros exemplos se poderiam dar em Moçambique e noutros países parceiros. O meu ponto com estes exemplos é apenas este: é mostrar que a ciência e a formação avançada são uma dimensão muito importante, um pilar muito importante da política de cooperação portuguesa. Portanto, resumindo, este movimento de internacionalização da nossa ciência é também um movimento de protagonismo dos nossos recursos, programas e projetos científicos no quadro europeu e internacional. Seja pela presença que nós temos nos programas e nas instituições europeias e pelas novas responsabilidades que vamos ter com a nossa presidência do Conselho da União Europeia, seja no relacionamento bilateral com outros países, seja nesse relacionamento específico que é aquele favorecido e enquadrado nos programas de cooperação para o desenvolvimento. Desejo um bom trabalho a todos.
E um agradecimento ao Sr. Ministro da Economia, ao Sr. Ministro também dos Negócios Estrangeiros, Alexandre Cunha, Miguel Belhou, Tiago Rebelo, Dr. Russell. E para concluir, a ciência, aqui umas palavras do Sr. Ministro, a ciência é um recurso estratégico de Portugal. Obrigado.
Muito obrigado. Muito obrigado a todos os participantes nesta sessão. Nós estamos com algum atraso, pelo que vamos de imediato começar a sessão planeada para as 11h30, que será o Patient Innovation Bootcamp Demo Day, que terá participantes em vários países europeus e por isso precisamos mesmo de garantir que as ligações acontecem a horas. Eu pedia desde já aos participantes que estejam na sala, nomeadamente aos membros do júri, para se dirigirem ao palco, para que possamos começar o mais rápido possível. Can I get the slides, please? So I think we are live now, but we need... Wonderful. So good morning, everyone. Welcome to the Patient Innovation Bootcamp Demo Day. My name is Pedro Oliveira, and together with my colleagues Helena Canhão and Maria João Jacinto, I lead this project that today is going to have a pitch competition here in the context of Ciência 2020. Let me tell you briefly about our project, which is something that we created when in our research, when I say our research, is joint work with Lazy Lalovic, a professor at Nova School of Business and Economics, and Helena Canhão, and other colleagues. In fact, we realized that quite often patients are able to develop very interesting and innovative solutions like the ones that you can see here in the slide. We here are showing just a few examples. For instance, Tail Goldsworthy, a guy that is known for fixing his own aorta. He was able to develop an aortic support for himself, and by doing that, he was actually able to save the life of many people. You also see Amit Gopher from Israel, and Amit has a different story. After a car accident, he became tetraplegic, and he developed the most sophisticated exoskeleton that is now available in the market. Hugh as a researcher from the MIT Media Lab, does a lot of work in developing bionic limbs, and in fact, this started because of his own condition. The first bionic limbs that he developed were for himself. At some point, we realized that this was a very interesting phenomenon, and we wanted to study it, and we needed more data, so we developed a platform so that patients would be able to share with us their stories, their innovations. We did that 5 years ago, and in a relatively short period of time, we collected about 2,400 medical devices that were developed by patients and informal caregivers from around the globe. We have now a portfolio of 1,300 solutions that have already been medically screened by our medical team. On average, we are getting about 3 submissions every day. For instance, during this COVID period, we collected over 300 solutions that were specific for COVID-19, including under 10 ventilators. On average now, we get 1.2 million visitors in the site per year. Now, one of the initiatives of the Patient Innovation Project is what we call the Bootcamp. The Bootcamp is an initiative that is funded by EIT Health that is aimed at helping a selected number of entrepreneurs, you will meet them today, to actually further develop the products that they have, bring them to market. So we have been with them in this journey of further helping them what they have already, further developing what they have so that they can launch in the market if they haven't done so. And this is a bootcamp that started in Lisbon, here in Lisbon in August. It was actually the only time that we could meet together due to the pandemic. The other 2 stops had to be moved online. We were supposed to be in Barcelona at Chiesa Business School. This wasn't possible, so we did it online. Also, it was not possible to have the Copenhagen Week in Copenhagen, so we did it online. But it all started here in Lisbon, and what you will see today is the result of that work, and result of the work that, of course, these entrepreneurs had done before. This is just some snapshots, some pictures of what happened in Lisbon, where we met at Nova School of Business and Economics. You also see some pictures of Hospital da Luz here in Lisbon, and some of the speakers that were with us either remotely or on site at Nova. Now, today, we are also going to have a pitch competition. So the idea is that each entrepreneur will use the floor for about 4 minutes, and after that, the jury, that I will introduce in a second, will ask questions for also a period of 4 minutes, and then in the end, we will decide what is the best project that we have here, and there will be both a prize money, relatively small prize money, and also this prize here is for the team that will win today this competition. So let me tell you briefly about the members of our jury. We have with us Francisca Leite. Francisca, among other things, is the General Director of Hospital de Luz Learning Health. We have Leite Zinolevich, professor at Nova School of Business and Economics and also the chairman of the Data Science for Social Good Foundation. We have Sofia Rocha, a medical doctor, CTO at Lusíadas Saúde and founder of Skin Soul, and also actually a member of Patient Innovation. And we have remotely with us Hugo Silva. Hugo is co-founder and chief innovation officer at Plux, medical devices company from Portugal. So thank you, first of all, for helping us in this hard job today. What we are going to do is to follow this order for the different pitches. My colleague Helena Canhão will be controlling the times and leading the way from now on. After the 9 presentations, 8 of them will be remote because the participants are in Spain, different places in Spain, in fact, Czech Republic, Denmark, France, UK, Belgium, and also Portugal. But also, after this, the jury will quickly decide the winner. And at the end of this session, we will have the Minister of Science and Technology delivering the award, remotely, if the winner is not present here in the room. So, this is the plan. Again, welcome to our pitch competition, to the Patient Innovation Bootcamp Demo Day. And now I'll pass the floor to my colleague.
Thank you so much, Pedro. And we'll start with Epidermis. I think Epidermis is already in the Zoom. Hello, Gonzalo. Can you start, please?
Yes, 1 second.
Share your slides.
Your time is counting.
Hello, everyone. We are Epidermis, learning about eczema management easily. Atopic dermatitis, eczema, is an extremely widespread chronic skin disease. It affects many people, as you can see, and 1 out of 10 suffers it from a severe form. It doesn't kill you, but it makes your life worse. The patients are constantly looking for information and for new treatments, even if they are under a treatment. They change a lot of doctors and dermatologists because they are not able to build a strong and a long-term relationship with them. The same problem happened to the doctors, and also the lack of time on the appointments, and in the near future, there is going to be a lack of dermatologists. Our solution for the industry is helping both groups, patients and doctors, building a stronger brand among patients and providing a useful tool for the doctors. This solution is a platform for eczema patients, doctors, and experts to help each other to learn how to manage eczema in long term. It is aligned with our vision, helping eczema patients through technology. We are very data-driven, so our solution is composed by discussions, knowledge base, and data collection. The value we provide is the trust, a platform personalized through technology. It lets save time and money for doctors and for patients, and all the information we provide is easy to understand. Our solution at Dermis is the product hunt for all the eczema stakeholders. And this web tool will be incorporated in our current prototype that is already in the market in a private beta version with 35 patients that are currently co-creating the app together with us. Our solution will facilitate the effective flow of data between all the eczema stakeholders. The market we can reach is 16 billion euros, and that is the annual patient spending all of the severe eczema patients who are the 10% of all the patients. We are testing different business models, like the freemium model, sales of licenses, anonymized data access, corporate partnerships, and also tailored app for different purposes. What makes us different from our competitors is our communication tool. And we have a very multidisciplinary team with IT, marketing, and business, and also we count on a health expert in our team. Vamos a falar sobre colaboración. We are looking for corporate partnerships on the pharma and cosmetic industry, patient association to co-create and moderate the tool with us, and doctors to keep co-creating the app. Thank you very much.
Thank you, Gonzalo. We have time for 2 quick questions from the jury. Sofia, do you want to ask
Sure.
Gonzalo?
Congratulations, Gonzalo, on the presentation. One quick question. How do you plan to validate the information on the communication tool?
We would like that we are in Portugal. We are in contact with the patient association, and we would like to do the same in other countries. That they will be the ones who moderate the content of the tool.
Thank you. Can I ask another quick question?
Yes,
Sorry, very quick one.
second one,
Regarding
yes.
the way you want to monetize, you showed that you have 4 models or 4 stakeholders targeted. How do you plan to monetize it to reach those 16 billion possible markets?
Right now we are testing the corporate partnership, and I think that if we build a good relationship with the patients association, and we go with a pharma or cosmetic corporation, we'll be able to reach all that users in order to get this market.
Thank you so much, Gonzalo. And now we will move on with Bill Glasses.
Hello, do you hear me?
Yes, but we cannot see you.
You cannot see me. Can you see my screen right now? Can you see my screen?
Not yet, but yes.
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 Yes? Okay.
Yes. Thank you so much. You can start.
Okay, good morning. The project started with my son, Biel. Biel was born with a disease that causes him low vision. He has problems for ascending stairs, crossing streets. He used to suffer falls and collisions, and he easily gets lost. When his mother and I realized that the eyes of Biel do not adapt to the world, we decided to adapt the world to his eyes, allowing him to move it by himself. Low vision is a visual impairment that cannot be corrected with normal glasses or surgery, and it's 7 times more common than complete blindness. It has many different causes, and its worst consequences are the mobility issues, which cause dependency and social isolation. But people with low vision still see. They still keep some visual capacity. This is why our solution consists in smart glasses that adapt the reality to the remaining visual capacity of people with low vision, improving their mobility and personal autonomy. For doing so, we use technology from robotics, AI similar to the one used in autonomous driving, and mixed reality like in gaming, to create an enhanced version of reality, like in this video. Here is the way that somebody with low vision sees. They need to be scanning the ground all the time in order to avoid fixed or mobile obstacles. And now we can see the same situation using our solution. First, we have an eye for crossing the street. Now we can see that they do not need to be scanning the ground, because if is there any danger, the system warns of it using graphical signs adapted to the remaining visual capacity of the patient. Moreover, the system includes other complementary functions, like in this case, a zoom window to facilitate reading. This is a patient running into an obstacle, and now without the glasses, now we can see the same patient using a prototype that he's able to easily avoid the obstacle. Dogs and canes are still the most used solution for mobility of people with low vision. Dogs are expensive and care requiring, and canes have very limited functionality. Both of them occupy one hand, do not leverage remaining sight, and are very stigmatizing. Therefore, for most people with low vision, they do not make a difference worth taking on all these problems. On the other hand, smart glasses make use of remaining sight, including vision improvement functions like zoom, let both hands free and are less stigmatizing, as smart glasses are becoming a very common gadget. Comparing with other electronic solutions for low vision, we focus on mobility. We provide unique solutions for mobility, but we also include other functions to provide a complete solution for low vision. There are more than 25 million people with low vision in Europe, and 7 million of them have severe mobility issues. It's a market worth more than 5 billion euros, and we plan to achieve 33 million euros of this market in 5 years. The glasses will be sold in optical stores which specialize in low vision, but will configure the device to fit the specific needs of the patient. The retail price will be 4,900 euros, and to assess the value offered by this price, you have to keep in mind that the estimated cost of having low vision is more than 8,000 euros per year, and the device will last a minimum of 3 years. Moreover, in most of European countries, this price will be reimbursed by public, social, or health systems. The team is composed by experts from the technology sector, from the medical, and from the e-car areas. And we also have an excellent network of businesses and industrial partners, and we collaborate with the main patients and professional associations. We have raised more than 800,000 euros in public and private funds so far to develop a prototype and to start industrialization. Now we are looking for the next round of 1 million euros to finance product launch in Spain and Denmark, and to expand to the rest of Europe. All of that to let people like Biel to be free to move as any other. Thank you.
Thank you so much, Joe. Late, do you want to ask a question?
Is this working? Yeah. So thanks a lot for your presentation. A wonderful solution. Did you already test it with with Biel?
Well, actually we test with Biel, but Biel is not very,
I'm sorry.
Let's say he's not our main tester, because the feedback that we can have from Biel is not as good as from other people. We have been testing the device in the Faculty of Optometry in University of Barcelona, the UPC, University Polytechnic of Barcelona, and we tested with many patients so far. And we didn't finish yet the test, but we have promising results. 80% of the patients confirm improvement of mobility.
And did you test by giving people and seeing whether they stick with the solution? Do they use it continuously, or is it just one-off?
No, not yet, because for ethical reasons we cannot just give the device for the people who use it by their own. We need to test it in a controlled environment, because we need to be sure that there is no any safety risk. So we are testing in. I'm showing another. You can see this is the lab that we are using now. It's a lab that we built with the funding of EIT Health, actually. And this lab is specifically for testing mobility problems, where we can simulate any kind of mobility situations, but we can do it in a controlled environment.
And just the last question, what is your patent for? There is a patent pending sign on your slides.
Yes,
what is it for?
We patented both the methods and the system. And well, it's patent pending. We filed the patent 2 months ago.
Where?
In the European Patent Office.
Okay.
Thank you so much, John.
Thank you.
And
You're
now we move on to CF Hero. Can you hear us?
Yeah.
Okay.
Can you hear me? Hi.
Hi, how are you? So maybe just wait a little bit to see you, and then you can start with your pitch.
Do you see our page, our presentation?
Not yet, but we are waiting a little bit more.
Mm-hmm. Although I can see she's
Okay.
sharing.
Yes.
Hello.
Hello, how are you? So you can start, please.
So do you see the presentation, right? Because I see only two of us.
We are seeing you.
Yeah, perfect. Yeah. Okay, so let's start. I will tell you a story. 20 years ago, I was finishing my high school exams with intravenous antibiotics and 2 hours long, boring lung inhalation therapy for every single day. And I was wondering what to do next. All statistics showed I have only 5 more years to live. Is there a future for me? Should I have a family? Those were my thoughts. And those are still worries for young people with a genetic lethal disease, cystic fibrosis, CF, which I have. Even today, with all medicine progress since 2000, the average age at death for CF is under 29 years in the EU. I have lost dozens of my friends. But I have survived to my 39, and I realize that it's the patient himself who is the greatest expert very often. The biggest difference in my case was very intensive inhalation lung therapy, demanding boring thing that patients usually hate. In 2016, I joined a father of a little CF girl who started a project of a playful mobile app for CF youngsters. Because therapy can be fun, and funny therapy can save lives. How to make therapy fun? Well, first you need great teammates like Barbara. Hello, my name is Barbara. I'm a software engineer with a big pharma background, and I'm a technical lead of CF Hero project, which we are doing with our team consisting of experts, including CF doctors and physiotherapists. We get a lot of support to realize our project for young CF patients. Because as a teenager, you are struggling many things and aspects of your life, and no one should tell you what to do, right? And there are much more things you have to fight with when you are a teenager with cystic fibrosis. In this time, the therapy drops a lot, and health conditions go quickly down with no way back. We want to help and improve all these terrible statistics because we believe every patient can be a hero. CF Hero is a non-profit mobile app which focuses on building habit of daily inhalations and also provide the education with humor tips and tricks. This all is done through the gamification and playful design. The most important section is for the inhalation therapy. During the session, you can focus on breathing and follow the pattern. That's how you can increase the efficiency. You earn virtual coins, and this helps you focus on doing the only one thing is needed, the inhalation, and do it right. These coins can be spent on improving your avatar or buy a funny comic stories written in the teenage language with tips and tricks. CF Hero is available in Czech Republic and in Slovak Republic. It's free and it's helping young CF patients and their parents. We have first data. These were presented at the European Cystic Fibrosis Society conference in Liverpool. And we have direct feedback from patients and their parents and from hospitals and doctors too. And we are ready to bring We are seeking for partners and donors to make the app available country by country, with cooperation with local Portugal patient organization
we would like to bring the app to Portugal too. So please contact us if you are able to help us with this mission. Thank you for your attention.
Thank you so much. Thank you. Francisca, do you want to the question?
Hi, thank you so much for a wonderful presentation, a wonderful product, and I'm so glad that you're using it and that it's making a difference for many people in the world. All the slides were very fast. How many kids, teenager kids, use it right now, and how many keep using it after a first attempt?
Well, we have, as cystic fibrosis is a rare disease. There are 600 people with this in Czech Republic. There are about 400 people with this disease in Portugal. So it's about 200 in Czech Republic and about less than 100 in Slovak Republic, when it's even less people in the Slovakian.
But they keep using it once they try the app? Do they keep using it?
Yeah, we have the app designed for about 2-3 months with the content there, and we are now designing a clinical study to really validate this. It will be a prospective, single-blind, multi-center study in faculty hospitals in Czech capital, in Prague, and in other capital in Brno.
Okay. The app is free. How do you intend to survive if you're not going to have the users pay for it?
Yeah, that's the question. What are you when you are doing something for 300 people in your republic? Perceive Hello is something like from a likable initiative to sustainable social impact platform or startup. We are now funding from grants, from awards we have won, of course from private donations, and now we are in some talkings with Roche, pharma company that is producing the inhalation medicine for this rare disease. And the other part of our team is in other Roche accelerator. So maybe there is some another possibility.
Okay, great. Thank you so much and good luck.
Thank you so much. Congratulations. And now we have heuristics. And I think, hello?
Hello, Elena.
Hello, how are you? Yes, yes. We are
Fine.
hearing you, and now, yes, thanks on. So you can start, please.
Give me a sec.
Do you want to share your screen? Okay, yes.
Yeah.
It's perfect.
Is it working?
Yeah. Yeah.
Perfect. So let's start. Did you know that the 54% of misidentification errors inside hospitals are caused because identification bracelets? That's because the printing issues they wear off actually when the patient are using those, and some of the patients refuse to use them. So basically they take them away and they throw. And also some patients can swap them. So they take them away and swap between the patients. A normal hospital usually prints like 1,000 bracelets per day with a cost of almost €1 per each. So basically, the identification bracelets are not accurate enough and are super expensive. So that's why we developed the fastest, safest, and most accurate way to identify patients, biometrics. Our solution hasn't got anything to do with the biometric solution of the smartphones. Our technology is far more accurate. Basically, we first scan the patient fingerprint, then our artificial intelligence gets the measures on the fingerprint and creates a pattern. That pattern gets encrypted and we save it in our server. And then we link that encrypted code with the patient's information inside the hospital's own server. That's why we are compliant with GDPR. We don't have access to the patient's data, we just focus on encryption and artificial intelligence. Those are one of the main differentiators from our competitors. Basically, our solution gets smarter with each fingerprint, because actually with each scan, our solution gets smarter, faster, and safer. rather than our competitors that they just install their solution in the hospital server. Also, our solution is totally scalable because we are providing them with a cloud solution that connects like the hospitals, helping with the interoperability. Our solution is simple and scalable, as I told you before. We can integrate directly in the hospital's working program, or we can create an additional identification program for them. Then for the hardware, it's just a plug and play with a USB to the computer or with a technical tablet. Talking with our customers, we discovered three main areas. Basically reception, to identify the patients when they come to the hospital, and operating and recovering rooms to identify the patients before, during, and after the operation. We are also working with ambulance companies to identify unconscious and undocumented patients, just scanning their fingerprint in a matter of seconds. And we make a pilot with DIA, which is one of the largest ambulance companies in Spain. Actually, they loved the solution so much that they invested on us. We created a customer-based business model. This means that the hospital will have to pay per identification, and we have like special packages for them, and a renting of the devices. This means that they just are going to pay a monthly fee for the devices, and in case one device gets damaged, we can replace it in a matter of days. We have a super professional team with some PhDs in artificial intelligence, big data, doctors. Like, I don't want to go deep on that right now. We also have experts in all the fields, and we have two signed pilots with one of the largest ambulance companies in Spain and with one of the largest public hospitals in Spain, Osakidetza, in the Basque Country. We also are pending some pilots with private and public hospitals in Spain, and we've been in talks with two of the main largest private hospitals in Portugal, Hospital da Luz and Lusíadas. We also have been part of some of the largest healthcare acceleration programs in Europe, in Hungary, Czech Republic, Portugal, and non-healthcare acceleration programs. We have international partners that they help us enter the market and also deal with the pilots. And that's all. If you want, I have like an additional Q&A slide, so I will be more than happy to receive all your questions. Thanks.
Thank you so much, Anton. Maybe now I call Hugo, because Hugo, can you see us and hear us, Hugo?
Perfectly. Yes. Hello.
Hello.
Good. So thank you for the presentation. It's a very interesting project. I have a couple of questions, namely, now in COVID time, everything that has a touch-based interface is kind of a problem, and biometrics is one of those kind of problematic modalities. Are you only considering this as an interface? Do you plan on using things that are contactless, like facial recognition and others? So how do you see biometrics in the short term being applied?
Okay. First of all, face recognition doesn't work for health things, because actually, if you have like maybe a car accident or whatever, your face is going to be like inflamed or with blood or everything, and in case a change happens, it's almost impossible to identify. And this makes more difficult even with a mask. But actually, our lectors and our devices are rugged. This means that are water and dust proof. So basically, when a patient puts the fingerprint, the health staff can clean it just with an alcohol-like tissue, and everything is going to be like sanitary proof. So we don't have like any matter with that.
Another question I had was regarding your business model. You mentioned the renting of devices, which is quite cost intensive, at least in the beginning. Is this something that's really critical for your growth path, or because the devices now are commodities, is the device proprietary to you, or do you integrate from a third party, and what is the rough cost of the device for an integrator?
Yeah, great question. Actually, these devices are one of the most accurate devices in the world. They come from the United States, and they are actually used by the FBI. We are using these devices because to train the artificial intelligence, we need like super accurate fingerprints. Because, for example, if an accident happens and the fingerprint is damaged, with these devices we can identify it. But we are using a renting model because it's better for hospitals and better for us. Because, for example, the static device has a cost of around 150 euros, and the tablet costs around 1,000 euros, or 900 actually. So basically, the hospital, rather paying that cost, they will pay, imagine, like 10 or 15 euros per device each month, and in case it gets damaged, we can change it in a matter of days. That's why we are using like a renting model, because we don't want the hospital to invest a lot of money, and actually with a little investment, they can run a pilot. We actually have, in the third slide, I think that is this one, sorry. Oops. Wait a sec.
Anson, we don't have much time, so...
Yeah, it's just like a pilot for a hospital. Just it will take just 1,000 euros, basically with 3 static devices and 1 tablet, and 10,000 identifications per month, which is nothing compared to the cost of the identification bracelets.
Okay, thank you.
Thank you so much. Now we go to On Wheels, and we need a little bit of time to show On Wheels. Are you there? Yes. Joe,
Yes.
how are you, and Robin?
I'm fine. Robin, are you here too?
Yeah, you can start, please.
Yes, but I need to hear Robin too, because we are doing it together.
We are seeing Robin.
And
Can you
hearing?
hear?
Yes, yes.
Okay,
Okay.
so you can start. Thank you.
Hello, Lisbon. We are Robin and Joke from On Wheels. And I'm gonna start by telling you my own story. In 2013, I was in a rehab hospital where I met Michiel. I had a big surgery and he had a terrible accident. I took him under my wheelchair wings because he was a wheelchair virgin. After a while, we were allowed an evening out because we booked enough progress. But when you have a few drinks, you also need a toilet. And it wasn't difficult to locate the place, but it was on the 2nd floor with stairs. Our evening out was ruined, and we had to return to the hospital with wet wheelchairs. A few days later, the idea of On Wheels was born, and we promised to do better and to get cities on wheels for everyone. And we didn't do it for the both of us. We know this can impact 5 million wheelchair users in Europe, and worldwide, there are 1 in 6 people suffering from reduced mobility. So our goal is to get freedom for everyone, also for wheelchair users, and to get all the cities on wheels. How do we do this? We want that our users can rely on our data, and that's why we check all the information that is used in the On Wheels app. You will not find toilets on the 2nd floor with stairs in our app. Our users get to experience the freedom to choose where to go again. That is something you lose when you end up in a wheelchair. And that is what On Wheels can give back right now. But it doesn't stop by giving information. We also work together with cities. They can use the data we collect and work together with us. And then they can make the difference by really change the world for wheelchair users and people with reduced mobility.
At this moment, On Wheels has 2 platforms. We have a free app that everyone can use, and we also have a management platform more specific for cities. Our app has some amazing features. You can create a personal profile and see only what is possible for you. There's also an interactive map with more than 20 categories to choose from. And if you want more information, you just click on the icon and you get a lot of detailed and verified information. Our management platform is built for cities, and you get all the data of your city in one place. You can create lists of all the data, and in the future we're also going to add that you can make maps and charts.
We have an amazing team with a lot of wheelchair experience, also architectural background, and a whole team of IT experts. In the last 5 years, On Wheels has around 1,000 people using the app each day. And we have more than 34,000 verified locations in around 507 cities and 28 different countries. Our main focus is in Belgium now, but we want to grow. We also have a lot of amazing partners that helped us develop the first 2 versions of the app. How can you help us? You can download the app and share your favorite places with other users. As a city, you can also work together with us and use the data platform so you can make a city on wheels for everyone. You can also become our partner and sponsor and help wheelchair users become more independent.
And if we make this happen, we are sure that people that go out for the first time can celebrate without worries.
Thank you so much, Joke and Robin. Sophia, please.
Congratulations for the project and also for the presentation. A quick one. When you talked about how to turn cities better, can you elaborate a little bit more on that? Because I think it's really, really interesting.
The data we gather are data about the width of the doorstep or the width of the door of all the locations in a city. So if we can give this data back to a city, they can choose to make the less accessible places more accessible. And then you can really go and change a city. Then you can make little ramps for the least accessible places, and then you can make a city more accessible. It's just a small example to give. We have lots of them, but not enough time to explain them.
Sure, so you can be also a validation tool for cities, for instance, to be friendly for wheelchair users, for instance, like in a way. Imagine for a hospital or for the variety of hospitals and healthcare centers that might be a partner for yourselves?
Yes, of course. Yeah.
Thank you. I have no more questions.
Thank you so much. Now we move on to Step Up. Hello, Step Up. Are you there? We need to wait a little bit. Hello, how are you? Can you hear us?
Yes, I'm sharing my screen now.
Okay. We are not seeing the screen.
Yes, ready now.
Yes, you can start. Thank you.
Okay. Hello, everyone. I am Karthik, a CEO of Step Up Health. Sorry, I think I will change my slides quickly. Yeah, sorry for the delay. Hi everyone, I'm Karthik, a CEO of Step Up Health, and we are improving the life of COPD patients. And let's have a glance at the life of a COPD patient. Imagine having a cold or cough and not being able to go out and being so tired. And COPD patient's life is 10 times worse than that. And also it really reduces their self-confidence. And from a doctor's and a practitioner's perspective, and data collected from the patients at home is very low quality and very less. And it is because when the doctor asks the patient, how did you feel yesterday or last week, that response given by the patients is often very subjective, and it makes the treatment strategies very, very challenging. And it can also result in hospitalization due to the wrong information. And our value proposition is that we are radically improving the way it has been monitored at the current situation by enabling people to continuously monitor their breathing pattern, which will give objective data for the doctors, and also the doctors can better assess the treatment strategies And for the patients, it improves their self-confidence and also self-awareness on how their lifestyle affects their health conditions. And our product comes in 3 different forms. It can be wear around the chest as a strap, or it can be the medical grade patch, also integrated with the t-shirt. And we have a software to allow the users to track their progress. And our feature is, in essence, we are making the pneumography very simple and convenient for accessing at any settings. And we measure the breathing frequency and depth of each breath, and also the user activity level. Our market entry strategy is to get into the pilot telemedicine programs in Portugal and Denmark. It's because these countries really embraces the digital health and also health innovations. And our business model is based on the sales for the device and also a subscription model of 25 euros per month. Our traction is that we have a proof of concepts established, and also we have established partnerships with the hospitals in Portugal and Slovakia, and we are part of the Patient Innovation Bootcamp, and we are also getting in touch with the Danish public hospitals. Our next step is we are planning for market entry in third quarter in 2022, but our immediate focus is to get into the validate our market and also product and user needs. So we are a group of passionate people, extremely skilled in our each individual domains, and we would love to bring this innovation for the people. Let's improve the lives of the COPD patients together, and you can reach out to me in LinkedIn or email. We would love to talk to you if you find our product interesting and innovation relevant to you. Thank you.
Thank you so much, Kartik. Francisca, please.
Hi, thank you for the presentation. Have you done any clinical trial or clinical study already using your product?
No, we haven't done the clinical trial, but we have validated our data with the state-of-art technology for benchmarking our data. So we are pretty confident that it will really solve the problem, but the clinical trial, it's in the pipeline. We are getting in touch with the hospitals to start the process, but we are now in the process of a pre-clinical study assessment.
Thank you so much. And now we have Ali here from UV Mask. Ali, thank you so much for coming.
So should I start?
You need to. Yes.
Okay.
Is that yours?
Yes. Good morning. Oh, sorry. Good morning. My name is Ali Boudiaf, and I'll be presenting the ultraviolet respiratory protection mask. And this is my story. There's no sound.
Engineer. I discovered Lisbon 2 years ago, and I fell in love with this city. So, I decided to move and enjoy life in Portugal. I also decided to go back to school and do the Lisbon MBA. Then, COVID-19 hit in March, and I found myself locked. Life has suddenly changed.
Globally, we may be still nearer the beginning than the end of this pandemic, but we are continuing to see the rate of healthcare worker and nurses' infections rise and to receive increasing reports of the deaths of nurses.
Recent studies have shown that COVID-19 virus is airborne. It can travel up to 8 meters, carried by droplets. When a person sneezes, surgical masks can't filter particles smaller than 10 microns, while the size of the COVID-19 virus is about 0.1 micron. Olivier and I decided to put together a team of engineers, dentists, medical doctor, and pharma marketer to come up with a new solution. And we created the ultraviolet respiratory protection mask, which I am going to present to you.
All right, I hope you recognize the character. It was me. So the three features of this product are instant inhaled air purification based on ultraviolet LEDs, real-time monitoring using IoT sensors to monitor the physical characteristic of the patients, and a reusable mask that has an ergonomic design. Plenty of articles have been already published regarding UVC, and this is the design of the mask. It has two pieces, and the value proposition is that we provide the smartest way to keep you safe with no waste. We 3D printed the proto for less than 40 euros. The weight is less than 50 grams, and we believe that the production cost can be drastically reduced. We tested it with a nurse, and she liked it. She says there's no fog on the glasses so far. We believe there's a potential market for non-disposable protection masks in the medical applications. Right, so the next one. So why are I doing this? We do this because we care. We would like to provide healthcare workers with a highly efficient respiratory protection mask, and we believe we can do this better than the disposable masks. We are a small startup so far, 2 business partners. We are both PhDs in microwave and optoelectronics with more than 20 years of industrial experience. We are at the early stage. We are bootstrapping. The business model is medtech, B2B and B2C. We are working towards the first milestone to create a viable prototype and a solid business plan. And we started the French patent applications. So that's it for my presentation, and I will finish this by putting the mask so you can see how it looks like.
Thank you so much, Ali. Lights, do you...
I don't know whether this works. So thank you for the presentation, a very good one. And I hope it's not going to be needed as much, not because of you, but because of everybody else. I have 1 or 2 quick questions. So first one is, why is it needed all these IoT things and sensors?
Because we would like to monitor the health worker when she wears the masks, especially measuring the oxygen level in the blood, in case after a prolonged time of using this mask, there's less oxygen getting into her system. So it's a way of keeping the health worker under good conditions.
So I'm sorry for my ignorance, but you can measure the level of oxygen within the blood through the mask?
There's a small electronic device called oximeter. It's a diode that emits a signal, and we measure the reflection on the skin, and it will give us the
I think I have it here.
It works on the hand or on the finger. It's just a matter to put that device close to a vein that can detect the signal.
Thanks for this. And what is your IP protection for, intended? The IP protection, intellectual property protection, that you said that you're preparing an application in France?
Yes, we are using an innovative approach on how we use and bias the ultraviolet LEDs inside that assure that it is killing the virus. So it's a new way of using the LEDs inside the mask. That's the part we are trying to patent.
No more questions. Thanks a lot.
Thank you.
Pedro wants something.
Thank you so much. We have 2 more teams to go. So now we have WeWalk. Hello, how are you? Can you hear us?
Thank you. Yes, I can hear you. Can you hear me?
Yeah. Do you have slides to share?
Yes, I will, and I will share it.
Okay. And then you can start. Thank you. Yes.
Okay, perfect. I'm so happy to be here today. We have been listening amazing technologies, and we all witness how fast technology advances every single day. And we even speak about self-driving cars, flying autonomous vehicles, etc. Here is the question. Although technology has advanced so much, as a blind person, why am I still using just a plain stick? Hello, my name is Kürşat. I am blind from birth, and I'm co-founder of WeWalk Smart Cane for the visually impaired. It was 3 years ago, I was in New York to give a speech at the United Nations, and I was going my hotel. While I was going my hotel, I was using my traditional white cane and holding it with my one hand. At the same time, I was holding my smartphone in order to check the GPS direction. At the same time, I had to pull my luggage, but I have two hands and my two hands are occupied, and I used these 3 fingers for pulling my luggage. And all of in this chaos, I bumped into a pole. And right now, that's why you can see some scars on my front head. This is not only my problem. According to World Health Organization, there are 253 million visually impaired, and according to European Blind Union, 75% of visually impaired are unemployed. This situation causes 28 billion pounds loss of the UK economy. We believe these statistics must be changed, and the first step to change these statistics is to provide full and equal participation opportunity to social life for visually impaired. That's why we created WeWalk, and WeWalk detects overhead obstacles and alerts its users. Also, as a second feature, WeWalk can be paired with our smartphones. And it means I don't need to hold my smartphone anymore while I'm getting navigation, etc. I can put it into my pocket and I can keep managing my process, my smartphone over WeWalk's touchpad or microphone with the voice assistant of the WeWalk. As a third feature, I like this feature the most. WeWalk can gain new features with the software updates. WeWalk can integrate with the smart city solutions. For example, right now, I can check which bus is approaching the bus stop while I am waiting at the bus stop. Our vision is to make WeWalk a personal hub for visually impaired, where they can reach all sorts of information and technology over WeWalk. And luckily, we are not alone in this journey. We are partnering, we are collaborating with the Imperial College London with the support of the UK government. Moreover, WeWalk is a Microsoft AI for Good company. It means we are collaborating with the Microsoft to increase the AI capacity of the WeWalk. WeWalk has been chosen as one of the best inventions of 2019 by Time magazine, also awarded by the Thomas Edison Foundation, and WeWalk was in the news over more than 250 different sources. But most importantly, the most important award, we believe, is to create an impact all over the world, and to succeed that, we are partnering with the largest blind organizations such as RNIB from the UK, Lighthouse Guild from the USA, or RSB from Australia. And so far, WeWalk is used in 37 different countries by the visually impaired, and we are looking for more opportunities, more collaborations with the private sectors as well as government, municipalities, because municipalities buy WeWalk and distribute to their citizens and governments as well. And some private companies are making their own social awareness campaigns with the WeWalk. Thank you for listening to me.
Thank you so much. Hugo?
Yes. Thanks for the presentation. It's quite interesting. How do you see this scaling up and being industrialized? I see that you are quite advanced already. So what's the next step for this technology in your opinion? And also the comparatively to the competition, what's the main bonus? If you could develop a little bit more on that.
I can start with the competition. We have some indirect competitors. For example, Sunu. Sunu is a band. It's not a smart cane, and they are also providing some technologies for the visually impaired to make them more mobile. But WeWalk is differentiate itself with the its technology, because we believe that visually impaired people doesn't need any extra device, because as a blind person I am already using white cane, and also I'm carrying my smartphone. I cannot give up to use it, and we don't want to add one more device into visually impaired people's lives. Instead that we built a smart cane, because visually impaired people are already using white cane. We thought that instead of holding just a plain stick, since we are in 2020 right now, we can build that kind of technology. And right now we got very positive feedback from our users. As I stated in presentation, in 37 different countries, we are in the right direction. In terms of the technology development, right now we are developing AI technology for mobility trainers, because there are mobility trainers. These people are teaching how to use white cane to visually impaired people. However, they cannot they cannot monitor their students. After the class, they don't know how am I using my white cane. Am I writing randomly, right and left, etc., or am I using properly? So with our AI technology, we will provide feedback to both users as well as their trainers, how they are using their white canes, and also we will provide feedback to improve their white cane usage as well. So we are working on that kind of development, and also we will be in the Series A round in 2021. That's why we will scale up our technology in both European Union, USA, and Australia deeply.
Thank you.
Thank you. Thank you. And now the last but not the least, 11else, the last team that we have here in competition. Hello.
Hello, Elena.
Hello. How are you, Jean-Michel?
I'm fine, thank you. I'm sharing my screen. Do you see my screen?
Yes, yes, you can start. Thank you.
Hi, everybody. I'm Jean-Michel Edreux. I'm a Crohn and ostomate patient. As you listen, I'm not a fantastic English speaker. I'm a French guy, but I'm trying to presenting to you the 11else project called Alfred Smart Care. This is Michael, my friend and founder of 11else. He was a Crohn patient with a severe form of the disease. Unfortunately, in May 2020, Michael didn't win the last fight. We met 10 years ago. We have had the same passion for patient advocacy. And our mission, our plan, our idea is improving the quality of life of ostomy patients and people who are living with chronic disease, like Crohn, like colitis, like colorectal cancer, endometriosis, polyposis, and so on. And for this, we use the technology, the data, and patient support network. Our solution, our approach is adapted for the main type of ostomy. The first one is ileostomy, created from the small intestine with liquid feces. And the second is colostomy, created from the large intestine. And the main difference with the other is the formed stool. The problem. The cost of readmission per patient is high, 14,000 euros per patient. Why? Because too many patients are first readmitted to hospital for dehydration, for skin complication, for renal failure, and much more visit than average the other disease. The ostomy market and ostomy care, it's a huge market. It's $25 billion in the world. And sadly, with Michael, we haven't seen much innovation in ostomy bag and ostomy care. And for us, too many patients are staying isolated. Too many patients didn't know how the dehydration could be dangerous for them. And too many patients suffering alone. And now we want to stop this. We are in 2020, not to the prehistoric period. And that's why we want to deliver a digital health solution for chronically ill patients and ostomate. By creating sensor into a medical device, and then to collect information to have a better understanding, patient need, unmet need, and understand and improve the patient pathway. Our solution is more than a set of sensors. It's a solution for each stakeholder in the ostomate patient pathway. And our program, will act a crucial care management tool for all stages of the patient journey, before the surgery, during the hospital, and in recovery at home. And what 11L6? We want to find an investor for 11L's capital and find partnerships. The past 8 years, like you see here, we work a lot. We created strip sensor. We built our own smart bag and wafer, developed all digital solution. We clinically validated everything and we patented it. Now, for the final one, we need to raise money for initial commercialization. In the 5 next years, we would like to provide our program and product to 26,000 patients in US and in Europe. Thank you very much for your attention. If you need more details for figure or market, I'm there.
Thank you so much, Jean-Michel. Sophia, do you want to ask a question?
Sure. Jean-Michel, first, thank you, more than congratulations for being here, and I'm really sorry for Michael. Your solution seems to be really impactant, and you have a full idea of the problem. So could you please explain us a little bit more of your vision on the expansion of these? Because it's being a medical device is always hard. So can you give us a little bit, a blink of the future?
And the next, you want to know the next steps?
Yes, to expand, yes.
We finished the clinical trials in US with Cleveland Clinic, and we are ongoing to connect all the codification with insurance to the US. In France, we are start clinical trials with several CHU in France to validate the process. And when we validate it with hospital, we have to go to commission for the reimbursement for the patient. And it's almost 2 or 3 years. And the aim of this clinical trial in France is to get the reimbursement for all the patients. Reimbursement for the product and reimbursement for the program with the patient coach. The patient coach will be able to support the patient before the surgery and after the surgery.
Can I ask just a short question too? Regarding the price, is it similar to the normal bags or is it much more expensive?
No, it's more expensive. It's not the same product. We don't want to be a company who manufacture a bag. We have a lot of services around the bag. It's not just a product. It's really a program, a very good program for all new patients. You know, we suffer a lot with Michael regarding our disease and with the ostomy. And we don't want that the young patient who discover the disease life have the same life than us. We want to improve that. And that's why we can compare the price of the product, but it's a global solution.
Thank you very much.
Thank you so much, Jean-Michel. And after these brilliant 9 presentations, we will have a winner, and our jury is voting. And I ask Pedro.
So I would like to invite the members of the jury for a short meeting here, and if you wait, the ones that are at home or here in the auditorium, in a few minutes we will be back with the winner.
Okay, but please be quick.
Please don't leave us. Yes, we will be as quick as possible.
You have 2 minutes to decide. Just 2 minutes. And after this session, we have a lunch. I think I can speak in Portuguese. Nós, depois desta sessão, que vai terminar há 1 hora, temos o almoço e voltamos depois, como sabem, às 2 horas com mais sessões. A sessão das 2 horas será uma presencial, mas terão 5 sessões simultâneas online. Podem encontrar os links no site do Encontro Ciência e por streaming teremos a divulgação da sessão que ocorrerá aqui no Auditório 1 e todas as outras sessões têm links próprios que são feitas as ligações através de Zoom. E que podem encontrar na página do site. Depois teremos ainda mais 2 sessões plenárias que decorrerão aqui no Auditório 1, serão sessões únicas e ao fim do dia o encerramento do encontro que será feito hoje ao fim do dia pelo Sr. Presidente da República. Let's wait 1 minute more. We are waiting for the jury, And as you saw, we saw some presentations from patient entrepreneurs, and these type of innovations that are developed by the patients are now quite important, because the patients feel the needs, and then they can develop and think in some solutions. And in the patient innovation site, we have around 2,000 innovations that were developed by patients. Some of them reach the market, because some of them are patient entrepreneurs, but there are also some strategies, other products that you can see, and this can help lots of people. And please think that the patients and the caregivers feel some needs that the conventional medicine cannot solve, and with that they can improve their lives and the lives of others. So look, the www.patientinnovation.com, and you can see how these brilliant solutions can help all of us. And I think they are returning now. Sorry, a more minute. Eu penso que estão já a voltar. Aproveito para lembrar de novo que durante a tarde vamos ter várias sessões aqui no Encontro de Ciência, e vamos continuar a perceber como é que a ciência em Portugal pode contribuir para uma Europa mais resiliente, mais social, mais digital, mais global. Logo à tarde teremos também a participação de Robert Langer e de Eric Van Nippel numa sessão como recuperar com mais ciência toda a Europa, e eles são speakers que têm contribuído bastante para, com novas tecnologias ou com novas teorias, nomeadamente com o User Innovation, e o Robert Langer com a biotecnologia, a trazerem-nos inovações. E depois, ao fim do dia, Elvira Fortunato e o Pedro Conceição irão fazer as suas palestras e a sua apresentação para fecharmos com chave de ouro este encontro. We have the jury now. I think you took too long.
Because it was interesting.
Yes, interesting, but people are waiting. So we will announce the winner.
So, the jury has reached the conclusion. In fact, in a way, you are all winners. That means that all of you will actually get a very nice piece of crystal like the one that I am holding now. It's crystal from Portugal. Very nice piece, I can guarantee. But we have not just one big winner, we have two big winners. The jury decided that instead of giving the prize to one team, two teams should divide the prize. The money prize, that means that 1,000 euros will be divided by two teams. And the two winners are BL glasses and UV masks. So thank you all, congratulations to all. Let me now call our Ministry of Science and Technology to say a few words and to congratulate all of you.
Let me congratulate all of you and certainly the Patient Innovation team. The work of this final session is just a small sample of all the work done over the last more than 10 years, and certainly this is a continuous effort that you should all very, very proud. I believe, as Pedro mentioned, all of you are winners of a long trajectory that will not close here, will certainly continue, and my role is essentially to support you, to support the work you are doing, certainly the team behind the patient innovation that certainly will keep this for longer and for many, many more years. Thank you very much for your commitment. Thank you.
Thank you so much.
If technology had an identity, it would have ours. If technology had a place, it would be right next to us. If innovation had a trademark, it would be Carnegie Mellon Portugal. First, let's forget the ocean between
Good afternoon, everyone. Welcome to the CMU Portugal session of the Ciência meeting. We have the pleasure to have several representatives of very interesting research projects that are going on in the context of the CMU Portugal program. And to frame the program, we will start by presenting a short video about the CMU Portugal partnership before I present the individual speakers.
If technology had an identity, it would have ours. If technology had a place, it would be right next to us. If innovation had a trademark, it would be Carnegie Mellon Portugal. First, let's forget the ocean between us. This is a partnership that brings together the know-how of Carnegie Mellon University, a world-class institution from the US, with the experience of the best academic and industrial institutions in Portugal. Since its foundation in 2006 by Fundação para a Ciência e Tecnologia, CMU Portugal mission has been to join forces and place Portugal at the forefront of education, research and innovation in information and communication technologies. So far, the task has had nothing but success. Why? Because we are focused on exploring new research frontiers in areas such as computer science, electrical and computer engineering, public policy, human-computer interaction, software engineering, robotics, and language technologies. Our overarching mission is to foster industry-science relationships as agents of change, focusing on education and research for social and economic impact. Here's how we've been achieving it. Through dual-degree PhD diplomas between Portuguese universities and CMU, and supporting mobility programs to give Portuguese researchers and students the opportunity to visit CMU and establish the ground for new research collaborations. Research is a keystone of our partnership, and we are strongly committed to supporting groundbreaking projects in ICT, fostering interdisciplinary collaboration between industry and academia. Throughout the years, we have financially supported already over 72 collaborative projects. Recently, the most ambitious call under the program of the CMU Portugal. For the first time, 10 research projects are led by Portuguese companies, representing a strong public and private financial commitment to foster the cooperation between researchers from Portugal and CMU with national companies, promoting innovation and technology development for a global market. CMU Portugal has also been a hub for entrepreneurial initiatives, with 12 startups launched or facilitated by our activities. Together, they contributed to over $200 million of international investment, which allowed the creation of more than 1,000 qualified jobs. Most of all, we are proud of having built a strong research community that contributed effectively to an impressive number of publications, registered patents, and successful PhDs and master's theses. But the best is yet to come with new research projects and initiatives, connecting companies and academia on both sides of the Atlantic. This collaboration will keep on contributing to thrive in the innovation ecosystem. One thing is guaranteed: we will keep doing everything in our reach to bring technology into people's lives for an even brighter future.
Thank you. So I forgot to introduce myself. My name is Rodrigo Miragaia Rodrigues. I am the co-director of the CMU Portugal program in Portugal. The other co-director is my colleague Nuno Nunes, who joins us online. And on the CMU side, the other director is Professor José Fonseca de Moura. I'm going to give you a short presentation about the CMU Portugal program. The program has been in place for well over a decade. It has proceeded in a series of stages. We are now entering the third stage. The first two stages were, next slide please, yeah. The first two stages were in approximately 5 years each. And in this third stage, our goal is to create an innovation ecosystem with high-tech companies and world-class research to develop knowledge in the area of ICT, and in particular by developing the data economy and trying to help these highly innovative companies extract value from their data. Next slide, please. The program has essentially two main pillars. One of them is talent development. In that respect, we are offering several, next slide please. We're offering several types of programs. We have dual degree PhD programs where students spend about half of their doctorate studies at CMU and the other half in a Portuguese university, and they have co-advisors in both locations. We're also developing two advanced training programs for professionals, one in data science and the other in user experience. This is something that we hope can be ready within the next few months. We also have mobility programs that allow students from Portugal to spend a period at Carnegie Mellon, and also for faculty and researchers to spend their a period in Carnegie Mellon, for instance, in their sabbatical year. Right now, we have an ongoing call for our dual degree PhD program. So any student can, in the areas of ICT, can apply, and in this program, the students, after they complete their PhD, they are awarded degrees both from a Portuguese university and also from a counterpart department at Carnegie Mellon. And we have agreements ongoing with a variety of different degrees at Carnegie Mellon and different departments at Carnegie Mellon, ranging from computer science, electrical engineering, engineering and public policy, and other areas. Next. The other main pillar of the program is knowledge creation, and here we have funded a series of research projects throughout the years. And in this long list, you'll notice that we have not only a variety of different types of projects. Some of them are more applied, others are more blue sky, and also with a variety of durations and different types of research being conducted. The focus of this particular session is on a set of large-scale collaborative research projects that have started this year. And in this call, we have funded 12 projects with a total investment of 24 million euro, of which 4.3 correspond to private investment and 6 million correspond to the CMU investment. And of these 12 large-scale collaborative research projects, we have a series of companies that are involved with the universities, with the researchers, both at Portuguese universities and at Carnegie Mellon. And as you can see by the list of industry promoters and co-promoters, we have a series of highly innovative companies that really invest in knowledge and in research and to develop cutting-edge products and to be on the forefront of their areas. These projects are in collaboration, like I mentioned, with Portuguese universities and with Carnegie Mellon, and we are also pleased to have a variety of departments involved in these collaborations. We have a total of 8 Carnegie Mellon departments involved in these projects, and with 17 different research institutions in Portugal also involved in various different locations of the country, corresponding to those institutions. Next. Today we'll be hearing about 3 different projects in the area of healthcare. We believe that this is a strategically important area because it is an area that has a very important interface between information and communication technologies and their own research. And we will be hearing, and I will present you later, 3 different projects, 3 key people involved with these projects. The projects are called Intelligent Care, TAMI, and WOW. And next slide, and that's it for now. So next, what I will do is I will ask if Nunes is online, if he wants to say a few words before I present the speakers.
Thank you, Rodrigo. I'm not sure if you can hear me
yes,
in the room.
Yeah. Yep.
Okay, thank you, Rodrigo. I'm sorry I cannot be there due to problems with getting back to Lisbon. I just like to congratulate everybody for all of the effort, all of the students, all of the researchers and the projects and the companies involved, and hope for a great session that I will be trying to attend if my plane doesn't start. Thank you very much again, and apologies for not being there.
Okay, thank you, Nuno. So I will then move to introduce the speakers. Let me start by thanking all of the speakers. 2 of them are here with us today, and the other 2 are online. And I'll introduce them one by one before they do a short presentation of their own involvement with the program and projects they are leading. So I will start by introducing my colleague from CMU, Carmel Majidi. Carmel is the Clarence H. Adamson Professor of Mechanical Engineering, and he has a long history of collaboration with the Carnegie Mellon Portugal project, and I think he's going to tell us a little bit about how much he has benefited from that collaboration. So thank you again, Carmel, and the floor is yours.
Thank you very much. It's a pleasure to present to you, and I've benefited immensely from this program, so I'm very eager to share the work that I've done in collaboration with my colleagues at the University of Coimbra in ISR on work that we've been doing on soft and stretchable electronics for applications in wearable health monitoring in medicine. And for the WOW project that you'll see towards the end of this the meeting, a lot of the work that we plan to do in collaboration with the rest of the WOW team will build on some of this work. So soft electronics for wearable computing is a very hot area of research. There's been really tremendous progress over the past 10 or so years on developing sticker-like electronics that can adhere to the body and be used for all sorts of different sensing modalities. And these sticker architectures have a variety of different material compositions and designs. In terms of emerging applications going beyond healthcare and physiological monitoring, these architectures also have application in haptics, and in particular, they have the potential to make haptics thinner, lighter, softer, and more compatible with the human body. So also a very exciting direction of research. And also, increasingly, there's been interest in using these soft electronics for energy harvesting, in particular, placing various types of energy harvesting transducers or generators on different parts of the body and using that to generate electricity from body heat, motion, and friction. And this is another area that my group has been involved with and also represents another exciting thrust in this field of wearable electronics. Now, in all these cases, there is an important design challenge, which is how do we get soft materials that are compatible with the human body and engineer them in ways that they can exhibit functionalities that we typically associate with much more rigid electronic materials. So we want to get sensing, electrical circuitry, computing elements for signal processing, and we want to package this in a way that the sticker or that wearable device has the same elasticity and the same compliance as our natural biological tissue. And so this represents a really important challenge in engineering. I call this soft matter engineering because it involves incorporation of soft materials. Closely tied to this is the challenge of soft materials integration. With most of these implementations that we've been exploring in our collaborative efforts with our colleagues in Portugal, we've been using a combination of soft materials and also rigid microelectronic components. So the soft materials function as a carrier medium. It also functions as highly stretchable and soft electronic circuit wiring to create interconnects between these embedded chips. And the chips are necessary for various sensing modalities along with signal processing, power regulation, and also wireless communication. Ultimately, though, the overall package system should be thin, it should be lightweight, and it should be soft and elastic so it can be compatible with the human body and remain functional without resisting natural motion. Early in my research, before our collaboration through CME Portugal really took off, a lot of our early work was on serpentine electronics. And this really built on research from other groups at Princeton and University of Illinois and Northwestern on creating stretchable electronics using conventional electronic materials like copper and gold, but patterning them in ways that they have this stretchable functionality. So you can see in the top left and to some extent in the top right images, the copper wiring used to connect all of these surface mounted electronic components have this serpentine type shape, and that allows these circuits to bend and also stretch to some extent. Here's a video of a more recent implementation that shows how these circuits are incorporated into these wireless stickers. I'll let the video play out here, but you can see the layup where we have a fabric, we have the skin adhesive at the top, and we use laser micromachining to cut the copper circuitry, these traces, to form these electrical interconnects between these surface mounted components. So for us, this had represented the state of the art of what we could achieve with soft and wireless electronics that you could adhere to the body and use for physiological monitoring. However, in a minute, I'll talk about some of the fundamental limitations of this approach. As a prototyping method, and as for making these kind of one-off implementations, it's a good enough solution. As you can see here, we can, within a few hours, use rapid prototyping to create this body-mounted sensor for monitoring knee motion. The serpentine shape of the wiring allows for fairly robust functionality. We can stretch these to about 50–60% strain before the digital electronics fail due to mechanical rupture. Here's just a few examples of various types of sensing modalities that we can achieve with these serpentine electronic circuits. Now, I mentioned that these do have limitations. One limitation is that manufacturing of these can be fairly intensive. In a lot of cases, if we want to scale this down, to kind of microscale circuit architectures will require a clean room fabrication. And another issue, as you can see on the bottom right, is that we get delamination between those rigid copper interconnects and the surrounding soft rubber substrate. So a way to overcome those fundamental challenges with internal mechanical failure and delamination of those serpentine circuits is to replace the copper with conductive elastomers. And typically, these elastomers are composed of either silver or carbon filler that's embedded within a soft rubber matrix. And this allows for electrical percolation and electrical conductivity. And this is what we started with in our collaboration with ISR at University of Coimbra. So working with Anibal Almeida and Mahmoud Tavakoli. This is Mahmoud's lab on the left here. And this has been an incredibly fruitful collaboration. So I want to spend the next few slides talking about the progress that we've made developing soft electronics in this collaborative effort. Now, we started by using the more conventional technique of carbon-filled elastomer composites. So these are soft silicone rubbers that have a very high concentration of carbon powder. The carbon itself is electrically conductive. So by having a very high concentration, we can form electrically conductive pathways within the rubber. And this has been very effective for creating all sorts of resistive and capacitive pressure and strain sensors that we've been able to incorporate into a robotic hand prosthetic that Mahmoud's lab has developed. And this has led to several publications that we prepared in the early stages of our collaboration. Since though, we've largely shifted to liquid metal as a soft conductive material. As you can see here in this video, if we put a microfluidic trace of liquid metal within a strip of soft silicone rubber, we can get highly stretchable circuit wiring. And this overcomes a lot of the challenges with the serpentine copper traces, or for that matter, these particle-filled elastomers. We have very high metallic conductivity, but because the conductor is fluidic, it can deform almost infinitely as the surrounding rubber is stretched. And so I'll just very briefly show some of the work more recently that we've been doing with Mahmoud's lab in incorporating these liquid metal electronics into soft bioelectronic stickers. The first effort with liquid metal involved the creation of these biphasic circuits, and this was a discovery made in Mahmoud's group. They were experimenting with printing silver ink using just a standard desktop inkjet printer, and then they would coat it with this liquid metal. And the purpose of the liquid metal was to dramatically enhance the electrical conductivity in the traces, but also make these much more mechanically robust. And so when we transferred it to the body, or when we subjected the circuitry to bending or stretching, the liquid metal would help keep all those silver particles connected because of its ability to deform and stretch and flow with the surrounding rubber. Here's an example of a study that Mahmoud's group had led, where we assisted on exploring soft bioelectronic applications with liquid metal. So as you see on the left, we compare our printed liquid metal circuits with a variety of other soft conductive technologies, as well as gold standard technologies that are used in commercial bioelectronics. And what we found is that the liquid metal architectures tended to outperform even those gold standards. And so this has been very promising, and this is what has inspired us to adopt these technologies for this WOW project. Here's a example of a fully integrated soft electronic sticker that's capable of electromyography, so EMG monitoring of muscle activity. And here, because of the high performance of our soft electrodes, and also because of the mechanical robustness of those liquid metal interconnects, we can have very good conformity with the skin and very accurate reading of muscle activity. So in terms of future challenges that we and others need to address for further progress in this field of soft bioelectronics, one of the challenges is still due to mechanical failures. In the case of liquid metal interconnects, the failure doesn't occur at the interface between the conductor and the rubber, as you have seen before with the serpentine circuitry. Instead, in these cases, the failure tends to occur at the interface of the embedded microelectronic chip and the surrounding silicon. So that's something that we're currently facing, and there's a few solutions to that. Another area, as I mentioned, is in the field of energy harvesting and also energy storage. All the batteries that we use currently are these rigid lithium polymer batteries, or these coin cell batteries, and what we need moving forward are soft, flexible, and even stretchable batteries. So the bottom video shows a stretchable battery that we've recently created in my group that can remain functional even when stretched beyond 300% strain. Energy harvesting represents another important challenge. So the video in the top shows some recent work where we've developed a triboelectric generator using liquid metal rubber architectures that we can incorporate into a pad that we place on the kneecaps of a jogger. And as the jogger runs, that repeated contact between the skin and our liquid metal generator creates triboelectric charging, and the change in capacitance associated with that between the charge and the counter electrode results in the generation of electricity. And as we get towards the end of this video, you see that after several minutes of running, we can charge up a battery and use that to then power a wearable computing device. So in a few seconds here, you'll see that now that the battery is fully charged, we can activate this device. You can see that the digital display turns on, and we can also operate the embedded microprocessor and also onboard sensors for temperature and humidity monitoring. The top right shows some other kind of recent early effort from my lab on thermoelectric energy harvesting using these liquid metal components. Another direction or outcome of this collaborative work has been spin-off companies. So we know that, for the CMU Portugal project, entrepreneurship represents a very important aspect of these funded efforts. And so we've had not one, but two spin-off companies derived from this project. So Soft Bionics, led out of Mahmoud's lab, so based in Portugal. And then based out of Pittsburgh is Life4 Labs, which I co-founded with a postdoc who was supported on the CMU Portugal project, and who also had the opportunity to go out to Portugal to participate in that collaboration. So in terms of next steps and future work for the WOW project, we want to build on these liquid metal architectures. We actually want to move away from onboard batteries and power sources and shift towards wireless RF technologies, not just for wireless communication, but also for wireless transfer. And so both Mahmoud's group and my group have had some good preliminary success achieving that with these soft liquid metal stickers. And then another important challenge is microelectronics interfacing. And so we've made a lot of great progress through this collaboration. And most recently, on the right is an image from Mahmoud's group showing a more recent implementation where we have even more robust electrical interconnects and contact interfaces with microelectronic components. And then lastly, something that both of our groups are pursuing is studies on biocompatibility and cytotoxicity. This is not so much a factor for on-skin applications. The liquid metal is fully encapsulated within the rubber. But if we ever do want to use these materials in implants or for direct contact with internal tissue and organs, then we do have to better understand the biocompatibility of these materials. So I'd like to close by thanking both research groups, so my lab at CMU, the Soft Machines Lab, and also Mahmoud's Soft and Printed Microelectronics, and then more generally our collaborators at ISR and Coimbra, and then the sponsors for this work. So thank you.
Thank you, Carmel. That was fascinating. I understand that you have to leave for a prior commitment, so you cannot stay for the debate, right?
That's correct. Unfortunately, I will have to. But thank you so much for giving me this opportunity to present work on our collaboration.
Oh, thank you. Thank you for a great talk. So I'll move on. But by the way, nonetheless, we will still hear more about the WOW project because Margarida is here and she will be able to tell us a little bit more about the project. So thank you again, Carmel. And let me introduce the next speaker, who is Francisca Leite. Francisca has a doctoral degree from MIT, so she's switching camps from MIT to CMU in this role. And she is here as representing the Intelligent Care Project. Francisca is with the Hospital da Luz Learning Health, which is a partner of this project. Please.
Thank you very much for the invitation. Very, very happy to be here to tell you about our project. So it's a project financed within the CMU Portugal program. And I think nowadays everybody really thinks about this healthcare world and what is the future and all the challenges that we are now encountering. And we know what these are at this point. We know that we don't have enough hospitals, we don't have enough people, we don't have enough equipment for what we need at these days. Of course, these are not normal times, and these will pass, but still, this is not something from today. So we know, and we have been seeing this for quite some time now, that the healthcare spending as a percentage of GDP is growing in many, many countries, and it's actually been increasing to the double in the last 30 years in many countries. And this is mostly because of aging. Population is getting older, is getting more chronic disease, and chronic diseases are responsible for a lot of this increase. But at this point, what we see is that this probably won't be sustainable much longer. So we really need innovation in healthcare. We really need, and we are doing this, fortunately, worldwide, from universities to hospitals. We're really getting new treatments, new diagnostic procedures. So there's a lot of innovation going on. The problem is that innovation is also expensive, and it's not enough. It's not enough to have a new drug, or it's not enough to have a new MR machine if people then over-abuse healthcare, or if lifestyles don't change in a way that we also are able to reduce demand on the system. And also, once people get to hospitals, it's absolutely crucial that the hospitals work extremely well. Unfortunately, again, this is very difficult because healthcare is very complex. We have disease complexity. Diseases are complex. We have more and more diseases. We have diseases of the old that we didn't even know existed before. We have diagnostic complexity. We have more and more ways to diagnose. That's great, but on the other hand, which one to use in a given disease, in a given circumstance, is also something that has to be planned and has to be done in a specific way so that we really get the best diagnostic possible and that we don't overspend. We have treatment complexity. Again, we have to follow very rigorous guidelines to make sure that we're doing the best for the patient that we have, and again, that we don't overspend in doing things that are really not needed at the time. We have workflow complexity. We have a care that is more and more multidisciplinary, involving very large teams. And if there's no communication, if teams don't work in the best way possible, then there's medical error, and there are people dying from that. And it's something that is a really great problem. It's the third cause of death in developed countries because there's just too much complexity going on. And so with all of this complexity, innovating, changing, of course, is also difficult. We hope, and there's a lot of people talking about AI, and in many sectors, and also in healthcare, there's this hope that AI will really change and help across all of the areas of healthcare. There's even those that believe that AI will replace what the doctors do in many, many different areas, and in the end, the doctors and the nurses will have time for what is actually the most important thing, which is spending time with the patients, explaining the treatments, and really empathizing with the patients. Of course, this is still kind of far in the future, but that's the hope. And also, healthcare will help, artificial intelligence helps in another way, which is basically putting us more in control, the patients, in control of our health. We have more and more apps that we can put in our phones, and that will help us diagnose or even monitor diseases, and that will also bring us a lot of data, that structured data that we don't really have available in the hospitals in a useful way sometimes. So there's a lot that AI can do for the field. We're not there yet, but there's a lot of hope that will really help to really bring healthcare to the future and to be more sustainable. And that's where our company comes up. So Learning Health is a startup inside Lucia Wood's group. It was born from the desire of becoming more than an early adopter of technology. And so we were born to with a mission to shape the healthcare workforce of the future. So in the middle of all of this complexity, in the middle of what we know is a business model that really is not sustainable and needs to change, what can we do? How can we train people to understand this, to act on this, and to really innovate? And we do this putting together these three pieces: training, research, and innovation, supported by a simulation center, one of the most simulation centers in Europe. We are not alone, of course. We are in an ecosystem of innovation with other companies, with universities, and also with startups, because with this such a big challenge like healthcare, we need to really have a network approach. It's not enough to think that only hospitals will deal with this, or only the large corporates, the large pharmaceuticals, or only the governments. This is something that we all need to participate, from the patients to the startups to these corporates to the universities. So this is where we are dwelling. And in terms of research, we have all of many different interests, but mostly concentrated in three areas: AI, of course, human factors engineering, which is very important, and I will explain later why, and also clinical research, always to bring value for patients, because of course that's the most important thing. So what about our project, Intelligent Care? What we aim here is to build a multimorbidity decision support tool to help doctors and patients and hospitals will deal with this condition. So what is multimorbidity? Multimorbidity is typically defined as having more than two or more chronic conditions simultaneously, which is something with aging has been, we have been seeing this growing quite a lot. So prevalence has been increasing exponentially, and nowadays people older than 65 years old, we see that at least 35% of them have at least two chronic diseases at the same time. And again, this complexifies care in many, many different ways. This is a very ugly graph from a very beautiful paper that basically shows that as you add more conditions, of course, treatment complexity increases, and particularly when we're dealing with systems, healthcare systems, where more and more people are being treated by specialists and not so much by the family doctors and the GPs, what we see is that we have a siloed approach to this. And so what many times happens is that different specialists will give different medications to the same symptoms sometimes without, and these will, of course, again, have some not so good outcomes. And again, there's also other problems that we really didn't know, and now with data we're starting to realize. Again, a very ugly graph from a very beautiful paper, basically showing that symptoms that are often, there are signals of heart failure, like for instance, fatigue, or shortness of breath, or pain, and typically a cardiologist will treat a patient for shortness of breath and for fatigue, thinking it's due to the heart failure. But the thing that we see is that most times these are actually related to comorbidities like diabetes or COPD or renal failure. And if this patient does not go to the pneumologist or the renal specialist, won't be treated for these in the right way, and will keep showing these symptoms, and at some point we might be taking too much medicine. So what do we aim to do in Intelligent Care? What we want to do first is to be able to detect multimorbidity very early on, so that we can start treating these people for the conditions they have in the right way, in a personalized way as well, because we know that there's many different types of clusters of multimorbidity. People can show heart failure with diabetes, but this can also vary depending on the lifestyle this person has, or it can show also heart failure and COPD. And so there's different profiles, and also putting together these with other variables that we can measure, we can adapt the way we treat these people so that they will go less to the hospital, so that we can, at the right time, anticipate if there's something that is going to happen, prevent an urgent visit in the middle of the night that in the end will have the patient stay in the hospital, which is something that all want to avoid. As I said, we're going to do this using data that we already collect in the hospitals, but also in a second stage, getting all of these additional data from patients, from sensors, from questionnaires that people can also fill in at home, and then we get this data about the quality of life, the physical activity, sleep patterns, life events, and all of this data we know and we hope to show that will really change the way these people are treated. So we're doing this using data, as I said, from the hospital and also home care. We're looking at structured but also unstructured data. We're trying to identify these clinical phenotypes and then build this, what we call these clinical pathways, basically for a given cluster of multimorbidity patients, what is the care that we need to do? What are all the steps that we need to go through to make sure that the patient has the best care and the less complications? To do this, we have a very strong partners from Técnico, INESC, ISR, Pribera, that will really help us in all of these projects to get this thing done. In addition to Learning Health, we also have the participation of Hospital da Luz, and this really will only be possible with a multidisciplinary team. So what, in fact, are we doing here? So again, just going through this a little bit more in detail, what we want is to identify these patients with multimorbidity. We want to know how to characterize these patients. We want to be able to build the evidence and build these clinical pathways that will allow us to treat the different patients in the way that is the best for them, and also to understand and show how these additional variables will be able to improve multimorbidity management. This is all great, and I'm absolutely sure that we'll get a lot of things from data, and we'll be able to really understand a lot more about multimorbidity. But then there's this second part of the project that is equally important, and it's where typically what we see until this point, unfortunately, with AI, is that it may work very well in the lab, but then when we go to the hospital, it fails. And it fails because hospitals are complex places, because hospitals have processes, because sometimes or oftentimes we don't really think about what's happening already and understand and plan to how we can integrate these new tools in this complex work that I showed you earlier on happens in the hospital. So it's extremely important to plan this in advance, to study what happens, to understand how it will have to change so that people will in fact profit from these AI tools. And also, there's a lot of other power dynamics going on in the hospitals. There are doctors and there's nurses, and there's power dynamics there. And these things happen, and we need to know how to address them so that amazing tools that sometimes and oftentimes we have really are used and are not just put somewhere and not thought of anymore. And so this is something that we're also dealing with in this project, is really already studying what is happening nowadays, how is the care of these patients coordinated inside of the hospital, how we identify these patients, how this clinical decision tool can really be helpful, and who is going to use it, and how it should be constructed in a way that people will, in fact, use it at the right time. And so, again, this involves a multidisciplinary team. We need to have doctors, we need to have nurses, we need to have operational and managers of the hospital involved, and they need to be very much involved. It's not just showing them something in the end. They need to be involved from the beginning, together with the human factors team that studies the user experience so that we are able to, in the end, get a tool that really is going to be used and that really will bring value to patients. Again, just acknowledge CMU Portugal program support. Very happy to be here. Thank you very much.
Thank you for a very interesting presentation. The project sounds fascinating. So our next speaker is Luís Rosado. Luís is a senior scientist at Fraunhofer, Portugal, and he is partner in the TAMI project. TAMI stands for Transparent Artificial Medical Intelligence. And so, Luís, please tell us more about this project.
Hello, good afternoon. First of all, thank you for the invitation. It's a pleasure to share our project in this great event. Let me just share the screen with you. Okay. I think you are now seeing, okay. So the TAMI project, first of all, a disclaimer. I'm here in representation of the lead promoter for solutions, which unfortunately could not be present, but I will try to share with you their vision and their expectations for this project. TAMI stands for Transparent Artificial Medical Intelligence, and this is also a project approved by the call in co-promotion in international partnerships. And just a brief outline of the presentation. I will start with the motivation of the project. What is the problem and the opportunities that emerge by tackling this problem. Also, what are the objectives of the project? What we are proposing as a solution for this problem, and also briefly present the team and the timeline for the project. And then in the end, also address what are the expected results, not only from the R&D perspective, but also what commercial opportunities we envision with the outcomes of this project. So let me start with the brief contextualization. As you all are aware, the current rise of artificial intelligence has brought exciting advances in a wide range of applications. Medicine is one of them. And this was greatly boosted by three main factors. The fact that there's right now large and diverse data sets available. There we also have access to improved algorithms, and we have also new levels of computing power. But despite this spectacular success of AI recently, there are still huge challenges, and the previous presentation also highlighted that. And in particular, there are areas of public concern that we consider that are constraining a wider use of these AI systems. And one particular example for these concerns and these needs is the European Commission report that was released last year, which is related with a comprehensive European industrial policy on artificial intelligence. And in this report, it's clearly stated that AI needs to be ethical by design. So characteristics such as transparency and explainability should be embedded in the development of these AI systems. So in other words, the problem that we are currently facing and focusing on for instance, in the imaging domain. So we are right now, some models are achieving very good results. Some of them even surpasses the humans in specific tasks, but many of them are like black boxes. So we don't know the internal logic and inner workings of these models. They are hidden to the user. So this is a serious disadvantage because prevent us as humans to verify, to interpret, and to understand how particular decisions are made by these AI systems. This was also one of the main motivational factors for the emergence of a new field of study, which is called explainable artificial intelligence. This is one of the main building blocks of this project. And what this new field of study tries is to make a shift towards a more transparent and interpretable AI development. So if we focus on specifically on the usage on AI in medicine, there are a lot of challenges, and one of them is the fact that decisions in medicine are very complex and usually uses diverse data. So we can have different types of data to take a unique relevant decision, from images, time series, text, and in order to give this diverse data in a standardized way to the machine learning algorithms, we need to tackle problems in terms of mapping where is this data, how are we going to fuse this data, how are we going to integrate this data in order to standardize the inputs of these models. But besides that, and if we look to the clinical domains that use images, we can clearly see that right now there's an inherent tension between performance and explainability. So right now, the best performing models in a wide range of use cases are based on approaches called deep learning. And right now, this is one approach in AI that is the least transparent because it's not clearly understandable for the user how a particular decision was made. And in the opposite, the approach, more conventional machine learning approach that are more clear and transparent, right now are not achieving the performance of these deep learning approaches. So we know that in medicine, high performance is a must, so it's almost mandatory. But at the same time, we also need to enhance trust and give the basis to certification of these approaches by knowing how the inner workings and their reasoning behind the decision. So we need to balance between this high performance but also transparency and explainability. So one of the main challenges in this project is to try to achieve these two requirements at the same time. So we want to develop approaches that are high performing in the medical domain, but at the same time, these outputs can also be understood and cross-examined by the users. Or in other words, what we aim to achieve is not only develop algorithms in specific areas that don't only give the decision, but also give an explanation, a reasoning for this particular decision. So one of the objectives of this project is, in fact, develop this next generation of AI models that have embedded these requirements in terms of interpretability and explainability. And it's very clear for us that there's not one solution fits all. So we cannot achieve a structure of an explanation for a specific decision that fits all the use cases. This must be dynamic and must be adaptable to specific use cases. First, because most of the times we are talking about multimodal problems. So we have sources of data from different types, images, text, time series. And second, because we have different users with different profiles. So for instance, if you have a user that only works in the image domain, let's say a microscopist, probably explanations in the image domain will be the way to go. For instance, with approaches like highlighting in the image which areas contributed most for this decision, what are the characteristics on this particular image that most contributed to this decision. But at the same time, if you have use cases where also the electronic health records are used, we need to adapt to this healthcare actor and also show how the multimodal decision was made. So what are the key aspects in the electronic health records? For instance, family history coupled with the result of a specific exam and the presence of specific structures in the image that contributed to this automatic decision of the AI system. Second, what we realized while exploring this idea is there are not standard and clear ways to evaluate the interpretability of AI models. So what we also aim to achieve is quantitative methods that we can objectively use to assess and compare different types of explanations. So if you have a library of different types of explanations that we can deliver to a specific decision, we need to understand which is the type of explanation that best suits a specific profile of the end user. And this, what we try to do is bridging the gap between these raw measurements in terms of interpretability with also user-centric measures. And here we count with the contribution also with our human-centered design team, which is going to have an active involvement with healthcare actors to shape these evaluation metrics. And third, we also believe that doing these methods is not enough if you want something that can be effectively used in the clinical practice. And so the way we show these decisions and these explanations need to be adapted to the clinical practice. So these outcomes cannot be an overhead to the already very exhaustive work that the healthcare actors do. So on the other side, these tools need to be as intuitive and as transparent as possible, so it can be really easily embedded in the clinical practice. So having these different approaches, I will say more ground-based research about these generic methods. We, in this project, also aim to apply them in specific clinical domains. And we are talking about 4 different imagological domains, which are the cervical cytology, cervical colposcopy, glaucoma, and chest X-ray. And with this, build a platform that deliver these functionalities. So here I have a diagram that represents the architecture of our solution. So basically, we have these horizontal layers where we have these generic methods that we aim to develop. The first one more related with the decision. So it's the layer where we develop the models that actually give decisions that aim to support the clinical practice. And we will receive as input image data and also electronic health records. On the second layer, we have this translational layer, which also tries to generate the explanations for these particular decisions of the layer below. And then a third layer, which is used to evaluate which are the best type of explanation for a specific profile in the clinical practice. And a fourth layer, the top layer, which is the interface layer, where we are going to develop the support tools and demonstrators. And here we have these 4 clinical domains I referred previously that, as you can see, goes transversely being fed by the different layers developed, so we can demonstrate the usage of this generic approach in different use cases. And of course, these are going to be changed both for clinical inputs, but also from market inputs. So in terms of the team, the lead promoter is First Solutions, Sistemas de Informação. First is currently the main supplier of screening measurement software for National Healthcare Service in Portugal. So they have actually in usage different information systems that are supporting screening programs such as the cervical cancer and the diabetic retinopathy screening programs. As co-promoters, we have Fraunhofer Portugal, which is a team led by me, in ESCTEC, a team led by Professor Jaime Cardoso and Professor Aurelio Campilho, Carnegie Mellon University, of course, led by Professor Azim Smeiligic, and also Administração Regional de Saúde do Norte, which is going to be very important in the clinical domain, and also to make the bridge with our clinical partners. So we also have clinical partners. Some of them are subcontracted. And this is a key aspect because we need this commitment from the clinical partners to successfully execute this project. And they will work, help us in the clinical guidance, also in the data collection and annotation, and then in the end, in the field trials and evaluation of the solutions. So I will not go into detail about the timeline. So just to let you know, it's a 3-year project started in April. In blue, we have here a lot of R&D tasks that are going to tackle these problems I've been talking, but it's also worth mentioning that we have here a very important work package related with the field trials. So we really want to go to the field and try these approaches and see if actually brings a benefit for the clinical practice. In terms of the expected results, from the R&D perspective, it's directly related with these approaches that we want to develop related with generating explanations to support decisions, multimodal explanations, and be very customizable and adaptable to a specific use case and a profile within this use case that is going to use it. A very quick example in the cervical cytology, we have the cytotechnicians that work just in the microscope. So here we can focus on explanations only on image domain, but then we have the medical specialists that also use the electronic health records, and then we can have more complex explanations and more complex models that also use this text information to take the decision. Then we want to develop these methods to assess and select the most suitable explanation for each specific use cases and profile, and then have these novel visualizations methods to present the decisions and the explanations without overheads for the clinical practice, but actually turning the process more efficient. So then we want to merge all these contributions in computer-aided diagnosis tools in these different use cases. Here on the right, we have some illustrative images from cervical cytology, cervical colposcopy, glaucoma analysis, and also chest X-rays. Just a quick note about this version of the chest X-rays. Right now, we are focusing on using X-ray images from positive or suspected COVID-19 suspects, because there were released some public data sets on this aspect. And so the team from Inestet is actually working on these data sets to see if we can develop automated tools to predict and understand the infection. To finalize, in terms of commercial outcomes, First Solution already has these information systems that are used on the screening program. So we aim to integrate these computer-aided diagnostic tools in this information system, and also provide not only the decision, but also the explanations, and also take this opportunity to evolve the system and bringing new capabilities in terms of annotation and visualization. Besides the information systems for the screening programs, we also envision a more broad platform being used for scientific, academic, and commercial purpose, where also we are going to give access to these computer-aided diagnosis tools for healthcare workers outside the screening program, and also use this platform to provide filter and anonymized data sets for researchers that can be used to increase the knowledge base for academic purposes. And basically that's it I have to present. Thank you very much for your attention.
Thank you, Luis. Thank you. This also sounds like a very interesting and impactful project. And our last speaker is Margarida Neri from Glint, and she's representing the WOW project, which has a very long acronym, but is related to devising smart beds for hospital patients. And so, please, the floor is yours.
Well, hello everyone. I'm very glad to be here. Thanks for the invitation. Well, today I'm going to be talking about wireless patient biomonitoring and smart IoT system connected to patient's bed at the hospital or at home. Well, this seems a lot of things and it's very extensive, but in few words, what I'm going to talk about is about wireless biomonitoring of patients. Well, let's see if I can do this okay? Yeah. So first of all, I'm just going to present myself. I work at Glint, and Glint's business is mainly in the health area, and we work with health providers and with pharmacies. Our two biggest markets are Portugal and Spain, and we are a technology company, and we work focused on the citizen's journey, focusing on health management besides the disease management, but our main focus is on health management. That's why we are now a part of this consortium that's working in WOW. And along with Glint, we have ISR from Coimbra, and they are an important part in this project because they are printing the stretchable and electronic skin devices, and their expertise is helping us with the IoT and the AI modules. For University of Coimbra, we're having the material science expertise, and the hospitals of Coimbra, well, they are also widely known, and they are one of the biggest healthcare centers in Portugal. And they come to the project with a pilot and with the patients that we're going to monitor. For Carnegie Mellon University, well, Carmel has already spoken, and we have his contribution with biosensors. So, for these wireless biomonitoring patients, well, we work on the patient's journey, and we want to improve the quality of life for everyone in the society. And when we are using this wireless biomonitoring, what we want is for the patients to have the best comfort there is. So make sure that they are untethered from all the wires that you have on a hospital bed. And make sure that they are autonomous, they can get up, they can go from one side to the other. They just can give a small walk around the bed. And also to power for the domiciliary hospitalization. So we don't want patients that don't have to be in the hospital, in the hospital beds. We want them to have the best care possible, and the best care can also, and most of the times, is at home, where they are better, they are with their families, and if we can promote this kind of approach, well, it's better for everyone. It's also it also implies some cost reduction because we are not having all the hospital beds occupied. So if we're removing the patients from the hospitals, we'll have more ways to treat other patients. And also for the biostickers, the way they are being assembled is using materials that can also be more cheap and than the ones that we are now used in hospitals. For all stakeholders, well, we have data, and data is power. So if we can have this data, then we can have everyone informed, and we can have better policies. So I'm just going to share the project components. So for the biomonitoring stickers, they've already been mentioned by Carmel, and he knows a lot more than I do on this area. But mainly, we're going to have biomonitoring stickers that are going to measure the vital signs like heart rate, temperature, ECG. We're going to see some motion and to detect some motion from the patients. And then in a highly new approach and experimental approach, we're also going to try to find some of the emotions from of the patients using the galvanic skin response for emotional computing. Well, the information that's being collected from the stickers is going to be collected in a smart box. That's going to be, I don't have a pointer, but if you see for each patient, he's going to have the sensors, and then you have the smart box in each bed. So each patient has one bed with a smart box. That smart box is going to collect the information, and then all the information goes to a smart gateway. And in this smart gateway, we're going to have an interface between the smart bed IoT and the hospital solution. In this case, it's Global Care that's going to be showing the information to the doctors. Also, an experimental and a breakthrough that we want to have with this project, like Carmel said before, it's the harvesting and the storing of the energy. Because one of the problems you can have is that all these wireless biomonitoring stickers have batteries, and we want to make them live longer, and for that we need to power them. And we're going to try to find the smart box solution that can give this, also can help with this challenge. So for the patient evaluation, we're going to have Global Care, we're going to collect all the information, and then for doctors and nurses can see how the patient is doing, if he's at home or if he's in the hospital. So next, I'm going to show a video for all of you that have assisted to Carmel's presentation. You just can check your emails now, because for the next 2 minutes, I'm going to show you why we call this WOW. Well, I must confess, I never get tired of watching this video. When it comes to our project, for the WOW project, the biomonitoring stickers, I'm showing some samples of what has already been done by the Institute of Systems and Robotics in Coimbra. And the biostickers that we're going to have in this project will be similar to these ones, to collect the vital signs and the other signs that I've just mentioned earlier. So for now, and what we've done since April till now in this project, we've already selected the pilot for the project. It's going to be in the University of Coimbra, our partner, and it's going to be the orthogeriatric service that's going to work with us in this project. We are now defining the user requirements, just to make sure that when we go to the pilot stage at the end of the project and we're going to have the biomonitoring stickers in the patients and everything assembled, we are going to get information that's useful for the clinic, for clinical evaluation, so for doctors and for nurses to work with. One thing that I didn't mention is that we're going to have a pilot with 5 people. We are going to work with them in the hospitals, in the hospital service, so in the hospital stay, but we also want to bring them out and to the home of the patients and to make sure that they are still going to be monitored. So along with defining the user requirements, we are also doing the definition of the system's architecture, because we need to have the smart beds working well. So we are also working on this interface. So from the biostickers to the smart box, to the gateway, and then to global care to present the information. The designing of the biostickers and selecting of the sensors is also a work that we are doing now. So for the expected impact, and like Carmel said before, we're going to demonstrate with this project for the first time ever the integration of biomonitoring skin into a professional health information system. So we really want that the data that we're going to collect is going to be used, and it's safe to be used, it's credible to be used by doctors, by nurses, and that they can do medical calls based on this information. We are also, so when we come to the positioning and commercialization channels, well, the first ones will be hospitals, but we will also want to take them to home care and to pharmacies that are near population. And so it also makes sense. And we can't skip talking about a pandemic situation like the one we're living now. I'm sure that for these biomonitoring stickers that we're talking about, they won't be useful for COVID, because the vaccine will come sooner than the project will end. But for a situation like the one that we're having nowadays, and that we don't want a lot of people in the hospitals, we want to make sure that people are safe and that they are being correctly monitored outside the hospital. Well, these kinds of situations will help us to monitor people that don't need to come to the hospital, that they are okay at home, they are safer at home, but still have a quality in their health and in the healthcare that's being provided. So I want to thank you, everyone. If you want to know more about us, you can check our website, and happy to be here.
We have time for a very short discussion, about 5 minutes only. So I'm not sure if I'm probably only going to be able to ask one round of questions. And I would like to ask you the following. As academics, one of the main concerns we have is if we are providing the right training to our students and to our doctoral students in particular, so that they can subsequently move to very good jobs, a few of them in academia, but more and more of them in industry. And in fact, my students, the students from my group nowadays get more jobs in industry than in academia. I guess my question is, do you see these projects as contributing for creating the conditions to have those sorts of positions for PhD students to move on to companies and do highly innovative work? And more generally, what is the role of PhD graduates in the innovation that you are doing in your companies, and how do you see that role evolving? Maybe you can start, Francisco.
Well, I can tell you that our project, for instance, would not happen if there were not 2 PhD people in our company. So that's the main reason why we were able to get this project going. So that's extremely important. We do have a different way to think than most people in companies, and that's very valuable. And the way we can structure information is really helpful. It's not only particular to PhDs, of course not, but it definitely helps. And specifically when we go to these kind of projects, which are complex, and you really need to understand, to be able to have a consortium that works, we need to be able to understand what the people in the universities and in the academic institutions are saying. If you don't really have the training, it gets very hard to do that. We have been, that's one of the things, one of the difficulties in this project at this point is that it's really the hiring, because we were looking for PhD people to help us in this, and we finally were able to hire a person at this point, but it was extremely difficult. There's not a lot of them, and not a lot of good ones. And the first few interviews that we were only able to interview people that were just ending the undergraduate, so not really a lot of PhDs that we were able to hire, also because the market is global at this point. But it definitely helps, and I really cannot see these projects going on in industry without having PhDs there. That's absolutely impossible to do. What happens then is that they become very university-driven and not so much company-driven. And I really think, at least in healthcare, it doesn't really work. So I definitely think we need to have more PhDs working in the companies.
Am I? Oh, it's on. Okay. So yeah, I agree with what has been said. And for our companies, we know that if we want to have a breakthrough, if we want to do something out of the box, well, yes, we need to work with investigation with the universities. For this project, we have PhDs not only for ISR and for all the other parts of the consortium, but it's important because if you want to do the wow things and the breakthroughs, you need to have the curiosity and from PhD students and from PhDs, and also you have to have a balance, and then for the companies to know what's good for the market and what has to wait some time to go to the market. So I think it's a good symbiosis that we can have here.
Now for Luigi, if Luigi is still there, Fraunhofer is an institution that bridges academia and industry. How do you see these projects helping in establishing that bridge?
Yeah, it's really important because in our philosophy of research at Fraunhofer Portugal, we already have this matrix. So we try to do research really close to the companies and really close to the applicability. And we always try to have these projects to create more competences in our team. Because if you want, I completely agree with the previous suggestions, because if you want to deploy something in the clinical practice, we need really strong competences, very maturity in terms of our skills. And we always try to bring to these projects really strong teams, and at the same time also include persons of the team that can evolve also to a PhD. So doing the PhD during the project, and we are going to try also to do this in the TAMI project.
And so as a last question, I would like to ask you, how do you see the role of Carnegie Mellon in this partnership? What is the value added by having a world-leading university in this area working with you?
I can start now. Well, for us and for WOW, it's the biostickers. We know that we couldn't achieve, or we won't achieve what we want. It's the monitoring at home. if we don't have the expertise, if we don't have Carnegie Mellon, if we don't have Carmel and all his team working with this breakthrough. So for us, I may say that we wouldn't have a project for that. And this project, I really believe, that it's going to be very important, and that it's going to have in the society the ability to let people stay at home, be cared at home, focus on health, not just on the disease, because we know that if people stay longer times in hospitals, the depressions and some other not so good diseases can come. And for this kind of project, and to make sure that we're going to be well succeeded, well, I think that Carnegie Mellon and these biostickers, this technology is very important.
Yeah. Franziska?
Yeah, again, Carnegie Mellon in our case, as we have people there with the particular expertise to design clinical pathways that really don't exist in Portugal yet. So of course, in just that sense, it's very useful and important to have them on board. But overall, it's always important to have really smart people put together in discussing this, in this case, in virtual rooms. So Carnegie Mellon people, of course, super important to have here, also bring up the international perspective, which is quite important because in healthcare, there's a lot of variability if you move from countries to countries, from different healthcare systems. So that's already just in itself very important. Of course, it's always also extremely important to have people from Técnico and all of the Portuguese institutions that we have on board. Again, putting smart people together, it's always the best way to go in these very complex problems.
And Luis, to conclude, how do you see the involvement of Carnegie Mellon?
Yeah, it's also very, very important because when we are talking about projects, we have such disruptive ideas and concepts like explainable AI, having different perspectives from different contexts is very important, and this will require a lot of discussions and brainstorming and explore different paths, and so a very strong team is very important. And also we know that and Carnegie Mellon, the type of research they do probably have a more focus on how to deploy this in the clinical practice. So we see in the Carmel presentation when we talk about the spin-offs and how to shape what we are already researching to be effectively used in practice. So I hope that this collaboration with Professor Azim also contributes in that perspective.
Okay, thank you. So this concludes our session. I would like to once again thank all of our speakers. I would like also to thank the audience and hope that you enjoyed the session. Thank you.
Boa tarde a todos e, em particular, um agradecimento especial à Ministra Ana Brunhosa por estar connosco. Let me pass to English. This session will have two great speakers, Eric von Ippel from MIT and Bob Langer, also from MIT. And the two of them have collaborated over many, many years with Portugal and in particular with Portuguese researchers. Over the last years, Eric has been a major supporter and promoter of the initiative Helena Canhão and Pedro Oliveira launched, Patient Innovation, and he has certainly influenced not only them and the group of user innovators that have been showing to the world why we can promote innovation from patients, but also worldwide, he has been particularly dedicated to a better understanding of the ways we innovate and we can improve the relationships between society at large and those which produce knowledge. I have the opportunity to meet Eric many, many years ago at MIT and in many OECD contexts where Eric has always been a driver of a better understanding on the way people engage in a knowledge-driven society. But in the last 10 years, as I mentioned, Eric has been particularly important and relevant in promoting patient innovation with Helena and Pedro Oliveira, and for all the support he has given to researchers in Portugal. We have awarded him with the Portuguese Science Medal, and I'm very, very pleased to, again, acknowledge his contribution for the way we look at innovation in Portugal in the European context. Actually, Eric, you should be pleased to understand that last summer the European Commission has recognized Portugal as one of the European strong innovators country, and that is very, very much associated with the way SMEs at large and startups, and particularly academic-driven startups, has become so influential in our society. And again, lessons learned from the way we can open up the access to knowledge, and particularly using many of your understanding on the way we should understanding open innovation are particularly critical for our current positioning in Portugal, in Europe, and in the world at large. Eric's presentation will be followed by Bob Langer. Bob Langer has been associated with the MIT Portugal initiative since the very early stage, and he was in 2006 and 2007, one of the key persons with whom I could better understand how to open up the collaboration between Portuguese researchers and MIT. And again, in his lab, the largest world lab on biotechnology, has trained many, many Portuguese researchers over the last decades. Also, in the last years, Bob Langer has been particularly influential in supporting Pedro Oliveira and Helena in the Patient Innovation Initiative, and again, has continued to support the way Portuguese researchers try to promote innovation at large. As some of you may know, Bob has also been associated with many entrepreneurial initiatives, although a leading academic scholar. He is also a leading entrepreneur at the world level, and currently he is very much involved in one of the main companies associated with the vaccine for COVID, and I'm sure that you will report on the way biomaterials and bioengineering is driving change at the world level, but also to help fighting the pandemic that we all are facing. Earlier today, our Minister of Foreign Affairs was very clear demonstrating and discussing the relevance of the program with MIT and the way we look at the world and Portugal's position foreign affairs through scientific collaboration. Our program Go Portugal, Global Science and Technology Partnerships Portugal, under which MIT Portugal initiative is one of the leading initiatives, has particularly been influential in the way we considered more and more transatlantic cooperation, and these two speakers are a part and a great part of those which has made possible MIT Portugal and Portugal at large to be nowadays recognized at a world level. So I thank you very much, these two speakers. We are particularly honored for the two of you to have accepted receiving the Portuguese Science Medal, and now it's time to listen to you and again to learn out of your lessons how can we always do better and better in the innovation context. At the end, the session will be closed by our Minister of Territorial Cohesion, in which I'm sure she will address the audience and all of those that are at home and at your institutions to better understand why science and innovation are also so important for territorial cohesion and the experience of Portugal in better understanding the role of science as a key strategic tool for a better inclusive society at large. Thank you very much.
Eric, you may want to share your slides.
Here you go. Okay. So let me say I'm enormously honored by this. I have indeed, through MIT and directly in Portugal, built a wonderful relationship, a research relationship, and I'm very aware of the very important contributions that Portugal is making and has made to our overall effort and to Portugal's unique sort of strength in the area of these new innovation methodologies. In my talk, I will discuss user innovation as an important general phenomenon, and also will discuss the major contributions being made by Portugal patient innovation scholars, specifically Professor Oliveira and Professor Cajano, as also mentioned by Minister Idur. So let me first begin with context, because I understand that our audience is quite a general one, and you know, that's always a wonderful thing. So let me first say that in economics, product users have traditionally been thought of as passive innovators. They're simply users of what the producers might give to them. So this was central. It was started out by Schumpeter in 1934, and it really is driving innovation practice and policy to these days. But it is wrong and it is incomplete, as we now, with work in Portugal and around the world, understand. So the model that that Schumpeter put forward and that has been driving things like patents and all these government policies to date is called the linear innovation model, and it is that a producer does market research, research and development, production, market diffusion. So for example, it would never occur within this kind of a situation that a user would see an innovation that the user needed for his or her or itself and would develop it for itself. It simply is not done. Instead, what happens, this theory, which is dominating the world today in terms of public policy and practice, is no, it is the producers who innovate, it is the users who have needs. So here, when I was a young man, my father was a professor at MIT as well, and I used to, ever since age 12, go around the corridors and I would see what scientists were doing in their various labs. And one of the things that I saw was that in fact the scientists were the ones, the users of scientific instruments, were the ones who were developing their own instruments. It wasn't the Schumpeterian argument that a producer was coming and saying, aha, I see your need, Mr. Scientist, I will create a product for you. Instead, it was that the scientists developed what they need before there was a commercial product. This is an example, because this is a science medal. This is an example from scientific instruments. And what you see here is electron spectroscopy for chemical analysis, ESCA. As you can see from the image on the left, it's a pretty complicated device. It involves vacuums and electron beams and so on and so forth, and it is complicated. It was developed by scientists who needed to study the surfaces of solids. It was not developed by companies saying, aha, I see you have a need. And what you can see from that chart there at the bottom is that the users developed and improved this innovation for years and years before finally a producer began to make it. This is very different than the situation that is commonly discussed, namely that the producer sees a need. It's extremely different, but it turns out to be very general. Now let me switch to, and by the way, you can see a reason here at the bottom. Basically, what's happening in the beginning is there's no market. For a really big innovation, there's no clear market. So producers have no incentive to enter, and users do, because individual scientists absolutely need this device to pursue their important research. So now, this is also true in medical areas. It's true, in fact, in general, in the consumer area. So suppose your child had a serious disease and medical firms were not offering what was urgently needed. What would you do? I'll bet you just wouldn't sit there and say, oh gosh, I hope someday a company comes and produces something to save my child. You, if you had the skills, would do something about it. And this is the general principle underlying the research of the patient innovation initiative of Pedro and Elena and others, and the general idea that it's users as well as producers who innovate. So I'm now going to give you an example of how this works. This example is what's called the artificial pancreas. And it is about something needed by people with type 1 diabetes. These people make 300 plus decisions a day that influence their blood glucose. They can make mistakes, and mistakes can be fatal. In fact, 5% of type 1 diabetics die by making a mistake over their lifetime. Typically, they make a mistake at night. They take too much glucose, and then they fall asleep, and they fall into a coma. Now, this happened to Dana. Dana Lewis, you see here on the left, and her husband, Scott LeBrand. Dana is a type 1 diabetic. And Dana made a miscalculation one night and went to sleep. She had, as usual, a juice box with sugar on her bedside table, because that's what type 1 diabetics do. If they make a miscalculation and they wake up in time, they can sip the juice from a juice box and save themselves. But Dana woke up too late. She could see the juice box, but she could not move her muscles to save herself. Luckily, Scott came in and saved her. Now, what is needed by these people, the reason the mistakes are made, is because there's so many complicated calculations that you have to make as a diabetic. You, for example, when you're having a meal, you have to estimate the carbs you're going to eat. You have to then correct for insulin resistance you may have, for your activities prior, like walking to the dinner, your activities post, like sitting still, and the amount of insulin you have on board, and then you must inject the correct insulin dose. No wonder lots of errors are made. Well, what could be done about this? Dana was afraid to go to sleep after this, as I would be as well. But Scott was a software engineer, and Scott said, this is ridiculous. We need to make an artificial calculation pancreas, a device basically that will calculate for Dana, using her rules, the amount of insulin she should take. What it does, in other words, currently we have a continuous blood glucose measuring device. Companies sell those. We also have insulin pumps. So in ordinary practice today, what you do is you look at your measurements on the blood glucose device, you do your manual calculations, and then you press the button on the insulin pump to give yourself insulin. What's missing is that box in red, namely something to automatically calculate the dosage. So what happened? Companies were saying, oh, wait 5 years, this is so hard, you can't expect us to do it right away. Dana and Scott built an artificial pancreas to automatically adjust insulin levels on Dana's insulin pump. Others helped. So in other words, they, in a few months, developed what companies said would take years. They developed it because they needed it. And what you see here is the first such device that was openly shared, artificial pancreas system design. In other words, what Dana and Scott did is they built this device, they used this device, they saw that their blood levels were improved. Here you see Dana's levels. She actually tracked her blood levels of glucose. The outcomes were better. She kept within range better than her manual calculations did. And then what did they do? They posted it on the web. So thousands of other people using these designs and updated ones are accumulating millions of safe, quote, flight hours with the same good results. Notice what this is. This is users solving their own needs when companies don't do it. Now, today, we have this thing continuously evolving, and it is, not many dollars, a couple of $100 versus what is now an available commercial device, which is $8,000. So many people still prefer the open APS, and they use it because it was inexpensive and because it's better. Now, recall again that in economics, product users have traditionally been viewed as passive. But now we see that's really not true. And what happened amongst my colleagues around the world is that we decided that we were going to measure for the first time the amount of innovation by consumers in the household sectors. So this would not count the scientists who also innovate, as we saw, for their own needs. This would count only consumers. This would count individual people living in their own homes, innovating for their own use. Now, when we first proposed to do this, it was quite astonishing from the perspective of the researchers, but we managed to do these standard surveys across 10 countries. And what you see is that it's about 6% of the population that innovates. This is a massive number of people. Across 10 countries, it's 65 million people. It is absolutely an amazing amount of people innovating. Consider the UK survey. 2 interesting general features are visible. It's big scale and it's free. That means, just like Dana and Scott, they create these innovations as householders. They don't sell them, they give them away. So first, you see here the percentage of population in England. It is 2.9 million people. That is 100 times more than all the people developing products for consumers. In other words, this massive effort has been invisible. Why has it been invisible? It has been invisible because, number one, the Schumpeterian argument said it shouldn't exist. And number two, since it's done for free, created at private cost in homes and given away for free, there are no economic measures that were automatically generated to make it visible. There are no patents and so on and so forth. And yet what we see here is that the annual consumer spending on R&D for products for themselves is $5.2 billion. That's 140% of what the companies are doing. So it's a huge phenomenon and it's very important. The measures that we use, we calculate this very carefully. We just simply only accept things where users say, yes, they have created or modified something. It is not job related. In other words, they didn't do their work for IBM at home. It is not available on the market, and it is functionally novel. It improves things for the performance of whatever that user is trying to do. So the innovations we record are in fact very conservatively recorded. Now, what do we have? What we end up with then, and this is sort of the arena within which Pedro and I and Elena and others in Portugal and many around the world work, what you see is a brand new innovation paradigm. Basically, it's users, self-rewarded, innovating and revealing for free, and then diffusing for free to others without protecting their innovations. Some of you may know about open source software, and you will see that pattern. People innovate for themselves, they just put it into a commons, and then they share it openly, other people improve it, and so on. You can see how enormously different it is than the innovation paradigm that has been traditional in the Schumpeterian world at the bottom. It is not about money, but it has enormous impacts, as we will see. Innovation designs that users make are often behind what producers are making. Why do they create innovations at their private cost and then give them away? It is because they are self-rewarded. This is a cluster analysis from Finland, and what you see here in these circles is the reasons that people give for why they innovated. You can see that users there, named after the biggest portion of the cluster, is personal need driven. That would be the case for the artificial pancreas that we just described. But there are also people innovating because they enjoy it. Those are participators. They learn from it. There are people helping others, like you would help your child. And finally, just 9% of the sample is producers. They are innovating to sell something. And so they are ones who make patents and so on. Now, again, because users are self-rewarded, they tend to pioneer. Why is this? You can see this curve. This is a standard market curve. It grows and then it declines over time. And at the very beginning of that curve, that's where you find these innovating users. It is not clear yet whether there's a market. And as a consequence, producers are not interested because they need a lot of product sales in order to, in fact, benefit from their innovations. Now, what happens then is that users pioneer, as in the case of the artificial pancreas. And therefore, it's very important to think about how those innovations get out to the general population. And here we come back to Pedro and Elena and the patient website that they have created, along with many colleagues as well. And this is why it's such a joy to work with them and the fundamental work that they are doing. How does this fit in? It looks from this like everything is under control, but in fact, there is a problem. The user innovation paradigm that we see on the top there involves people rewarding themselves. In other words, I develop an artificial pancreas to help my wife. I don't develop it to sell it. I am self-rewarded. Once I have helped my wife, then I have gotten my reward. I have no incentive to diffuse it further. This is a problem because, in fact, as you see in the bottom arrow, diffusion is driven by producers relentlessly. Producers are not self-rewarded. They only get benefit when they sell something to somebody else. So they will work really hard to diffuse their innovations. On the other hand, user innovators who solve their own problems are not motivated so strongly in this direction. So we see this in the data. What we can see, this is a study again in Finland of diffusion effort. What we see is that innovations that are very valuable to many, that's the one in the red circle, only 23% of the innovators make any effort at all to inform either their peers or to inform producers. Now that is the problem that Pedro and Elena and their center are working upon. And it's a central problem to this newly emerging innovation world that we see. Basically, what you have is innovations that their patient innovation site collects. So they, the user again has no particular incentive to diffuse it. The center that Pedro and Elena built is in fact going out proactively and getting these innovations, because one of the forms of diffusion is to bring them to a point where others can see them. Then what they do is they explore the pattern by which these innovations do or can diffuse. Here are two examples from their site. You see an insulin port there. Again, it's for diabetes, and what it is sort of this little sort of device that you put under your skin. You adhere it to your skin so that when you make an injection, you don't always have to puncture yourself again and again as a diabetic. Instead, you sort of inject the insulin dose you want within this sort of plastic port. Now, developed by a patient who did not want to repeatedly stick herself, and acquired by Medtronics. Medtronics then, an existing firm, became the method to diffuse that important patient innovation. Another example is another method. This is the shower shirt. Here is a patient startup. What this amounts to is a woman had a mastectomy and was told by her doctors when she said, well, I want to shower, what should I do to protect the incisions and so on? And they said, well, just make a hole in a garbage bag and put it over your head. This was ridiculous from this person's perspective. And so what she did was make a shower shirt for herself. You can see there in the middle of that second row, what she did was she created sort of pockets in it so that she could put her drains and so on into safe locations while she took a shower. And she started a company. Well, that is excellent, but those self-done, self-achieved diffusions are relatively rare. There's an enormous amount more of very important innovations out there that have to be somehow diffused more effectively. And this kind of research that the Patient Innovation Group is doing, conducting research on all diffusion options, providing practical support and teaching, it's a wonderful phenomenon, and Portugal is the leader due to your wonderful academic colleagues here. Now, free innovation, this kind of innovation I'm talking about, is getting bigger and bigger, so that what Pedro and Elena and many of us around the world are doing is getting to be more and more important. Producer innovation is getting outshadowed increasingly by this kind of innovation that I showed you, whether it's the scientific instrument being developed by scientists, or the medical innovations being developed by medical people, or in every other field, innovations being done by users for themselves. So what you see is that design costs are dropping due to computerization. Communication costs are dropping due to the internet. So what we now can have is large-scale projects like Linux that can outdo the kinds of projects that producers come up with. And you see then that the producer, if you think of it as design costs are dropping and communication costs are dropping due to the internet, basically all innovation opportunities are moving downward to the left into areas where these collaborative user innovation activities can occur. So we now, with help of Portugal and other countries, we now have managed to make the definition of innovation, have changed it to include both patient and free and open innovation. Previously, it was outside of the OECD official definition. All of us working together have now made it part of the definition. So we are moving this kind of activity from the research sphere to policy and practice. And I'm hugely happy to be participating in this activity along with my colleagues in Portugal. Thank you very much.
Eric, thank you very much again for the way you explain to everyone how innovation works, and certainly the way you are also supporting researchers from Portugal. And the lessons are always also the way we are open to collaboration with you and get your lessons to make sure that our population at large can also be innovators. And I believe that the lessons is that the access to innovation is open to everyone. And certainly it requires a training population able to be confident on provide solutions that can definitely be used by others. On the other side of the way knowledge and science and our own mobilization can be used to change our lives is what we will listen by Bob Langer. As I mentioned before, Bob has become particularly engaged with many Portuguese researchers over the last years. He was very, very much instrumental in the launching of MIT Portugal joint ventures in 2006 and 2007. And since then, he has very much engaged in training and supporting Portuguese researchers and Portuguese entrepreneurs. Bob, as you may know, has become a leading academic scholar, also the American West Medal of Technology, and we have also awarded this year the Portuguese Science Medal to Bob. He has also engaged in many leading entrepreneurial projects, and himself is engaged in several companies. One of them is Modena, one of the leading companies associated with the attempts to develop a vaccine to prevent and to avoid the propagation of COVID-19. Many scholars in Portugal has been interact with Bob Langer over the last years, but he has also been particularly instrumental in supporting patient innovation and the work Helena Canhão and Pedro Oliveira are promoting at the world level, but which was launched through a Portuguese-funded project some 12 years ago. So again, Bob, thank you very much for supporting all the Portuguese researchers over the last years, and in particular Pedro and Helena, and very much for accepting also the Portuguese Science Medal, and we all are listening to you and to your future developments in the years to come. Thank you very much.
Well, thank you very. Can people hear me okay? So anyhow, it's a real pleasure to be able to speak to you. So I thought I'd start and tell you about what we've tried to do in terms of innovation. And my background's very different. You know, I'm a chemical engineer. And in 1974, when I graduated, all my friends went into the oil industry. So I thought I should do that too. But as I started interviewing with them, I wasn't that excited about what they were doing. And I was looking for a way that I could use my background in engineering and chemistry to help people. And I ended up taking a job at Boston Children's Hospital and Harvard Medical School with a man named Judah Folkman. And I was the only actually engineer in the entire hospital. And by the way, it didn't pay nearly as much as the oil companies, but I was very excited about it because he had an idea, which is shown on the next slide. If we could advance the slide. And his idea was that if you could stop blood vessels from growing to tumors, maybe that would be a way to treat cancer and other diseases. And this slide, this goes back to 1971, actually. What happened, his theory, he had a theory that if you had a tumor cell, it started to grow in 3 dimensions. And if you look in the middle lower part of the screen, what you see is it's sort of plateaued. You get about 1 million cells, it turns out. And it wouldn't get any bigger than that because it runs into a nutrition problem. Cells in the center die because they can't get nutrients or get rid of waste. But his theory was that the tumor made something called TAF, tumor angiogenesis factor, that caused the surrounding capillaries, which normally didn't do anything, didn't grow, to now grow directionally right to the tumor. And what that did is it solved the nutrition problem because that could bring in nutrients and so forth. And then as you see in the upper right-hand part of this picture, the tumor would get bigger and bigger. And on the highest part, you see it's very vascularized. And so the tumor is not only big, but it can spread through those blood vessels. That's a process called metastasis, and that could eventually kill. So this turned out to be an incredibly controversial theory. I thought it was great because I didn't know any biology, but most clinicians and biologists thought it was crazy. But anyhow, I was thrilled, and my job was to prove it. And in so doing, could we isolate substances that could stop blood vessels? So how do you think about a problem like that? Well, first we had to find something that could stop blood vessels. And what I began studying was cartilage. Next slide. I'd get bones from a slaughterhouse, and then I found out where all the bones went, and they went to these meatpacking places in South Boston. And I'd get them, I'd bring hundreds or thousands back, and I'd scrape the meat off them, and they'd look like you see here. And then the upper part is cartilage. And I'd slice those off, pieces off, and I'd extract them with certain solvents and then try to purify them, and I'd get different fractions. But that brings up the next question, which is how do you test this? And if you look back at the history of biology and medicine, a lot of times people find factors. And what's really been key is having a way to have what's called a bioassay, a way to study what those factors are doing. And there wasn't one for this field, so we had to invent it. And the next slide shows what we tried to do. It turns out if you put certain tumors in the eye, like a V2 carcinoma, it will cause blood vessels to grow in the cornea. It takes about 9 or 10 weeks. So what we had to do was, and you could actually measure those blood vessels with an ophthalmic microscope. So we were going to use rabbits, and what we wanted to do was be able to take any of the things in cartilage, all of which were big molecules, like peptides and proteins and so forth, and be able to put them in what we call a slow-release polymer that could deliver them for this 9-week or more period. And so we asked I didn't know anything about polymers, so we asked different people if they could help us who were really expert in the field. But everyone came back with the same answer that's shown in the next slide, that the big molecules can't get through polymers any more than any of us could walk through a brick wall. The literature, by the way, said the same. Next slide. And the only thing that I had maybe going for me is I hadn't read any of this. So I didn't know any better. So I tried anyhow. Nonetheless, I experimented for 2 years. I found over 200 different ways to get this to not work. But eventually, next slide, I was able to make little microspheres or nanospheres. This is a picture of one on the left and one cut in half on the right. And we published in Nature, next slide, the fact that you could use these to release molecules of any size. And in fact, we also in this same paper, this turns out to be the very first time that nucleic acids like RNA or DNA were encapsulated in materials, little nanospheres or microspheres. And as I'll talk about a little later, that ends up becoming key to what Moderna and other companies are doing. So anyhow, we showed that you could do all this. We even showed, next slide, if you wanted to, that you could get constant release. But when I first started presenting this at scientific meetings, it was really ridiculed. I remember in 1976 giving a lecture at a big chemistry meeting, and I talked about this. I was 27 years old, and when I got done with the talk, a whole bunch of scientists came up to me and they said, "We don't believe anything you just said." They said, next slide, that these large molecules can't diffuse through materials. And we were also using organic solvents. They said that would destroy anything you put in. So, and actually things went downhill from there. First, I tried to get grants from the government, but they have these review panels and they all kept saying, well, Dr. Langer doesn't know anything about biology or medicine, so he shouldn't get these grants. And so my first 9 were rejected very badly. Also, I loved being a postdoc at Children's Hospital, but a lot of my friends told me that it's probably not a good idea to do that forever. So I started applying for faculty positions after 3 years. But what happened was, I'm a chemical engineer, so I applied to these faculty positions in chemical engineering, but every single one rejected me. They said the same thing as the grants. They said, well, a chemical engineer does oil, it doesn't do anything in biology. So I didn't get any chemical engineering jobs. And in fact, I was fortunate, I did get a job in a nutrition department. And the reason I got that was because the department head there, Nevin Scrimshaw, he was what I'd call like a benevolent dictator. So he liked me, so he offered me a job, but he didn't bother to ask anybody else what they thought. And that probably still would have been okay, except for one thing, which was the year after I joined, he left. So a lot of the faculty decided to give me advice, and they said I should leave too. In fact, the next slide is from Michael Marletta, who was a very good friend of mine. He was in that department at that same time I was in the 70s and early 80s. And he was giving a speech on me a couple of years ago and talking about that. And I'll just read it. He said one evening he went to a dinner at a Chinese restaurant with me and some senior MIT professors. He said, a senior scientist sat quizzing us while smoking a cigar. When the older scientist heard my concepts for drug delivery, he blew a cloud of smoke in my face and said, you better start looking for another job. And Mike said thought he was in a Fellini movie. Well, I didn't have much choice. They didn't want me, but I was there and I hoped that I could stay, and I kept doing my research. And one of the things we began studying was, since nobody believed this could work, was how did it work? So we started taking thin sections through these materials and visualizing them with what's called a cryomicrotome and then various microscopes. And the next slide shows a picture of one of those materials, ethylene vinyl acetate copolymer, as a model system. And it turns out that if something was even 200 molecular weight or greater, it couldn't go from one side to the other. Then how could these molecules get out? Well, it turns out, next slide, that if you put a model molecule in, like say myoglobin, which is red, and you cut a thin section before any release, you get what we call as a phase separation. So the polymer is white and the drug in this case is red. And if you release this for a year in this particular example, what you see is on the next slide. Left behind are where the drug was, are these pores. And these pores are large enough so that molecules of any size can get through. But it turns out that the pores, the way we made these, are very winding and tortuous. So it takes a very long time for the molecules to get through. If any of you have ever been to Boston, my hometown, I sometimes say it's like driving a car through Boston. And over the years, our students have figured out ways to design these so you can get release anywhere from a day to many years. But because we could do this, we could now go back and try to solve the angiogenesis problem. The next slide shows the assay. And what we did, I actually had something like 100 different samples that I wanted to test. And we did like an N of 20 for each of these. And almost every one didn't work. I think of those as the controls. But one did, and the next slide's kind of graphic, but there's no better way to show it. And these are the rabbit eye assays. This is from a paper we wrote in Science in 1976. And if you look on the left, what you see, this is after 9 weeks, is the sheet of blood vessels growing over the polymer to the tumor. And this happens 100% of the time. But, and in fact, if you looked at this eye 3 weeks later, if you did that experiment, it would be three-dimensional, out of the orbit of the eye, it would actually kill. We sacrificed the animals before that. But on the right-hand side, what was striking, and we saw this, if we could go back, we saw this every time, is that when you put this inhibitor in, you get the vessels are lower, they're sparser, they avoid the polymer, and over 60% of the time, these tumors never grew. So this was the first time that you could actually show that substances could stop blood vessels. And also it gave assays, bioassays that people could use in the future to study this. Nonetheless, it took another 28 years from this paper before the first blood vessel inhibitor was approved. And that's because companies like Genentech had great scientists, but spent billions of dollars developing these. But what happened starting in 2004 was striking. And that's shown on the next slide, which is that one after the next inhibitor is approved by FDA, starting in 2004. Avastin, the first one, is probably the #2 best-selling biotech drug in history. But beyond that, they're not only used for cancer. Before this, there were no treatments for eye diseases like macular degeneration or diabetic retinopathy using molecules. This was the first time that happened too. And those drugs like Lucentis and Eylea have also become very, very widely used for preventing and in some cases even reversing those diseases. Well, we also felt, Dr. Folkman and I, that beyond angiogenesis, perhaps these drug delivery systems could be useful for other things. So Larry Brown, one of my students, did it for his thesis that showed that you could deliver like a molecule like insulin with a single injection for over 100 days. And that's shown on the next slide. And then one day, Dr. Folkman said to me, Bob, we should file a patent. And that might seem common today, but then in the 70s, Boston Children's Hospital, where I was, never had a patent. So we filed a patent for the very first time in the hospital's history. And 5 years in a row, the patent examiner rejected it. He said it didn't make any sense to him. And then the people at the hospital started telling me, Bob, you should just forget it. He's never going to allow it. But I don't like to forget it. And I started to think, how could we convince the patent examiner to allow this? Legally, of course. And science really wasn't working. So as I told you in the beginning, when I first started doing this, everyone told me it was impossible, it couldn't work. And I wondered, did anybody ever write that down? So you can do what's called a science citation search, meaning I could, and I did this in 1982, after 5 years of getting rejected, and I could go back in 1982 and look at who referenced our 1976 Nature paper and what did they say. And I found things that I never realized even existed. And the next slide shows a great example of that. Here's a review article, it turns out, that had been written in 1979 by 5 of the top chemists in the world. And what they wrote, they're describing this field. And I was sort of shocked when I saw it. I'll just read it to you. They said, generally, the agent to be released is a relatively small molecule with a molecular weight no larger than a few hundred. One would not expect that macromolecules, for example, proteins, could be released by such a technique because of their extremely small permeation rates through polymers. However, Folkman and myself have reported some surprising, so surprising is a great word for a patent examiner, some surprising results that clearly demonstrate the opposite. So I showed that to the people at the hospital. They flew down to Washington, showed it to the examiner, and he said, gee, I had no idea. I will allow this patent if Dr. Langer can get written affidavits, written documents from each of these 5 people that they really wrote that. So I was this young professor. I wrote all these well-known people, and they were all actually nice enough to write me back that they really did write it. And then we got this very broad patent. Next slide. And with that patent, I got involved in starting companies. The hospital licensed it to companies. We teach different companies how to do this. And what that's led to, next slide, are all kinds of products, from microspheres and you need the delivery systems, otherwise the drugs are destroyed right away. So there's treatments here for prostate cancer, preventing bleeding, opioid addiction, type 2 diabetes, different eye diseases, pains and medications, schizophrenia, and so forth. Not only could you do this, it turns out that, as I mentioned to you, that that if you could, we could not only make microparticles and so forth, but you could also make nanoparticles. And I thought what I'd do is show you a video of Nova, the TV show. They came and filmed something in our lab, and they did a much better job than anything I can do. So I thought I would show you the video. I want to make sure the sound is on, but if we could show the video of the nanoparticles that we did. Is the sound on?
Encased in a plastic that releases the drug over time. That in turn gets a special wrapping that disguises the package as a water molecule to fool the body's immune system. And last but not least, the address where it should be delivered, a key that will only fit the lock of cancer cells.
A lot of the clinicians I work with tell me it doesn't really blow up the cell like that, but you get the idea. And these are in various, if we could stay there for a second. And these are used in various types of cancer treatments, but maybe even more exciting is that it's been absolutely crucial to RNA therapies. So Alnylam, a company I've been involved with from the beginning, has used nanoparticles to deliver siRNA to the liver, and they actually got approval from regulatory authorities to treat ATTR amyloidosis, which is a rare disease. And as was mentioned in my introduction about me, is we started Moderna, which is a company that develops messenger RNA drugs. They actually have 14 in clinical trials, one of which is the COVID vaccine. And actually, it's not just Moderna that's using nanoparticles to deliver messenger RNA. Every company that's developing a COVID vaccine, Pfizer, BioNTech, all of them are using nanoparticles to do this, because otherwise the RNA would be destroyed. So that's been very exciting, and I have my fingers crossed that it will hopefully help a lot of people. The second thing that I want to go over, since I was working on materials, I was curious, how did materials find their way into medicine? So I was looking into this one day at the hospital, and the next slide shows how it was almost always done. Next slide. And pretty much what was always the driving force for getting materials into medicine was a medical doctor going to their house to find an object that kind of resembled the organ or tissue they wanted to fix. And then they'd use something from their house. So it turns out like the artificial heart is a lady's girdle material because it has a good flex life like a heart. And a breast implant, one is a mattress stuffing because it's squishy. And that was pretty much all that was done in the 20th century. But I thought we could take more of a chemical engineering approach and ask the question, what do we really want in a biomaterial from an engineering, chemistry, and biology standpoint, and then create it from scratch. The next slide shows an example of what we tried to do. I was very interested, and we still do a tremendous amount of work in our lab on biodegradable polymers. But almost all of these degradable polymers degrade like this. They display bulk erosion, and that could lead to bursts of drug coming out, which for an anti-cancer drug or insulin could be fatal. So we said, from an engineering standpoint, what would you really like? And what we said is on the next slide, surface erosion. So we went to the blackboard. I had some very good chemists and toxicologists helping me, and we wrote different structures. And the next slide shows one of them that we thought would be very good. It's what's called a copolymer. And as you change the ratio of those two units, the CPP and the sebacic acid, you can get different erosion or release rates. And the next slide shows that depending on what you put, what the ratio is, you can get almost any release rate you want, from literally a day to weeks or even years. And since we did that, one of my friends, Henry Brem, he's now chief of neurosurgery at Johns Hopkins, came to see me and he said, well, Bob, could we come up with a better way to treat glioblastoma multiforme? And the next slide shows a little bit of, this was the 1980s, of what we were talking about. Normally, the lifespan for these patients, no matter what you do, is less than a year. But the drug they used at that time was shown on the next slide, BCNU. And it's terribly toxic, and you give it, it spreads throughout the whole body. So the idea we came up with was, next slide, could we allow the neurosurgeon like Dr. Brem to operate on the patient, open up the brain, because they're going to do that anyhow to take the tumor out as much as possible. But before he closes it up, could he line the surgical cavity with little wafers? Now, normally this drug has a 12-minute lifetime, but here with the polymer, it protects the BCNU from degradation. So you get high concentrations in the brain where you want it, and low concentrations where the rest of the body, where it could cause harm. Now, of course, if you're a professor in the US, you have to raise money. And so I would write grants on this and to try to get money from the National Institutes of Health, and I always did terrible. The next slide shows some of the reviews. So first, when we wrote this, the reviewer said the polymers couldn't be synthesized, but I had a terrific graduate student, Harry Rosen, who synthesized them. And then people said, well, okay, but then the polymers will react with whatever you put in because you have these anhydride bonds. But I had another great postdoc, Cam Leung, and he showed that didn't happen. Then people said, well, okay, but in 1985, they said the polymers are fragile. They'll break because they're low molecular weight. But I had another couple of postdocs, Edith Mathiowicz and Avi Dome. Edith is a full professor at Brown now, and Avi is head of, dean of pharmacy in Hebrew University, and they made polymers that were high molecular weight and very strong. And then people said, well, okay, but new materials are going to be toxic. But Cato Lorenzen, one of my graduate students, who won the National Medal of Technology from President Obama, showed that wasn't the case. And then people said, well, okay, but even so, the drug won't diffuse far enough to kill the tumor. But Mark Saltzman, who was my graduate student and actually headed up Yale University's first biomedical engineering department, showed that they did. Anyhow, this kept going on until 1996 when the FDA approved it. By the way, if people are wondering how we got funding, we did have patents and we got some corporate money. But at any rate, the FDA approved it in 1996. It was the first time in over 20 years the FDA approved a new brain cancer treatment, and the first time ever they approved this idea of local chemotherapy. Just to show you a little bit about how this looks, the next slide shows a picture. I'm going to go fast because I don't want you to have to look too long at these. Next slide. Usually they put 6 or 7 in and close up the brain. The next slide shows you some of the earliest clinical data, and it's not a cure by any means. It basically can prolong life and relieve suffering, but and you certainly see that on the second graph, the 2-year graph. In fact, a couple of years ago, next slide, they did an analysis of all the patients on over 60 trials. And what you see again is that you do get a significant survival. In fact, this has now been this treatment's now been approved for and used the last 24 years. It's been used in over 20 countries. And maybe not only is the fact that it can help in cancer, but also where it's helped even more based on some of our patents is in heart disease. And if somebody has heart disease, one of the main ways of treating heart disease is to put in a stent. Next slide. It's kind of like a Chinese finger puzzle. And but when you put these in, it can cause proliferation, a problem called restenosis. So what people now do is they take a different anti-cancer drug, Taxol, put it on a polymer and coat it on the stent. And these are used by millions of patients every year to keep blood vessels open. Well, the very last thing I want to talk about is, can we make new tissues or organs? In other words, not only can you deliver drugs, but could you deliver cells? And so this was motivated by work I did with Jay Vacanti. And here's a little baby on the next slide that's dying of liver failure. And the only way a child like that could live is somebody else would die. And Jay once asked me, could we come up with a different paradigm? And what we did is shown on the next slide. This is from a paper we wrote in Science. And our idea is that we could take almost any cell type. We actually wrote this before people talked about stem cells, but you could take any cell type. And if you injected at random, not much would happen. But turns out cells are smart. And if you put cells on a scaffold, they could actually reform structures. People had shown this before we did in basic work, like out at Berkeley. And then you have to grow it in vitro, like in a bioreactor, and you could make literally any tissue. And we use different materials. The next slide shows some of the ones that we would use. Either polylactic glycolic acid, which is FDA approved. We also synthesize brand new materials like polylactic acid colysine. And if you look at that amine group at the bottom, you can link in by covalently different amino acid structures, which can help certain cells stick. So we actually had a whole library of different materials. And then you'd make them into fibers like you see on the next slide. Or you could even make any structure by what are called CAD-CAM techniques. Prasad Shastri had done some of this. And let's say you want to make a nose. So the next slide's an example of that. You could use computer-aided design to make a nose. And you see that it's pictures of these. It's like 98% porous. And then you could design it by CAD/CAM, by computer-aided design, and then do something like foaming techniques or three-dimensional printing, and you could make the nose, and then you could take somebody's own cells, like from an ear, and make a tissue. And actually, to that end, some of the people in our lab and the Vacanti brothers, they've actually made tissue. The next slide is a picture of a nude mouse, and where on the bottom part you can see we've redone this guy's skull. And on the next slide, we've redone this, on the top left, we've redone this guy's cheek. And if you open up the animal and look at the tissue, it's pure white glistening cartilage. You see that on the next slide. And histologically, it's cartilage as well. The only thing is it's good cosmetically, but it's not strong enough if some of you are runners. And so we're still working on that. But what happened is the Army in the United States approached Jay, myself, and Linda Griffith, one of my former postdocs, and they said, we have people coming back from Iraq and Afghanistan, soldiers, without ears and without other body parts. Could you make those? So the next slide is a human ear that Linda made on the top part. And on the bottom right, you see a scanning electron micrograph of polymer fibers that will degrade actually into water and carbon dioxide. But before they do, you put cells on them, and the cells actually grow and they make matrix. And you can actually make an ear. This is shown on the next slide on a rabbit. Next slide. And the reason we do that is we want to show that these are safe for people. So, this has actually now been done on different patients. Here's a little boy who's 12 years old at the time, but he likes to play baseball. But if he were ever hit on the chest with a baseball, he could die. So Jay operated on him. We made a polymer scaffold for him. Jay took his cells and made a chest for him. And he's now doing fine, at 6 feet tall as a chest. Other companies have licensed our technology to make new skin, which is actually FDA approved for people who are burned or have skin ulcers. And I'll show that now on the next slide. So this is a little boy who's baby, 2 years old, very badly burned. But the product now is neonatal skin fibroblasts on a scaffold. Next slide. You can put it in the child at the time of injury. Next slide. And so this is time 0, but let's come back 3 weeks later. Next slide. And on the last slide, let's come back 6 months later. Next slide. Yeah. I'm sorry. Yeah, well, we'll stay there. I guess the last slide didn't come out. But basically, he's completely healed after 6 months, which is what I was going to show. Now, people are taking this in all different directions. You know, companies and scientists, you know, people are using tissue engineering now to make new spinal cords, to make new blood vessels, to make new corneas. And again, a lot of these are in clinical trials. And it's been taken in lots of other directions too. One of the concerns that people have is like animal testing and human testing. So now what we see is using these kinds of approaches, people having organs and tissues on a chip, which can minimize, I hope, animal and human testing. And people are even doing things that never even occurred to me when we first did this. Like some people, some of my former students even, and others are using this to make meat, you know, from scratch, to make leather and so forth. So this is basically what I want to tell you about some of the work we've done. I'm really deeply honored that you asked me to speak, and very honored about you giving me such a wonderful award. I want to wish you all the best, and thank you so much for having me. Thank you.
Thank you very much again, Bob. Nós voltamos para o português e eu cumpro-me apresentar a ministra Ana Abrunhosa, que tem, de uma forma incessante, apoiado o desenvolvimento da ciência para a coesão territorial e tentar que as regiões portuguesas também tenham mais ciência de uma forma aberta, e ela, melhor do que ninguém, pode nos dizer como é que percebemos também o desenvolvimento da ciência para o futuro e, sobretudo, numa altura onde estamos a desenhar os futuros fundos comunitários, quer ao nível do plano de recuperação e resiliência, quer, sobretudo, também no plano de financiamento, no programa de financiamento plurianual, aquilo que será o Portugal 2030, perceber como articular os fundos nacionais e os fundos de gestão centralizada europeus para melhor avançarmos neste campo de batalha que aqui foi tão bem demonstrado por estes dois cientistas e investigadores norte-americanos que trabalham com Portugal há muitos anos e que, sobretudo, nos têm apoiado neste percurso de fazermos sempre mais e melhor. Ana, muito obrigado.
Muito boa tarde, queria agradecer ao Sr. Ministro o convite e é um grande prazer estar aqui hoje, partilhar um bocadinho do que são a nossa experiência no apoio à ciência, mas sobretudo uma ciência que se quer mais digital, mais resiliente, mais verde, mais social e de que modo todas estas dimensões contribuem para digamos, uma coesão territorial e, portanto, aqui incluir também, eu estive ali a enumerar todos aqueles conceitos e eu vou acrescentar o mais local, mais territorial e, portanto, a importância de todas estas facetas da ciência para a competitividade territorial e, portanto, para os territórios e darei aqui alguma nota do que são também os nossos desafios nos territórios do interior. Quero fazer aqui primeiro uma nota muito importante. Vou focar-me sobretudo no papel da ciência, uma ciência muito ao serviço dos problemas da economia e muito em parceria com a comunidade. Isto não significa que nós não também a financiemos e que também não sejamos totalmente favoráveis a apoiar a investigação livre, sem utilidade imediata e, portanto, deixo essa premissa da importância de também financiarmos essa ciência que se faz sem fronteiras, de forma como sabem muito melhor do que eu. Eu tenho aqui algumas notas que vou seguir mais por uma questão de raciocínio e o que eu vos queria transmitir é que da experiência que temos, esta ideia de desencontro entre ciência e comunidade hoje é muitas das vezes uma ideia errada, cada vez mais errada. Eu devo dizer que nos últimos 5 anos esta questão de a ciência e aqueles que trabalham a ciência estarem cada vez mais próximos das comunidades envolventes é uma realidade, Não é uma realidade por necessidade, é uma realidade porque, de facto, os tempos assim o vêm exigindo. Estes períodos se há momento em que o cidadão normal, o cidadão que muito provavelmente nunca refletiu sobre a importância da ciência e a confiança que muitos de nós temos, basta ouvir basta pensar no que os 2 últimos oradores nos transmitiram. A confiança cega que muitos de nós temos na ciência para resolver os nossos problemas e as nossas dúvidas, muitas vezes existenciais, mas isso muitas das vezes está reservado para uma fração demasiado pequena da população. A pandemia trouxe ao cidadão comum a importância da ciência para resolver os seus problemas do dia-a-dia. Isto é muito importante. Eu às vezes digo isto num contexto mais político, mas penso que vão entender. O dia em que o cidadão comum entender que nós não resolvemos os nossos problemas, pelo menos de forma sustentável, de forma resiliente, sem ciência, o dia em que o cidadão comum entender isto vai, peço desculpa pela linguagem, vai dar votos e vai ser muito mais fácil para nós políticos canalizarmos verbas do orçamento para a ciência. Isto é tão simples quanto isto. A valorização que o cidadão comum dá ao trabalho que os cientistas fazem. E a pandemia pôs isto na discussão do dia-a-dia dos cidadãos, no café, na mesa do café, nas redes sociais. Isto é muito importante. Eu nunca falarei de uma oportunidade, porque esta pandemia não é uma oportunidade, falarei de uma lição que temos que reter e que temos que aproveitar. E, portanto, deixava esta primeira nota. E a importância que as sociedades têm que dar ao talento. Em primeiro lugar, a questão do talento, porque só o talento é que produz conhecimento ligado à ciência e à tecnologia. E, portanto, esta ideia, aquelas frases feitas de que o conhecimento é o grande motor da economia, eu penso que hoje o cidadão comum entende isto verdadeiramente e, portanto, esta verdade não está circunscrita a uma franja da população. Hoje ela está na consciência de todos os portugueses. Isso é, de facto, muito importante. O que é que tem contribuído para isto? O facto de termos um sistema científico e tecnológico muito mais consolidado, com uma distribuição territorial muito equilibrada, é uma das características do nosso país. O facto de termos as instituições de ensino, os centros tecnológicos, os centros de valorização do conhecimento, os centros de interface distribuídos no nosso território e próximo das economias locais, criou-se uma massa crítica que permite passar conhecimento para as empresas e, neste momento, nós já verificamos que são as empresas que vão ter com os centros de investigação, com os politécnicos, com os centros tecnológicos, para juntos desenvolverem e co-criarem novos produtos e serviços com os quais as empresas vão competir internacionalmente, em todos os setores. Isto é muito importante porque só depois deste contacto é que muitas das vezes as empresas se apercebem que têm que ter talentos nas suas organizações para absorver este conhecimento e para o endogeneizar nas suas organizações. E só a partir daqui é que as empresas, e quando falo das empresas, falo das organizações, passam a desenvolver atividades económicas de elevado valor. E só isso é que lhes permite contratar pessoas qualificadas e pagar salários elevados, porque é isso que permite reter os nossos talentos, ou seja, a valorização do conhecimento que têm e a possibilidade de, nas nossas empresas, desenvolverem atividades que aproveitem esse conhecimento. E, portanto, cada vez mais esta consciência de que o conhecimento é fator crítico para resolvermos os problemas das nossas sociedades. Nós, as nossas empresas, muito tradicionalmente, resolvíamos os problemas de forma empírica e hoje há esta concepção de que temos que ir mais além, de temos que pedir ajuda. Até porque isso é fundamental, estas parcerias, porque muitas das empresas não têm internamente estes recursos e ao fazer estas parcerias elas ganham dimensão porque incorporam competências que não têm internamente e que resultam destas parcerias. Queria aqui também sinalizar que o investimento em ciência e tecnologia por parte das organizações aumentou cerca de 60%. E isso deveu-se em grande parte não só ao grande dinamismo do nosso Ministro, do seu Secretário de Estado, pessoas extraordinárias, mas ao apoio dos fundos europeus que têm permitido criar estas sinergias com a atividade empresarial. E aqui, quando falo de fundos europeus, falo não só daqueles que gerimos no nosso país, mas falo também da importância das nossas instituições e das nossas empresas concorrerem às iniciativas geridas diretamente pela Comissão Europeia, porque isso tem outra vantagem para nós, é que nos insere em redes internacionais e, portanto, posiciona-nos e cria novas oportunidades, quer no ensino, quer na investigação, quer na inovação. E, portanto, é fundamental, esta questão da globalização é fundamental a expansão da área geográfica da nossa influência e é fundamental que cada vez mais assumamos lideranças em redes internacionais. E isso tem acontecido, isso depois é muito bom para a experiência que trazemos para o nosso país. Os centros de conhecimento, qual é a vantagem que muitas das vezes, ou que sempre em geral vemos nestas parcerias entre as empresas e os centros de conhecimento e o facto de os projetos inovadores, mesmo feitos em parceria com as empresas, a vantagem que têm de ser feitos nos centros tecnológicos, nos centros de conhecimento, é que os centros de conhecimento têm condições de liberdade e trabalham fora do ambiente de negócio para desenvolverem o conhecimento e as tecnologias e soluções inovadoras. Isso é muito importante, que estes projetos inovadores sejam feitos fora do ambiente de negócio normal e ainda num ambiente que depois permite o teste e o ensaio, que depois podem ser entregues de forma muito mais amadurecida às empresas. Isto verificou-se, por exemplo, com o ventilador, neste contexto de pandemia e com outras iniciativas a academia e que as entidades do sistema científico e tecnológico tiveram. Face a um mercado cada vez mais competitivo, não tenhamos dúvidas, e nunca é demais sublinhá-lo, e enquanto comunidade nós estamos cada vez mais conscientes disso, que é o conhecimento que permite às empresas anteciparem tendências de mercado e estarem à frente do mercado. Hoje já não basta seguir o mercado e aqui basicamente nós tivemos um bocadinho esta mensagem. As empresas, seja qual for a área, têm que antecipar, têm que estar à frente do mercado e só é possível fazê-lo com conhecimento. E é muito, muito importante que isto seja cada vez mais uma percepção enquanto comunidade. Simultaneamente, nós consideramos que é importante a implementação de estratégias que preconizem um caráter diferenciador para o conhecimento gerado, voltado para a inovação e para a dinamização da economia. É muito importante que criemos condições necessárias à atração e fixação de talentos, quer no setor público, quer no setor privado, em todas as regiões do país, mas sobretudo no interior, onde a baixa densidade populacional se torna uma preocupação de todos. Nós acreditamos que é a ciência que permitirá reverter esta tendência de envelhecimento da população e de abandono destes territórios. Parece estranho alguém estar a dizer que o problema do interior não é a agricultura, não é a floresta, como tradicionalmente se diz, mas dizer que a resolução dos problemas do interior é a ciência, e estamos convictos disso. É a ciência nos setores tradicionais, mas também é a ciência em setores de ponta. Portanto, não há territórios condenados à falência, não há territórios condenados à morte e a única garantia que podemos ter de que não estão condenados é com ciência, é com conhecimento, é com talentos, é com pessoas qualificadas. E, portanto, o Ministério da Coesão Territorial tem isto bem claro e é por isso que qualquer medida que trabalhamos, ou quase todas as medidas que trabalhamos, são de braço dado com o Ministério da Ciência, como não podia deixar de ser. E quero aqui aproveitar para dizer que, quer neste quadro comunitário, quer no próximo quadro comunitário, haverá uma prioridade clara no apoio à ciência nos programas operacionais regionais. Haverá uma prioridade clara ao apoio às parcerias entre a academia, entre os centros de valorização do conhecimento, entre os centros tecnológicos e a comunidade envolvente. Sejam projetos empresariais, sejam projetos sociais, sejam projetos na área da cultura, é muito importante para nós e será uma prioridade naquilo que será o primeiro eixo dos programas operacionais, o apoio à ciência. E aqui, a este propósito, eu queria sublinhar uma experiência muito interessante, que são os laboratórios colaborativos, que basicamente institucionalizaram aquele casamento que queremos fazer, que é entre o conhecimento e a comunidade. E, portanto, estes laboratórios colaborativos transformaram práticas pontuais de investigação em copromoção, em missões organizadas segundo estratégias complementares de elevado impacto na economia do país, permitindo percorrer diferentes cadeias de valor e mobilizar a cooperação intersetorial. Portanto, temos apoiado, vamos continuar a apoiar. Não pode, num país que se quer desenvolvido, tem que ser uma das prioridades da aplicação dos fundos, estou a falar dos fundos europeus regionais, geridos nas regiões, em todas as estratégias regionais. Esta é uma dimensão fundamental, a investigação colaborativa com a indústria, a investigação colaborativa com as associações e empresários, assegurando transferência do conhecimento, cocriação de conhecimento, tecnologia e inovação e, portanto, apoiar quer o que são as incubadoras, quer o que são, digamos, o robustecimento dos parques de ciência e tecnologia, os clusters tecnológicos, os projetos mobilizadores, os laboratórios colaborativos, a promoção de spin-offs, de startups, a promoção de núcleos de ID colaborativos, vão continuar a ser a prioridade na aplicação de fundos europeus. Creio que, paralelamente a esse posicionamento global e internacional que cada vez mais a nossa ciência tem, nós temos que ter a capacidade também de nos organizarmos internamente para nos posicionarmos de forma mais competitiva nas missões definidas pela União Europeia como prioritárias. E, portanto, queria aqui dizer que devemos valorizar a capacidade de exploração, que este conhecimento tenha a capacidade, e quando trabalham com as empresas, tenha a capacidade, como aqui foi referido, trabalhar o problema, trabalhar a especificidade, que este conhecimento que produzem, que este conhecimento e a tecnologia que desenvolvem tenha a capacidade de explorar as especificidades locais como elementos centrais do desenvolvimento socioeconómico do país e fazer o mesmo exercício para Portugal em relação à Europa. Estou aqui num exercício de global e de local e na importância de quando também, como atores ativos do desenvolvimento sustentável dos territórios e dos territórios mais frágeis, que tenham em conta também as especificidades desses territórios. Assumimos como sendo particularmente vital para as regiões do interior a exploração de segmentos de mercado mais sofisticados e as crescentes tendências de valorização da origem e autenticidade dos produtos. É este trabalho que está a ser feito em vários centros de investigação por todo o país, em perfeita harmonia com os institutos politécnicos, com as universidades que os acolhem e com as regiões envolventes. Queria aqui dizer que a melhoria das infraestruturas, bem como o aumento do nível tecnológico dos equipamentos, são evidentes e temos que continuar a fazer esse esforço, porém, volto ao ponto inicial, a prossecução do crescimento científico em Portugal está diretamente dependente das políticas que valorizam e consolidam a massa crítica que é o talento. E, portanto, queria aqui sublinhar a importância das medidas e do emprego científico e qualificado, alicerçando a formação doutoral, que é essencial para todas as regiões, sendo estas dinamizadas também pelas suas instituições de ensino superior, sejam elas politécnicas ou universitárias. E terminando, deixo o repto de que é com a ciência que nós, de facto, transformamos os nossos problemas em soluções que depois criam riqueza e valor e retêm os talentos nos territórios, é juntando inovação à investigação e articulando-a com o ensino que contribuímos para o desenvolvimento local, contribuindo certamente muito mais para o desenvolvimento do país. Portanto, fica aqui a palavra de mote: colaborar para inovar. Sem as empresas, o conhecimento que produzem não se transforma em inovação, não chega ao mercado, não cria valor, nem riqueza, nem que seja de forma, como dizia o nosso primeiro orador, de forma interessada, própria, mas de facto deixava aqui esta nota de grande satisfação no percurso que as nossas instituições têm feito no território. No território, deixava aqui uma nota especial para as instituições que trabalham connosco, nem de propósito, professora Helena, a Fundação para a Ciência e a Tecnologia, parceiros imprescindíveis do Ministério da Coesão Territorial, e deixava aqui também uma palavra preciosa para o trabalho da Agência Nacional de Inovação, que têm sido parceiros das nossas CCDRs, das nossas regiões, e deixar mais uma vez sublinhado que não será certamente por falta de recursos nos fundos europeus que ainda temos para aproveitar do Portugal 2020, do Portugal 2030 e do Plano de Recuperação e Resiliência, relativamente ao qual apelamos a uma grande dinâmica dos territórios. Nós acreditamos que uma parte importante daquelas verbas tem que ser concorrencial e, portanto, obterão tanto mais verbas quanto melhores forem as propostas que apresentarem. Contem connosco para também mobilizarem os atores da região, porque é destas parcerias que certamente surgirão propostas de valor que terão mérito reconhecido, porque não esqueçamos que o objetivo final do Plano de Recuperação e Resiliência é introduzir mudanças estruturais nos territórios, envolvendo os atores dos territórios, mas isso não se faz sem ciência, isso não se faz sem conhecimento, sem tecnologia, isso não se faz sem talento. Sr. Ministro, agradeço mais uma vez todo o privilégio que tenho de trabalhar consigo e com a sua equipa e a honra de estar aqui hoje a encerrar esta sessão. A todos, parabéns pelo trabalho que têm feito e continuação de bom trabalho. Muito obrigada.
Às 5 voltamos para a cerimónia de encerramento. Obrigada.
aproximar-nos do fim deste encontro com a última plenária, a plenária 6, Mais Ciência para Recuperar Portugal com Mais Europa. E vamos ter nesta sessão 2 oradores, a professora Elvira Fortunato e o professor Pedro Conceição. A professora Elvira Fortunato é professora do Departamento de Ciências dos Materiais da Faculdade de Ciências e Tecnologia da Universidade Nova de Lisboa e diretora do Cinemat. Atualmente dirige também o I3N, Nanoestruturas, Nanomodelação e Nanofabricação. É vice-reitora para a investigação da Universidade Nova de Lisboa. E sabemos todos como foi pioneira na investigação europeia sobre a eletrónica transparente, tendo já recebido inúmeros prémios nesta área, nomeadamente do European Research Council. Professora Elvira, se faz favor.
Muito boa tarde a todos, Sr. Ministro, caros colegas. É com imenso gosto que estou aqui e que venho e vou poder partilhar um bocadinho convosco parte das coisas que fazemos ali pelos lados da Caparica na área da sustentabilidade. Já agora não está aqui a aparecer à frente. Dava mais jeito. Portanto, eu vou falar um bocadinho na área da sustentabilidade e gostaria também de mencionar que nós, os cientistas, os investigadores, somos extremamente importantes exatamente em todas estas áreas, quer na área dos materiais, quer na área das tecnologias, e acabamos nós por ser os responsáveis em fazer com que todos estes processos e tudo aquilo que nos rodeia seja cada vez mais sustentável. Só em termos genéricos, nós temos uma estratégia, assim como existe em qualquer laboratório, qualquer grupo de investigação, e na área da estratégica que temos, nós trabalhamos com materiais, basicamente em engenharia de materiais, nanotecnologias, e precisamos também de processar esses materiais. Relativamente aos materiais, tentamos utilizar sempre que possível materiais abundantes e materiais não tóxicos, e uma vez que temos que processar esses materiais para fazer um dispositivo, fazer um sensor, um transistor, aquilo que seja, tentamos sempre utilizar tecnologias também não poluentes, amigas do ambiente. É evidente que estamos perfeitamente alinhados com os objetivos de sustentabilidade que foram lançados pelas Nações Unidas em 2015, muito embora toda esta área da sustentabilidade já faça parte do nosso grupo de investigação há bem mais anos. Na área da eletrónica, é evidente que aquilo que eu vou aqui apresentar não é uma solução para todos os problemas, mas é evidente que se todos nós, nas nossas áreas de investigação, conseguirmos contribuir um bocadinho para tornar este mundo ou aquilo que estamos a fazer mais sustentável, é evidente que vamos conseguir. Na área da eletrónica, isto é aquilo que nós hoje em dia fazemos, portanto, existe aquilo que se chama o high-tech trash, este lixo eletrónico. Lixo eletrónico que, na maioria dos casos, nem é reciclado. Isto também não é a melhor forma de se reciclarem alguns materiais de elevado custo desta eletrónica, nomeadamente o cobre e até, em alguns casos, terras raras. Esta também não é a melhor forma que existe para nós selecionarmos os vários materiais deste lixo, e é evidente que temos que ter formas para resolver estes problemas. É evidente que nós, atualmente, há já algumas coisas que estão a ser feitas, mas aquilo que acontece ainda nos dias de hoje é grande parte destes problemas não estarem a ser resolvidos e, basicamente, aquilo que está a acontecer é a exportação destes problemas, especialmente do hemisfério norte, para outras partes do globo, nomeadamente países em África, na Índia e na China. É evidente que isto não é solução. Então, o que é isto da eletrónica de papel e o que é que nós fizemos relativamente à celulose? E porquê que passámos a trabalhar com a celulose? É evidente que a celulose é um material, para já é o biopolímero mais abundante na Terra, é um material flexível e que não se parte e para algumas aplicações não só da área da eletrónica, mas até aplicações biomédicas, é extremamente importante. O seu custo é baixo, é também um dos nossos objetivos, é trabalhar com materiais de baixo custo. É um material muito leve e para algumas aplicações o peso é também uma característica extremamente importante. A tecnologia de fabrico do papel é milenar e nós em Portugal temos indústria de papel de ponta nesta área. Só para terem uma ideia, a papeleira, uma das papeleiras nacionais produz papel de fotocópia a uma velocidade de 100 km por hora, portanto folha de papel. Portanto, a tecnologia está bem estabelecida, nós não precisamos de inventar mais tecnologia, quer a nível do fabrico de papel, quer a nível do processamento de folha de papel. E depois o papel, a celulose, tem boas propriedades dielétricas, o que é muito bom do ponto de vista de eletrónica, porque um dos materiais que nós usamos para fazer eletrónica, dos três principais, condutores, semicondutores e isolantes, o papel tem boas propriedades isolantes, portanto pode ser utilizado como material de eletrónica exatamente devido às suas propriedades isolantes. O papel está em todo o lado. Se nós tivermos aplicações, produtos baseados na tecnologia e em papel, em qualquer parte do mundo nós podemos ter estes produtos, porque existem os produtores e existe o papel. E, por último, é um material que pode ser reciclado. Portanto, todas estas aplicações que nós fizemos mesmo na área da eletrónica ou na área das aplicações biomédicas, podemos reciclar estes produtos e voltar a incorporar isso na pasta de papel e fazer mais papel reciclado. É evidente que nós temos sempre o plano B, às vezes o C e o D. A celulose, como nós a conhecemos, ela tem origem vegetal, vem das árvores, e nesse caso nós precisamos esperar cerca de 10 anos para que um eucalipto ou um pinheiro cresça, o possamos cortar e extrair a madeira, a celulose da madeira. Mas, por exemplo, se utilizarmos uma solução de vinagre, basta-nos esperar, se calhar, 2 ou 3 dias numa solução apropriada de vinagre e ter exatamente folhas de papel com uma espessura similar à espessura de um papel de fotocópia. Ora, isso é porque o vinagre tem umas bactérias que não são inofensivas. Aliás, quem gosta de vinagre ingere essas bactérias de forma regular. E estas bactérias, que se chamam acetobacter, que existem no vinagre, elas produzem também como forma de defesa uma estrutura que se chama nanocelulose. É nano exatamente porque as fibras que elas produzem, portanto, estas bactérias funcionam como umas nanoextrusoras, elas vão excretando umas fibras de nanocelulose e fazem exatamente essa rede tridimensional, dá origem também a um papel, mas cujas propriedades são diferentes do papel que nós conhecemos, que até tem a cor branca, porque tem os aditivos, mas neste caso este papel é transparente, é 100% celulose, mas exatamente as propriedades ópticas devem-se a que, como temos nanofibras, não há interferência óptica da radiação na gama do visível com as nanofibras de celulose. Daí, como não há interação, portanto, este papel, estas membranas de nanocelulose são transparentes à radiação visível. Se olharmos para estes materiais, estas celuloses, quer de origem vegetal, quer de origem bacteriana, através do microscópio eletrónico, podemos ver que ambas são muito parecidas. Nós temos fibras que se dispõem de uma forma tridimensional. A única diferença é que, se olharmos para as escalas, na fotografia do lado esquerdo as escalas são 100 micrómetros, a fotografia do lado direito são 100 nanómetros. Portanto, do lado direito a nanocelulose, as fibras produzidas pelas bactérias, neste caso as fibras de celulose extraídas da madeira. Agora, só algumas aplicações de dispositivos que nós temos feito ao longo destes anos, utilizando estes materiais de origem renovável. Nós, em 2008, propusemos o primeiro transistor de papel. É evidente que ainda hoje temos muito os e-papers, os e-books, os e-qualquer coisa, porque a ideia é substituirmos o papel de origem celulósica por um equipamento eletrónico. Nós, como trabalhamos com a celulose, utilizamos a celulose com fins eletrónicos, mudamos o E da esquerda para a direita e trabalhamos em paper-e, porque usamos exatamente, utilizamos as propriedades da celulose para aplicações na área da eletrónica. Basicamente, o transistor que fizemos é um transistor muito simples, não vou estar agora aqui a falar muito de transistores, mas há vários tipos. Este é um transistor de efeito de campo, basicamente funciona como um switch on-off, ou está aberto ou está desligado, e fazer um transistor de papel não é mais do que fazer uma fotocópia frente e verso. Nós, numa das faces do transistor, colocamos um material condutor, que também pode ser um destes óxidos condutores, portanto, materiais também sustentáveis. Na parte de cima temos o semicondutor, que também é à base de ZNO, portanto, materiais, mais uma vez, de origem sustentável, e temos o transistor feito. Portanto, é muito simples. Aqui temos também o exemplo de um transistor utilizando estas fibras de nanocelulose e até chegámos à conclusão que, como eu costumo dizer que a natureza é perfeita, como a rugosidade destas membranas é muito inferior à rugosidade do papel de origem vegetal e também porque é praticamente 100% celulose, os dispositivos feitos com estes materiais acabam por ter também um desempenho elétrico superior. Aqui é um aspecto dos transistores, aqui temos um aspecto de papel condutor, nós podemos alterar, funcionalizar as propriedades do papel e torná-las não só isolantes, condutoras ou semicondutoras. Aqui há alguns exemplos de protótipos de eletrónica impressa, eletrónica flexível, em que nós utilizamos o papel para fazer circuitos integrados, com displays, sensores de gases, etc. Portanto, alguns destes protótipos foram feitos no âmbito de projetos europeus. Como estes dispositivos necessitam de funcionar, precisam de energia, fizemos também aquilo que se chama o tetrasolar, que são células fotovoltaicas, em que utilizamos, por exemplo, as embalagens de Tetra Pak, em que o Tetra Pak, uma das faces já é alumínio, é um contacto elétrico, e fizemos estas células fotovoltaicas que funcionam muito bem, exatamente porque nós estamos a falar de eletrónica de potência, portanto, é para alimentar estes dispositivos, assim como fizemos também, por exemplo, células fotovoltaicas flexíveis. Portanto, isto é uma das grandes vantagens, porque podemos conformar esta eletrónica, portanto, os painéis fotovoltaicos que conhecemos nos telhados, é evidente que a energia, a sua potência é superior, mas neste caso nós podemos conformar, adaptar a qualquer forma geométrica esta eletrónica, seja uma célula fotovoltaica, seja um sensor, seja aquilo que for. E por outro lado, só para terem a noção de como a celulose ou a madeira ou estes materiais têm tantas propriedades que ainda estão por explorar, exatamente no campo da eletrónica, há cerca de 2 anos foi publicado um artigo na Advanced Materials, que é uma das revistas de referência na área dos materiais, em que é possível fazer grafeno, que foi o Prémio Nobel da Física em 2010, a partir da madeira, com tecnologias muito baratas e de muito baixo custo. Para além da parte da eletrónica, nós também desenvolvemos testes de diagnóstico, também costumamos chamar de biosensores, utilizando a tecnologia do papel, e é evidente que, seguindo as recomendações da WHO, em que é necessário desenvolver testes de diagnóstico que, no fundo, satisfaçam todos estes requisitos. É evidente, como sabem, costuma-se dizer que a indústria dos biosensores ou dos testes de diagnóstico é uma indústria multibilionária. É evidente que cerca de 90% dos testes que nós usamos hoje em dia, ou pelo menos que são comercializados, são para a glucose, mas é evidente que hoje em dia há uma série de outros testes, ácido úrico, colesterol, uma série de exames que nós podemos fazer já numa farmácia, e a tendência é aumentar. Nós usamos também uma tecnologia muito barata, que foi desenvolvida em 2008 também pelo professor Whitesides, de Harvard, em que utilizamos uma fotocopiadora a cera, da Xerox, e posso dizer a marca porque é a única que imprime a cera, e podemos criar no interior do papel barreiras hidrofóbicas, ou seja, ter microfluidica. Temos a microfluidica convencional, de câmara limpa, com microeletrónica. Neste caso não, temos microfluidica em papel, porque imprimimos a cera nos locais onde queremos, colocamos o papel num prato de aquecimento a 100 graus centígrados, a cera, que basicamente é parafina, difunde para o interior, ao longo da espessura do papel, e criamos essas regiões. O papel é hidrofílico, a cera é hidrofóbica, e temos esses sensores. Tenho aqui um vídeo em que temos um exemplo, portanto a cera é transparente, não se vê, temos ali uma solução com açúcar, e depois temos 3 zonas em que se vai desenvolver uma determinada coloração, cuja intensidade é função da concentração de açúcar, mas fazemos testes rápidos, testes de diagnóstico e testes que não necessitam de equipamento eletrónico. Nós desenvolvemos, entretanto, aplicações para telemóveis e em determinadas condições de imagem nós podemos exatamente até, não são só qualitativos, mas acima de tudo quantitativos. E no final não temos partes plásticas, não temos nada, podemos simplesmente queimar o pedacinho de papel e não há problemas de contaminação. É evidente que as áreas na área da eletrónica de papel são várias, é evidente que as emergentes são na parte da embalagem inteligente e etiquetas inteligentes, e para tudo isso nós precisamos de desenvolver todos estes circuitos, sensores, sistemas de comunicação, etc., que sejam compatíveis. E é evidente que existem uma série de oportunidades, aqui a saúde, a água, a alimentação e a internet das coisas são as mais emergentes. E gostaria também de mencionar que no âmbito desta área nova e sustentável foi criado um laboratório colaborativo que se chama Alma Science, que é coordenado pela Imprensa Nacional Casa da Moeda, que já trabalha connosco há vários anos, exatamente na área do papel de segurança, na área da embalagem, e este consórcio, sendo coordenado por uma empresa, tem também o Fraunhofer Portugal, tem a Navigator, tem a Raiz e tem também um laboratório de análises clínicas, exatamente para explorar aquilo que se tem feito na área da eletrónica e também na área dos testes de diagnóstico e tentar que o conhecimento, como foi há bocadinho até dito pela Ministra, passar este conhecimento que nós geramos nas universidades para a inovação, que passe para as empresas. E pronto, isto gostaria, para terminar, de agradecer à equipa que trabalha. É evidente que isto é muito teamwork, aliás, exatamente como se falou há bocadinho no interior, se nós quisermos desenvolver mais o interior, temos que ter lá equipas, não são pessoas, são equipas grandes para se poder trabalhar. E, por último, não poderia deixar de agradecer os financiamentos, andamos sempre atrás deles, nomeadamente os financiamentos nacionais, mas acima de tudo também os financiamentos europeus que temos tido e dos quais nos orgulhamos muito, e gostaria de vos agradecer a vossa atenção. Muito obrigada.
Temos agora online o professor Pedro Conceição, do Programa de Desenvolvimento das Nações Unidas. Pedro Conceição é o atual diretor do Gabinete do Relatório do Desenvolvimento das Nações Unidas, com uma experiência de 20 anos ao serviço da ONU, onde assumiu já vários cargos, como diretor do Gabinete de Desenvolvimento de Estudos, economista-chefe e responsável pela Unidade de Aconselhamento Estratégico do Gabinete Regional para a África do Programa de Desenvolvimento. Obrigada. Consegue nos ouvir bem e partilhar os slides?
Muito bem, eu não vou ter slides. Não vou apresentar slides. Queria só começar por agradecer ao Sr. Ministro da Ciência o convite para participar neste encontro e pela oportunidade que me é dada de partilhar algumas reflexões sobre aquilo que eu chamaria o papel da ciência nas sociedades de hoje em dia. A minha perspectiva é mais uma perspectiva global, vinda das Nações Unidas, informada pelo trabalho que eu faço nas Nações Unidas, mas aquilo que vou partilhar é apenas a minha opinião pessoal e não reflete a posição da organização. Eu tenho três reflexões principais a fazer. A primeira relaciona-se com a relevância da ciência no momento em que vivemos, o momento da pandemia. Depois sugerir que esta relevância da ciência, a interação que tem tido com a sociedade, apresenta uma oportunidade para um novo tipo de diálogo entre a comunidade científica e as nossas sociedades. E, por fim, deitar um olhar sobre o futuro e partilhar algumas reflexões sobre aquilo que me parece importante salvaguardar, olhando para o futuro do envolvimento da comunidade científica com as nossas sociedades, para nos ajudar a responder aos desafios com que nos confrontamos. Portanto, relativamente ao primeiro ponto, a relevância da ciência no momento atual, eu penso que é evidente que a pandemia nos mostrou que se olha para a ciência para informar políticas públicas, não só no domínio da saúde pública, mas também no domínio de muitas outras áreas. Por exemplo, as políticas económicas também olham muito para aquilo que a ciência nos diz relativamente à forma como o vírus se vai propagando. E também não só importa para informar as decisões de políticas públicas, mas também para informar a população em geral relativamente aos seus comportamentos. Embora a ciência tenha sempre estado bastante presente no domínio da saúde, eu penso que é cada vez mais invocada para informar muitas das discussões, incluindo as discussões que acontecem aqui nas Nações Unidas em muitos outros domínios. Um exemplo é aquilo que acontece com as alterações climáticas, em que tantas vezes se começa por invocar aquilo que a ciência nos diz relativamente ao efeito das concentrações de gases de efeito de estufa na atmosfera. Esta relevância da ciência, no entanto, traz também um novo tipo de escrutínio social relativamente aos resultados e aos métodos científicos. No caso das alterações climáticas, isso é muito evidente quando há debates em torno dos intervalos de confiança de estimativas que têm a ver com processos atmosféricos, mas também com as incertezas associadas às implicações desses processos na economia e na sociedade de forma mais alargada. E também temos observado que a evolução científica relativamente àquilo que se sabe sobre a pandemia tem também levado a uma evolução das recomendações por parte da comunidade científica relativamente àquilo que os decisores políticos devem fazer e àquilo que as populações devem fazer. Portanto, eu diria que há aqui uma dualidade entre uma relevância cada vez mais importante, ou pelo menos muito importante, da ciência hoje em dia, mas que isso também vem associado a um escrutínio mais fino sobre aquilo que são não só os resultados científicos, mas também o método científico. Portanto, este era o meu primeiro ponto. O meu segundo ponto é que, em minha opinião, isto traz-nos uma oportunidade para começar um diálogo mais aprofundado entre entre as sociedades e a comunidade científica. E aqui acho que é importante a comunidade científica e todos nós percebermos a forma como as pessoas absorvem, interpretam a informação que vem da ciência. Por exemplo, está demonstrado que muitas das pessoas que rejeitam a evidência científica relativamente às alterações climáticas fazem-no porque associam o facto de aceitarem que as alterações climáticas são consequência de atividade humana como algo que entra em confronto ou em conflito com alguns dos seus valores. Por exemplo, valores que podem ter a ver com alguma relutância em aceitar intervenções governamentais no domínio da regulação. Portanto, eu penso que é importante nós estarmos cientes da forma como as pessoas muitas vezes absorvem, interpretam a informação que vem da ciência e estar cientes que afirmar a integridade do método científico pode não ser suficiente e que há aqui um espaço para a comunidade científica explorar novas formas de comunicar e dialogar com a sociedade, especialmente com pessoas que interpretam, podem interpretar a informação que vem da ciência de uma forma que pode vir em choque com outros dos seus valores. E do outro lado, eu penso que é importante também reconhecer que a atividade científica é algo que não acontece num vácuo. É também ela própria uma criação social que tem os seus enviesamentos, que responde a um conjunto de incentivos que são variados. E eu só vou dar um exemplo para ilustrar. Houve um estudo recentemente que demonstrou que quando há a morte prematura daquilo que se chama um star scientist, uma pessoa que é muito reconhecida no seu domínio científico, as publicações dos seus colaboradores nos 4 anos subsequentes a essa morte caem em 40% e as publicações dos não colaboradores sobem em 10%. O que é que isso demonstra? Demonstra que há um certo enviesamento quando algumas pessoas, alguns investigadores na comunidade científica adquirem uma posição que socialmente é vista como, de alguma forma, dominante. E também está demonstrado que nessa diferença de 50 pontos percentuais existe uma oportunidade para inovação, novas ideias, novas perspectivas surgirem que acabam por ajudar esse campo científico a progredir. Portanto, acho que é importante perceber também que a ciência é ela própria uma construção social e também perceber que às vezes é importante beber da sociedade aquilo que podem ser valores importantes para nos ajudar a perceber a forma como a ciência pode evoluir. Eu penso que isso é particularmente importante em domínios que nos podem trazer dilemas éticos, como na inteligência artificial ou na manipulação de genes. E tendo feito estes 2 pontos preliminares, acabaria com uma série de reflexões olhando mais para o futuro. E aqui começaria por dizer que se pode olhar para este momento em que vivemos da pandemia como uma oportunidade, dada a relevância da informação científica e daquilo que a ciência nos diz para o nosso comportamento no dia-a-dia, para as decisões políticas. Mas eu penso que é importante ter um alerta, porque eu vou contar uma história para ilustrar o que eu quero dizer. Em 1918, a reunião anual da American Historical Association estava planeada para Cleveland, no Ohio, para dezembro de 1918 e acabou por ser cancelada. E foi cancelada porque as autoridades de saúde pública de Cleveland estavam preocupadas com a gripe espanhola, que nesse momento estava a expandir-se na cidade de Cleveland, Ohio. Portanto, a reunião nunca aconteceu. Houve uma referência a essa reunião que nunca aconteceu na revista principal da American Historical Review, 20 anos mais tarde, mas a razão principal dada para a não realização da reunião foi a dificuldade de deslocação ligada ao fim da Grande Guerra, na altura, como se chamava, a Primeira Guerra Mundial. Portanto, isto mostra que pode haver uma tendência a não nos lembrarmos ou esquecermos de momentos que agora nos parecem marcantes. O que me parece evidente, no entanto, é que a ciência vai ser cada vez mais importante olhando daqui a 20 anos, mesmo que os historiadores não se lembrem muito bem do momento dramático e trágico que vivemos nesta altura, porque nos confrontamos com uma realidade que não tem precedentes na nossa história, na história da nossa espécie humana, mas também não tem precedentes na história do nosso planeta, na medida em que a interação e as modificações que nós estamos a trazer a processos planetários não têm precedentes. As alterações climáticas são um exemplo, mas há muitos outros. Isso leva algumas pessoas a utilizarem a ideia do antropoceno para designar o que talvez possa ser uma nova época geológica. E aquilo que isso sugere quanto a mim é que a ciência vai ser cada vez mais importante para nos ajudar a perceber essa interação e para nos ajudar também a perceber a forma como podemos lidar com os desafios que se nos vão apresentar. E acho também que nos vai levar a encontrar novos espaços de colaboração entre várias ciências, domínios das ciências, mas também interações entre as ciências naturais com ciências sociais e com humanidades. Por exemplo, há uma área da economia que está hoje em dia bem estabelecida, que é a economia das alterações climáticas, que foi recentemente reconhecida através de um prémio Nobel. Há um interesse crescente do ponto de vista de historiadores em perceber a forma como fenómenos naturais influenciaram aquilo que até há bem pouco tempo se pensava que era apenas fruto de decisões humanas, pandemias que ocorreram no passado, erupções vulcânicas e outros fenómenos naturais. Portanto, eu acho que não só a ciência vai ser cada vez mais importante, mas há um novo espaço para a ciência dialogar com outras áreas, de forma interdisciplinar, mas também com as humanidades. E eu terminaria assumindo que isto vai ser verdade, sugerindo 3 ideias para o futuro. A primeira é que é importante ver na ciência não só algo com utilidade, que nos pode trazer inovações tecnológicas importantes para o nosso bem-estar, para as nossas economias, mas tão importante como essa contribuição da ciência é estar constantemente a aprender. Se algo que esta ideia do antropoceno nos ensina é que as tecnologias que em certo momento da história nos pareceram revolucionárias e levaram a avanços dramáticos nas nossas condições de vida, por exemplo, a utilização de combustíveis fósseis, também trazem com elas muitas vezes problemas que não conseguimos antecipar. Portanto, eu penso que a resposta a este desafio não é rejeitar a ciência, não é rejeitar a tecnologia, mas, pelo contrário, continuar a investir na ciência como mecanismo de aprendizagem constante para nos ajudar a perceber esses desafios que nem sequer conseguimos antecipar de inovações tecnológicas ou avanços científicos que nos parecem revolucionários e parecem contribuir de forma significativa para a melhoria das nossas condições de vida. A segunda coisa que me parece muito importante é imbuir na sociedade um espírito de cultura científica e não ver muitas vezes na evolução das ideias científicas ou daquilo que emerge como recomendação científica para o nosso comportamento ou informação que é utilizada pelos decisores como de forma defensiva, mas estimular este espírito de perceber como é que a ciência funciona, como um espaço disciplinado de confronto de ideias sujeitas a um método científico reconhecido. E eu penso que isto só é possível fazer através de esforços como Ciência Viva, por exemplo, que estimulam a cultura científica, que olha não só para a importância dos resultados científicos, mas também nos ensina a perceber a forma como a ciência é feita. E, finalmente, eu diria que é crucial redescobrir e dar cada vez mais apoio público à ciência. O estudo recente demonstrou que tem havido, o estudo chama-se Are Ideas Harder to Find? Are Ideas Getting Hard to Find? E o que o estudo mostrou foi que é preciso, hoje em dia, fazer muito mais esforço de investigação para chegar aos mesmos resultados, ou resultados equivalentes há uns anos atrás. Por exemplo, se olharmos para a lei de Moore, que nos diz que a densidade de chips em microprocessadores duplica cada 2 anos, mais ou menos. Hoje em dia é 18 vezes mais difícil conseguir manter esse ritmo de inovação tecnológica do que em 1971, ou no início dos anos 70, quando esta lei foi estabelecida pela primeira vez. E uma das grandes razões que está por trás desta dificuldade relaciona-se, de acordo com o estudo, com a diminuição do investimento público em investigação básica e fundamental. Portanto, eu terminaria dizendo que me parece que a ciência vai ser cada vez mais importante para as nossas vidas, que é importante encontrar novos espaços de diálogo entre a comunidade científica e as nossas sociedades, e que esta é uma altura muito má para não fazer um esforço muito significativo em investir no apoio à ciência, especialmente apoio público à ciência. Muito obrigado.
Já está ligado? O vídeo está bem.
Sr. Ministro, Professora Helena Pereira, Manuel Carvalho, diretor do Público. Vamos então entregar os certificados dos vencedores do Prémio Arquivo.pt 2020. O Prémio Arquivo.pt tem como objetivo galardoar anualmente trabalhos inovadores realizados com base na informação histórica preservada pelo Arquivo.pt. O terceiro classificado é o trabalho intitulado Arquivo Económico.pt, da autoria de Nuno Bragança. Parabéns, Nuno. O segundo classificado é um trabalho intitulado Extensão do Arquivo.pt, da autoria de Rodrigo Marques e Hugo Silva. O Rodrigo e o Hugo vieram hoje do Porto. Aliás, o Rodrigo veio de França. Foi o Rodrigo, não foi? França, Porto, Porto, Lisboa. Fotografia. O primeiro classificado é um trabalho intitulado Desarquivo, da autoria de Miguel Ramalho. Em sua representação para receber o prémio, já que o Miguel está na Hungria, é português, mas está a trabalhar na Hungria e não conseguiu voar, está presente o seu pai. Por fim, a menção honrosa do Jornal Público, que foi o media partner deste prémio, e que agradecemos muito o apoio na figura do seu diretor, que foi muito importante para chegar a mais investigadores, foi chave este ano para chegar a muito mais gente, e foi um trabalho intitulado O Jornal do Passado, da autoria de Bruno Galhardo, e será entregue aqui representado pelo diretor do Público, Manuel Carvalho. O Bruno veio de Coimbra. Muito obrigado para o ano a mais no Prémio 2021. Muito obrigado.
Muito boa tarde a todos e, em particular, muito boa tarde ao Presidente da República, Marcelo Rebelo de Sousa, que se junta a nós por via online. E todos aqueles que pensavam que isto ia voltar ao normal, sabemos bem que esta conferência, a falar para um auditório vazio desta dimensão, é bem um sinal dos tempos de mudança, mas como também ficou bem claro ao longo destes 2 dias que o futuro não vai ser igual ao passado e o futuro e a nossa vida social, económica, cultural ou científica, e repito, a vida também científica, será sempre diferente daquela que era antes desta pandemia. Desde já, mais uma vez, um apoio muito claro àquilo que tem sido a presença constante do Presidente da República nestes eventos e, particularmente, neste ano, com quem temos discutido também a evolução daquilo que pode ser o contributo da ciência para o futuro das nossas sociedades. Este evento, este ano, surge, obviamente, num tempo sem precedentes para todos nós, um tempo também sem precedentes para a ciência e, sobretudo, numa altura onde estamos a aprender, certamente, dia após dia, que a ciência cura, mas cada vez mais, eu diria, o que estamos verdadeiramente a aprender é que a ciência é um campo de batalha. De facto, o risco e a incerteza constante, sobretudo a incerteza sobre o futuro, parece-nos, pelo menos a alguns, que só pode ser combatida com mais conhecimento. E é este debate que é particularmente importante e que foi aqui presenciado durante os últimos 2 dias, também de uma forma nova. Tivemos mais de 10.000 pessoas a entrarem no sítio da internet da conferência. Muitas das sessões tiveram mais de 450 pessoas em simultâneo e aqui neste auditório nunca tiveram mais cerca de 60 pessoas. O tempo de ligação das pessoas variou muito. Tiveram pessoas que tiveram 10 minutos, tiveram pessoas que tiveram quase um dia inteiro ligadas. Mas esta forma de interagir, que certamente está associada também à pressão e ao alerta que a pandemia nos trouxe, não nos pode retirar daquilo que é o essencial, do papel que o conhecimento sempre teve e sempre terá ao longo da evolução das nossas sociedades. E esta questão é crítica também porque sabemos que esta pandemia apareceu nos animais, como ontem ficou bem claro, transferiu e foi transferida para os seres humanos e que hoje sabemos que as doenças zoonóticas ou zoonoses tenderão a crescer, em particular associação a um crescente desequilíbrio entre a atividade humana e económica e a natureza, que sabemos que também se manifesta nas alterações climáticas. E é esta evidência que estamos a tentar construir, sobretudo com o conhecimento científico, entre a relação entre a pandemia, entre as desigualdades sociais e económicas que coexistem com esta pandemia e eventualmente estão a ser ampliadas, mas também com aquilo que é a nossa posição no planeta Terra e, como hoje aqui já foi dito, nesta nova era do antropoceno, que não sabemos o suficiente. E por isso, este banho de ignorância onde todos estamos embebidos só nos pode dar esta ambição de saber mais e de aprender mais. Foi neste contexto que ontem lançámos a primeira sessão onde o Primeiro-Ministro, de uma forma particularmente interessante, nos veio chamar a atenção que podemos claramente olhar para a ciência como uma resposta imediata, fazendo mais e melhores testes, procurando de uma forma rápida uma vacina, mas que isso não chega e que é preciso também usar a ciência para perceber as causas desta pandemia e para podermos evitar novas pandemias. Se sairmos nos próximos meses desta pandemia, a questão não é só essa, a questão é evitar outras pandemias. E é nesse contexto que ontem também o Prémio Nobel da Química, Aaron Shikanover, um médico israelita, nos apontou de uma forma clara as desigualdades crescentes com que esta pandemia abriu. Falou, por exemplo, que a questão crescente do racismo nos Estados Unidos da América tem sobretudo a ver com a desigualdade do acesso ao conhecimento. Reportou-nos, por exemplo, que a forma como a pressão que está a ser posta em algumas zonas do mundo para o usamento de vacinas, aquilo que ele chamou o nacionalismo para as vacinas, está a trazer problemas éticos que nunca tinham sido presenciados, sobretudo com os estímulos aos chamados voluntários para, em algumas zonas do mundo, para testar as vacinas. E falou-nos na desinformação da opinião pública e, portanto, como cientista e como médico cientista, apelava também à comunidade científica para se corresponsabilizar por este processo de acesso ao conhecimento. Foi curioso que depois, ontem à tarde, a ministra Mariana Vieira da Silva pegou neste tema e abordou a questão das desigualdades, também na questão em Portugal e a forma como Portugal e na Europa e na presidência portuguesa da União Europeia temos que ter uma particular atenção a este que são a coexistência das desigualdades, também nas desigualdades de género, e falou-nos, por exemplo, nos resultados do último relatório do PISA, que de uma forma alarmante mostra que na Europa, de uma forma geral, e também, portanto, em Portugal, por exemplo, cerca de 45% das raparigas aos 15 anos com mais talento escolhem a área da saúde e 45% dos rapazes nessa idade escolhem as áreas das tecnologias, que têm hoje um potencial de valorização económica totalmente diferente de algumas tecnologias da saúde, e por isso esta construção destes estereótipos no âmbito da sociedade que nós vivemos são particularmente um alerta que temos de chamar a atenção no contexto da crise que hoje emerge. Para isso, a Mariana chamou a atenção das ciências sociais e da transdisciplinaridade hoje do conhecimento e mais do que nunca, ela chamava a atenção para algum relativo isolamento social das próprias cientistas sociais face às outras áreas da ciência, quer das ciências da vida, quer das ciências da engenharia, que devido à sua relação com a economia tem-se aberto mais às empresas e à opinião pública versus às ciências sociais. E, portanto, a presença da transdisciplinaridade, mas também do conhecimento científico entre várias áreas ficou bem claro. Foi assim, neste contexto, que após a sessão inicial tentámos abordar esta conferência sobre a liderança de dois comissários, a Helena Canhão, médica da Nova Medical School, e o Pedro Oliveira, engenheiro naval, mas hoje que trabalha sobretudo em inovação, entre Lisboa e Copenhague, que nos puseram um programa particularmente interessante e desde já reconheço e agradeço mais uma vez ao trabalho dos dois comissários que ao longo do último ano mudaram tantas vezes a programação da conferência e acabámos por chegar a um programa, certamente da sua autoria, centrado nas principais prioridades da presença portuguesa na União Europeia num período covidiano, diria. Deve ser dito que a Helena e o Pedro dirigem hoje um movimento a nível do mundo, o Patient Innovation, a inovação pelos pacientes, que tem trazido de uma forma particularmente astuta a forma como, ou as diferentes formas de promover a inovação, sobretudo como hoje se pode inovar também pelos utilizadores e, sobretudo, aqueles que são, neste caso, que eles estudam os doentes, sobretudo doentes afetos por doenças raras, que podem passar ideias e, por isso, eles construíram hoje uma plataforma a nível mundial para ajudar, sobretudo, doentes das mais variadas áreas, do reumatismo ao cancro, das artroides, à locomoção e à mobilidade de muitas pessoas, para poder transmitir formas inovadoras que podem chegar a curar e a mudar vidas. E este tema que a ciência cura e que o conhecimento tem várias formas de poder ser usado, foi particularmente central a toda a reunião. Mas, como disse, foi particularmente focado naquilo que temos que olhar para Portugal num contexto europeu, de uma forma que sabemos que a ciência pode ajudar e deve ajudar a recuperar Portugal, mas sempre com mais Europa. Para isso, ontem, a Comissária Europeia, Elisa Ferreira, falou-nos sobre a resiliência e a necessidade que a crise também mostrou de encurtar cadeias de valor e de construir um projeto europeu menos dependente do exterior. Por exemplo, ela referiu que a indústria farmacêutica na Europa depende, em termos de matérias-primas, 80% de importações da Ásia. E foi nesse contexto que também o ministro Pedro Cisa Vieira falou-nos sobre a necessidade de articularmos a capacidade científica portuguesa com a capacidade empresarial, desenvolvendo agendas de industrialização e inovação que tenham, obviamente, o potencial de podermos criar valor, ao mesmo tempo que criamos mais e melhores empregos. Devo dizer que hoje o Bob Langer, talvez o engenheiro mais citado a nível do mundo e o diretor do principal laboratório de biotecnologia a nível do mundo, que tem tido ao longo dos últimos 10 a 15 anos acolhido muitos investigadores portugueses, deu-nos exemplos de alterações radicais na forma de pensar e da necessidade clara dos cientistas insistirem naquilo que são as boas ideias, e ele falou-nos, por exemplo, da forma como os biomateriais podem ser usados para a cura do cancro, mesmo num contexto regulatório particularmente adverso, e por isso é preciso insistir em certas boas ideias, porque faz parte hoje de saber ser cientista, de ser persistente naquilo que podem ser as boas ideias. Certamente que, para além da resiliência europeia, e, portanto, que não é necessariamente o caminho mais fácil, mas é um caminho que tem que ser insistido, ficou claro a necessidade de uma Europa mais digital e das oportunidades da digitalização que hoje são oferecidas às sociedades e às economias. Ontem, por exemplo, Pedro Ferreira, um investigador português na Universidade de Carnegie Mellon, mostrou bem o que, durante a pandemia, a forma como está a ser possível evoluir nos mecanismos de aprendizagem e de ensino e aprendizagem à distância, de uma forma que é possível hoje detectar cada vez melhor a forma como o aprendiz está atento ou não e está a captar aquilo que um mestre pode estar do outro lado do ecrã. E mostrou-nos, mais uma vez, que isto requer também cada vez uma maior responsabilidade social dos docentes e dos mestres a perceberem não apenas aquilo que estão a dizer, mas o que os outros estão a ouvir. E esta será, porventura, um dos principais desafios da evolução e da modernização dos sistemas de ensino-aprendizagem numa época mais digital. Não basta pôr conteúdos online, não basta disponibilizar e participar horas em Zooms, é preciso perceber o que os outros nos ouvem. E até que ponto é que a evolução tecnológica permite isso, ficou bem claro ontem nos desafios que estamos, mas também nas oportunidades que estão a ocorrer. Já também nessa fase, o Rui Oliveira, diretor do INESC-TEC, foi o principal responsável por, em Portugal, desenvolver a aplicação Stay Covid, mostrou-nos bem a responsabilidade que também os cientistas hoje têm, e ele é um caso claro, em tentar garantir a privacidade da informação numa aplicação que hoje está a ser usada de uma forma cada vez mais massiva mas para ser usada de uma forma massiva tem que, certamente, garantir condições de privacidade. Foi curioso ver que a capacidade de uma instituição portuguesa, como o INESC-TEC, de desenvolver essa parceria, não pareceu do zero. É o resultado de 20 anos de trabalho nessa instituição, de um grupo hoje líder a nível europeu, sobre formas não apenas de supercomputação avançada, mas formas de reunir segurança no espaço, no ciberespaço, em condições aonde temos que certamente garantir a privacidade da informação. E essa área científica, que hoje está desenvolvida em Portugal, foi obviamente a razão pela qual o INESC-TEC conseguiu desenvolver, com um conjunto de empresas à sua volta, uma aplicação. Mas ainda ontem, também no contexto da digitalização, ficou bem claro que aquilo que hoje o Pedro Conceição referia sobre a necessidade de estarmos no antropoceno e, portanto, de observarmos para o planeta, de observarmos o planeta Terra face à nossa atividade económica, só será possível com mais e melhor informação por satélite, que é a única forma de olharmos com resolução espacial e temporal àquilo que se passa nas nossas sociedades e economias. E por isso, Miguel Belo, o diretor do Centro Internacional de Investigação do Atlântico, com sede nos Açores, mas em estreita cooperação internacional, mostrou bem os desenvolvimentos recentes para que também em Portugal tenhamos acesso a uma constelação de novos satélites e informação que hoje é perfeitamente crítica para melhor compreendermos aonde estamos e aonde queremos estar. Mas, naturalmente, não há uma Europa mais resiliente, nem há mais ciência para ter uma Europa mais digital, se não for compreendido que essa Europa tem que ser sempre mais verde. O Ministro do Ambiente, João Pedro Matos Fernandes, ontem foi claríssimo a dizer que a questão que se põe é que o período pós-Covid não pode ser igual ao período antes-Covid e a única solução é entrar num trajeto claro de descarbonização. Foi curioso que ele falou a seguir à Susana Abrantes, da Universidade de Aveiro, ter demonstrado que durante a crise a qualidade do ar melhorou. E a questão que ele pôs é que não basta hoje termos esta evidência. Temos que garantir que após a crise pandémica a qualidade do ar não é deteriorada. E isso implica que tenhamos que usar processos distintos daqueles processos que hoje usamos, e ele falou o exemplo do atual desenvolvimento em Portugal com dois gases que são perfeitamente críticos para Portugal e para a Europa ser mais que verde. Por um lado, os gases de biomassa e, por outro lado, o hidrogénio. Entrar numa economia do hidrogénio, evitando a queima de carbono, parece fácil no papel, mas obviamente exige um conhecimento científico que hoje não temos. Não temos em Portugal, não temos na Europa e não temos no mundo. Por um lado, não sabemos o suficiente da química do hidrogénio, mas também não sabemos o suficiente sobre, eventualmente, fontes biogénicas de hidrogénio, nem sabemos ainda o necessário para poder, de uma forma rápida, desenvolver os catalisadores ou os eletrolisadores para poder usar de uma forma eficiente o hidrogénio com a segurança necessária. E por isso o Ministro do Ambiente foi tão claro em chamar-nos a atenção que o percurso para a neutralidade carbónica só pode ser feito com mais conhecimento, certamente com novas ideias e com a sua aplicação. Nessa mesma sessão, a Inês Azevedo, da Universidade de Stanford, uma portuguesa engenheira do ambiente, foi clara ao demonstrar, com trabalho novo, também feito com investigadores portugueses, que o principal causa do aumento de CO2 na atmosfera está a ser, neste momento, e será nos próximos anos, se nada for feito, a agricultura. Ela mostrou como, sobretudo nos Estados Unidos, mas também na Europa, o desenvolvimento de novas soluções técnicas possibilitaram uma redução efetiva das emissões de gases de estudo, quer na área da queima de combustíveis sólidos, quer no transporte, sobretudo com a eletrificação da mobilidade, mas também na área da indústria. A única exceção, quer nos Estados Unidos, quer na Europa, e sobretudo na Europa, que não tem reduzido a sua contribuição para os gases de estufa, é a agricultura. E depois o Prémio Nobel Richard Roberts, Prémio Nobel da Medicina em 1993, foi particularmente claro a chamar-nos a atenção para aquilo que é hoje o movimento de 156 Prémios Nobel, dizendo que a questão de uma agricultura verde na Europa e no mundo, em associação com aquilo que é a redução da fome nos países em desenvolvimento, só poderá ser possível se a agricultura envolver também na Europa mais ciência. E trouxe-nos, de uma forma particularmente provocadora, a necessidade de percebermos, efetivamente, a introdução no mercado, também na Europa, de alimentos e mecanismos geneticamente modificados. Sabemos que os grandes monopólios agrícolas europeus, particularmente em França e na Alemanha, têm-se oposto a essa introdução, e ele hoje lidera um movimento de, como disse, 156 prémios Nobel que estão a tentar demonstrar que é a única forma de combater, por um lado, a fome, mas também reduzir de uma forma clara a emissão de gases de estufa decorrentes da operação ou da atividade agrícola que hoje fazemos de uma forma sistemática na Europa. E trouxe casos do Paquistão à Índia e, certamente, aos Estados Unidos da América. É neste contexto que depois abordámos a questão como é que Portugal contribui para uma Europa mais global. E o Ministro Augusto Santos Silva foi particularmente astuto a identificar hoje o posicionamento de Portugal e, necessariamente, a presença portuguesa da União Europeia a demonstrar que é através da globalização da ciência que Portugal tem adquirido um melhor posicionamento. Referiu-nos 3 casos típicos. Por um lado, a alteração radical da cooperação bilateral entre Portugal e Espanha através da instalação, desde há 10 anos atrás, do Instituto de Nanotecnologias de Braga, que hoje é uma forma clara de mostrar como é que a ciência mudou a relação bilateral entre 2 países, mas também mostrou, de uma forma clara, como é que as parcerias entre a comunidade científica portuguesa e as principais universidades norte-americanas, nomeadamente os programas com o MIT, com a Universidade de Carnegie Mellon e a Universidade de Austin, mudaram radicalmente o posicionamento de Portugal na Europa e as relações externas entre Portugal e os Estados Unidos da América, incluindo o reconhecimento americano pelo papel de Portugal na Europa. E falou-nos ainda sobre o movimento que estamos em curso de cooperação em língua portuguesa e a instalação em Portugal do chamado Centro Ciência LP, Ciência Língua Portuguesa, de uma forma para que tem facilitado, gradual, sistemática, complexa, difícil, mas em ação, a cooperação com os países de língua portuguesa. Deu o exemplo também da triangulação com outras instituições e tivemos aqui connosco o presidente da Universidade HK, que viajou do Paquistão para Portugal, porque também vê em Portugal uma forma de, eventualmente, se instalarmos aqui novos estudos sobre as sociedades islâmicas e muçulmanas em particular, para além daquilo que já estamos a fazer com a Fundação HK nos países de língua portuguesa. O reitor da Universidade HK, Firoz Razul, foi particularmente crítico em comparar o que se vive no contexto social europeu daquilo que se vive no contexto social, sobretudo de sociedades muçulmanas, e apontou os casos da Índia, do Paquistão, mas também em algumas sociedades muçulmanas em África. E isto leva-nos, mais uma vez, à questão crítica que a Inês Azevedo de Stanford já tinha introduzido no primeiro dia, que não é possível pensar na ciência como uma evolução global sem perceber as condições da justiça social de acesso à ciência. E isto, obviamente, tendo nós um Presidente da República jurista, é particularmente importante perceber esta transdisciplinaridade do conhecimento, mas também na esfera da justiça e, nesse caso concreto, a Inês apontou os impactos negativos, sobretudo em número de mortos, que estão a ocorrer para além do Covid, sobretudo em associação aos efeitos da poluição e da desigualdade do impacto da poluição em diferentes tipos de sociedades. É por isso que volto a chamar a atenção para aquilo que o Prémio Nobel Aaron Shishner disse-nos no primeiro dia. Não pensem que a ciência e que a relação da ciência com a sociedade é algo que está a ganho. Não está a ganho. E hoje vivemos em Portugal, penso eu, um movimento positivo, aquilo que eu chamaria o resultado do efeito ciência viva, de insistirmos na cultura científica, como o Pedro Conceição tão bem demonstrou hoje ao nível das Nações Unidas. Mas, ao mesmo tempo, coexistem no mundo sociedades onde, efetivamente, a adversidade à ciência e ao conhecimento científico está a crescer. Veja-se o caso do Brasil, veja-se o caso dos Estados Unidos da América e muitos dos exemplos em países asiáticos. É por isso que a razão de ser europeu e dos valores europeus são tão importantes hoje no mundo em termos daquilo que é o papel da ciência. Por isso, deixem-me acabar com 5 fatores que já referi no primeiro dia, mas que nunca são tardes de referir. Hoje, onde é que nós estamos e onde é que nós queremos estar daqui a 10 anos? E este debate, que temos tido a oportunidade de fazer com alguns cientistas e também com a presença do Presidente da República, tem sido particularmente importante para nos percebermos posicionar, sobretudo face aos outros, e estarmos sempre a comparar, aprendendo mais. Primeiro, no investimento em ciência. Nos últimos 5 anos, Portugal experimentou um aumento continuado e uma aproximação daquilo que é a Europa do conhecimento. A despesa global em investigação e desenvolvimento aumentou mais de 35%, passou de 1,2% da riqueza gerada para 1,4%. A estimativa é que este ano, 2020, atinja 1,6%. E isto foi feito, entre muitos outros aspectos, aumentando significativamente a dotação da FCT, que em 2015 era cerca de 380 milhões de euros, e nos últimos 2 anos ultrapassou os 500 milhões de euros. Mais que duplicámos o número de bolsas de doutoramento. Passaram de cerca de 900 para mais de 2.000. Fizemos e introduzimos em Portugal a noção do emprego científico com mais de 6.000 contratos. E se isso nos deve orgulhar, não chega. É preciso fazer mais e, por isso, estamos a delinear uma trajetória para chegarmos a 2030 com 3% da riqueza gerada investida em investigação, 1/3 pelo setor público, 2/3 pelo setor privado, e sabemos os desafios que se associam a isso, particularmente entrarmos numa época onde conseguimos, de uma forma sistemática e gradual, criar mais de 2.000 empregos qualificados por ano no setor empresarial. Vai implicar Portugal crescer durante 15 anos sucessivos no investimento na ciência que nunca soubemos experimentar em Portugal. Mas também no ensino superior. Se é verdade que este movimento de confiança dos portugueses, das famílias portuguesas no conhecimento, se transmitiu e se manifestou, sobretudo, num aumento inédito do acesso ao ensino superior, que este ano experimentámos números nunca vistos na sociedade portuguesa, acompanhado também da abertura do ensino profissional, temos que garantir agora que os próximos anos são anos que continua a crescer o acesso, mas a reduzir o abandono ao ensino superior em Portugal e em todos os países da Europa. O ano passado assinámos um contrato de assinatura, na sequência daquilo que já tínhamos feito em 2016 com todas as instituições, e de uma forma inédita temos cumprido um aumento de 2% das dotações do ensino superior. Mas se é verdade que isto foi feito, a questão é que não chega. E não chega porque hoje, e ficou bem claro ontem também, que a pandemia trouxe-nos novos desafios e novas oportunidades para o ensino-aprendizagem, em particular a associação com aquilo que são a diversificação das formas de ensinar e de aprender, as formações curtas, em complemento com as formações complementares, a abertura das formações curtas iniciais, mas cada vez mais das pós-graduações, e as empresas que aqui tiveram ontem, sobretudo no mundo digital, pediram mais e melhor formação, mas também uma formação diferente, sempre a ser atualizada. Certamente, o terceiro ponto é o da inovação. Se é verdade que este ano Portugal foi pela primeira vez classificado como um país fortemente inovador, sobretudo associado à capacidade empreendedora das nossas pequenas e médias empresas num contexto europeu, sabemos que esse esforço tem que ser continuado na próxima década e, por isso, lançamos os laboratórios colaborativos, lançamos os programas mobilizadores com a indústria, sempre com a liderança das empresas ou da administração pública, mas sabemos, mais uma vez, que a questão crítica é, no nosso ecossistema inovador, sobretudo assente em muitas pequenas empresas, é preciso que essas, ou algumas delas, consigam crescer e, por isso, ter um impacto claro no emprego. E, portanto, o desafio de continuar a fazer sempre mais e melhor só pode ser feito se nos estivermos sempre a comparar e a fazer mais e melhor. E, para fazer mais e melhor na ciência e na inovação, temos que garantir melhores empregos e, por isso, nos últimos anos, lançámos o desafio também às instituições de ensino superior de desenvolverem melhores carreiras científicas e académicas. Isso é verdade que foram criados mais de 6.000 contratos de investigador desde 2017 e que, no último ano, foram feitas mais de 1.000 progressões nas instituições de ensino superior. Não chega mais uma vez. Na próxima década temos que fazer muito mais para poder continuar esta trajetória de credibilização da ciência que só se faz com melhores carreiras científicas. Por fim, o quinto desafio que temos discutido com muitos de vós é o da simplificação. Temos claramente que continuar a simplificar. Nos últimos anos conseguimos garantir a periodicidade de todos os financiamentos e de concursos da FCT, mas também sabemos que hoje temos ainda um sistema burocrático e de complexidade em todo o sistema, dentro das próprias instituições, que tem que ser simplificado para criar uma melhor relação de confiança. E por isso esta conferência deve nos encher de coragem, pelo trajeto que estamos a ter, mas também de uma extraordinária humildade para podermos fazer muito mais e melhor nos próximos anos e, para isso, certamente, passo a palavra ao Presidente da República, do que melhor do que ninguém pode fechar este encontro. Muito obrigado, Sr. Presidente.
É bom. Sr. Ministro da Ciência, Tecnologia e Ensino Superior, ilustres oradores de hoje, pude acompanhar apenas a sessão final e saudaria, em particular, a senhora professora Elvira Fortunato e o Dr. Pedro Conceição. Quero saudar todos os oradores, estrangeiros e portugueses, sublinhar a presença massiva do Governo nos vários painéis e sessões plenárias, cumprimentar a organização, felicitar os premiados e dirigir uma saudação genérica a todos aqueles que acompanham e acompanharam horas a fio, de uma forma enriquecedora, uma iniciativa que é tudo menos uma rotina. Peço desculpa por não estar convosco, fisicamente, mas tinham hoje compromissos no que respeita a parceiros económicos e sociais a receber, por causa da declaração de estado de emergência. Há cerca de um mês e meio, tive a oportunidade de manter um diálogo com a presença do Sr. Ministro da Ciência, do Sr. Ministro de Estado e da Economia e de um grupo de cientistas, parte do qual subscritor de um manifesto, apelando a um diálogo como o diálogo destes encontros. Ano após ano, tenho estado nos encontros. E estes encontros são tudo menos uma rotina. O deste ano é decididamente tudo menos uma rotina. Por causa da pandemia e por causa da crise económica e social que já vivemos. É uma oportunidade, foi dito, e eu acompanho os que disseram que era uma oportunidade. É uma oportunidade com riscos. É uma oportunidade porquê? É uma oportunidade porque aproximou ainda mais a comunidade científica portuguesa. Por estranho que pareça, o digital aproximou-nos. É uma oportunidade porque aproximou Portugal ainda mais da Europa e do mundo. Devemos olhar para a Europa, mas devemos, em termos de ciência, olhar para o mundo. Aproximou mais a ciência e os cientistas da academia, a ciência e os cientistas da sociedade, a ciência e os cientistas da vida empresarial, a ciência e os cientistas dos poderes públicos. Nem sempre o diálogo entre eles é fluido e houve essa aproximação. É uma oportunidade porque abre caminho para avanços e inovações, e disso falou o Sr. Primeiro-Ministro, no domínio das ciências da vida, das causas das pandemias e noutros domínios científicos. Também porque chamou a atenção para as desigualdades sociais. Dizia o Sr. Ministro isso mesmo há pouco, as desigualdades sociais são um dos traços mais negativos desta pandemia. Mas ao lado das oportunidades há riscos. Eu estava a ouvir-vos, estava a tomar apontamento sobre algumas reflexões que tenho feito acerca dos riscos que esta pandemia de alguma maneira revelou, trouxe à superfície relativamente à ciência e relativamente à ciência e as suas conexões com a política e a sociedade. Um primeiro risco tem a ver com o tempo. O tempo. Esta pandemia está a demorar muito mais tempo do que se pensava. E é imprevisível a evolução. A evolução este ano e a evolução no ano futuro, no ano próximo. E é mais imprevisível o conjunto de efeitos desta pandemia. Eu estava, precisamente hoje, a olhar para um estudo que saiu este ano, Pandemics Depress the Economy, Public Health Interventions Do Not, Evidence from the 1918 Flu, de Sérgio Correia, Stephen Luck e Emil Werner. E eles, analisando a gripe espanhola, chegaram à conclusão de que os efeitos de uma pandemia, em termos económicos e sociais, são muito mais profundos do que os efeitos associados aos ciclos económicos e sociais. São mais duradouros. Não é por acaso que o Fundo Monetário Internacional fala na recuperação de algumas das mais importantes economias europeias em 2023-24, e são muito mais fundos em termos de desigualdades sociais. E, portanto, isso coloca um problema, é uma oportunidade, mas é ao mesmo tempo um problema aos cientistas. Este tempo duradouro, apesar da importância do digital, apesar das redes que se mantiveram e se desenvolveram, apesar dos passos dados em tão pouco tempo na investigação de fármacos e de vacinas, o tempo é um desafio que se vai colocar nos efeitos negativos da pandemia para todos, mas também para os cientistas. O segundo risco tem a ver com a relação entre os cientistas e os políticos. Não é muito fácil de estabelecer a delimitação de fronteiras ao longo desta pandemia. Quem acompanhou, por exemplo, as sessões epidemiológicas realizadas e que reuniam cientistas, epidemiologistas, sanitaristas e decisores políticos, parlamentares, governantes, o Presidente da República, parceiros económicos e sociais, pôde perceber, como pôde perceber em vários momentos da comunicação dos poderes públicos sobre a pandemia, com a participação de cientistas, como da ótica dos destinatários da comunicação, nem sempre foi clara a delimitação de fronteiras entre o papel dos cientistas e o papel dos decisores políticos. Porque os cientistas naturalmente foram chamados a formular propostas e sugestões para a decisão política, porque os políticos algumas vezes socorreram dos cientistas para abonarem as suas decisões ou para justificarem a posteriori atuações ou omissões. E este é um problema sensível, que é um problema não apenas de ética, mas também de compreensão do relacionamento em momentos críticos, como foi esta pandemia, como está a ser esta pandemia, entre quem decide politicamente, quem estuda e aconselha cientificamente. É um problema este recorrente, é um problema muito complexo nas suas vertentes e é um problema tanto mais complexo quanto as solicitações forem diárias, semanais, mensais, ao longo de um período indeterminado de tempo. Isto é agravado com o problema da comunicação. Porque a comunicação científica é uma coisa, a comunicação política é outra coisa, e a comunicação social incidindo sobre ambas é uma terceira realidade. E a junção das três realidades ao longo da pandemia, que houve, que existe e que existirá em Portugal como em inúmeros países da Europa e do mundo, e estou a pensar nomeadamente em democracias, onde o tema tem maior acuidade, suscita problemas complexos, muito complexos. Basta colocarmos-nos na posição de quem recebe a comunicação. Como é que interpreta a comunicação? Como é que ela é percepcionada, a comunicação científica, a comunicação política e a comunicação social sobre as duas, juntando eventualmente uma e outra. Isto suscita problemas, sobretudo em sociedades que vivem momentos não racionais, não necessariamente racionais. Durante uma pandemia, múltiplos momentos são essencialmente emocionais, para não dizer irracionais. E as percepções são emocionais. Sobre dados científicos, sobre comunicações científicas, sobre decisões políticas, sobre fundamentações científicas de decisões políticas e sobre o seu tratamento pela comunicação social. Temos, portanto, um tempo que continua, um tempo riquíssimo de oportunidades para os cientistas, riquíssimo, por exemplo, de oportunidades para o entrelaçamento entre as ciências sociais e as outras ciências, porque as ciências sociais, por exemplo, a sociologia ou a psicologia, podem ajudar a analisar a complexidade destas várias comunicações e da inter-relação entre cientistas e políticos. Mas eu penso que, ao fim e ao cabo, são mais as oportunidades do que os riscos. São muitíssimo mais relevantes essas oportunidades. E se nós encadearmos aquilo que disse o Sr. Ministro sobre o que se pretende para Portugal em termos de ciência e o que está subjacente à sua intervenção, que é como que um compromisso não apenas implícito, mas explícito, de maior aposta em políticas públicas na ciência, em termos de investimento público, em termos de percentagem do produto interno bruto, em termos de qualidade do investimento, então, de facto, podemos dizer que estes encontros e este encontro em plena pandemia são uma grande oportunidade para acento tónico nestes compromissos. E eu terminaria dizendo apenas que ao longo da pandemia tenho sentido que só há verdadeiramente avanço científico se houver numa sociedade abertura ao universal. O multilateralismo é fundamental à ciência. O unilateralismo, o isolacionismo, o hipernacionalismo são a negação do espírito científico. Segundo lugar, se houver atenção à coesão social. Isto é, o avanço científico é tanto maior quanto menores forem as desigualdades sociais numa comunidade. Terceiro, e aqui foi dito, a criação e o desenvolvimento de uma mentalidade científica. Quarto, liberdade. Não há ciência sem liberdade. Quinto, razão. Razão que não impede a inteligência emocional e o seu contributo na ciência, mas que impede a irracionalidade em tantos momentos das sociedades contemporâneas. O avanço da ciência passa pela afirmação do primado da razão, da liberdade e da razão. Sei o que a criação de mentalidade científica, a sua radicação, o seu progresso é mais difícil. Vivemos hoje, em diversas sociedades democráticas, momentos de irracionalidade. E esses momentos não são fecundos para o avanço da ciência. É esse o meu apelo final. Que no nosso país, como na Europa, como um pouco por todas as democracias, possamos assistir no presente e no futuro próximo ao triunfo do multilateralismo, da abertura, do aprofundamento da mentalidade científica, da preocupação com a coesão social, com a afirmação da liberdade e com o primado da razão. Se assim for, então vós, cientistas, nós, cientistas, teremos outros horizontes e será mais fácil compreender porque é que é preciso apostar em políticas públicas da ciência. Muito obrigado, felicito-vos por este encontro, que é mais um passo no sentido da chamada de atenção para a ciência em Portugal.